Hello everyone, welcome to this lecture. Today we are going to do one short GOC, that is the first chapter of organic chemistry, general organic chemistry. First thing that we are going to begin today, it's straightforward. Let's go to a topic. Let's see the huge chapter. Okay. So the first thing that we are going to do is the IUPAC nomenclature. The first part, that's a part which you have already done in your previous classes as well. So let us discuss about the IUPAC nomenclature. I won't be saying like the rules and all. I will be telling you what to do and what not to do through questions directly. Then rules also will be done and the practice also will be done. Okay. So first of all is the basic thing about IUPAC nomenclature. What is that? That means how will you write a name? Your name has a first name, middle name, surname. Right. Similarly, a compound also has its own name. Like it can have a first name, middle name, and last name. Right? Right. Last name is compulsory for this function. This IUPAC names. Right? For a compound, the last name needs to be there. Has to be there. There has to be a last name, and this last name is nothing but word root. Okay. Suffix will be there along with the last name, right? So what is the basic format? Basic format is you write a prefix followed by a word root which is further followed by a suffix, right? Under prefix you have two types of prefix: 1 degree prefix, 2 degree prefix. Under 1 degree prefix, first let me talk about 2 degree, cyclo or bicycle or spiro, whatever you all know. This is generally not done. Cyclo part will come, nothing else will come. Okay. And another one is the prefixes. The prefixes of the general functional groups, right? That I will discuss a little bit later. The prefix of the general functional group will come. Word root you already know. The number of carbon atom that is present is called the word root. And the suffix also we are having 1 degree, 2 degree suffix. 1 degree suffix indicates n, in, or ein. Is a basic group, while 2 degree suffix indicates again the functional group. Functional group. Clear? 2 degree suffix will be the functional group. Why is 2 degree functional in case of suffix but 1 degree in case of prefix? The reason is very simple. When you will be writing the name, example we will get to see it later. When you will be writing the name, you won't be writing cyclohexane aldehyde, no, or methyl, or cyclohexane methyl, no, you will writing methyl cyclohexane. So the word methyl automatically comes before. That is why the prefixes have been kept before. Okay, and in case of suffix, you will not write ol propane, no, it's propanol. So ol will go back. That is why it is 2 degree suffix, nothing more than that. Okay. So now let us discuss about some common functional groups which you are going to utilize in entire class 11 and in class 12. So chapters are only there of that. Many you know, I will be just telling you a few which you do not know. Which you know, you all know about alcohol, aldehyde, carboxylic acid, ester, ether. These all you know about. And haloalkane obviously. So that I will not tell you. Which things I will tell you is which is not known to you. Maybe it is not known to you. First one is this group. This is called a nitrile group. What is it called? Nitrile. This nitrile is nothing but a suffix. Okay. This nitrile is a suffix. So when this C triple bond N thing will be present, also will find it written as somewhere Cn. This single bond Cn and C triple bond N is both same. It is nitrile group. So whenever you find nitrile group, this group which you will have to write in the suffix nitrile. Only if it is a main functional group. Why main functional group? That also I will tell you. When I am going to talk about the rules of IUPAC. Nitrile. Now when this same group, nitrile group, is present as a polyfunctional, that is as secondary functional group, then it will not be called as nitrile. Then in that case you will be calling it as cyano. So this cyano is prefix. When it is not the main functional group, it is called cyano. One functional group can be primary, can be secondary. The primary one is the main one. Okay, always there is no need that only one functional group will be present in a compound. There can be more than one functional group. In that case, is a polyfunctional group. So in that case, one functional group gets priority, others will be used by their prefix. Done? So nitrile or cyano. Cyano prefix, nitrile is suffix. Okay? These are the important areas. Previously also, this is also an important area. Let's note down. Done. Next one. Next group is, somewhere if you find out a group like this. Now here always chlorine is not mandatory. It can be COPr as well. So I am not specifically highlighting chloride. I am writing X. X indicates a halide group. Okay, but not fluorine. Halide group, fluorine, no, not fluorine. Clear? So don't write FX. This fluorine won't be there. Why? So this group also you will find somewhere as written as COX or COCl mostly will find out. So this group is called acid chloride. What is this group called as? Acid chloride. Acid chloride. If there is chlorine, since I have not mentioned chlorine, so I will write acid halide. Acid halide. Clear? And this is also a suffix. So in the name you will be writing it as acid halide. Examples you will get to see a little bit later on. I will give you examples, so no need to worry about examples. So acid halide. Clear? This is when it is in the suffix format. Now what about when it is not in the suffix format? Then it is haloformine. What it is? Haloformine. Haloformine. This is the prefix. This will be used when it is not in the suffix, when it is a secondary functional group. Okay, in the main chain, when it will be a secondary functional group, then we are going to use the term haloformine. But when it is a main functional group, then we will be using the term acid halide to indicate the presence of this functional group. Clear? Okay. Next is amine. That is, you will get to see mostly NH2 only. So NH2 is amine. Clear? NH2 is amine. Writing amine. Amine means suffix. But when this is not the main functional group, then you are going to write amino. What you are going to write? Amino. And amino is the prefix. Very simple. Amine and amino. Then similarly, there is a brother of NH2. Who is the brother of NH2? The brother of NH2 is CONH2. CONH2. Many a times you will find out written it as this way also. This is called amide. What is it called? Amide. Clear or not clear? This is called amide. That was amine. This is AMINE and this is AMIDE. Amide. Clear? Amino, amide. Understood? Amine is NH2, but amide is C double bond ONH2. That means there is a carbonyl group attached. That carbonyl group was not there in that case. Understood? Any doubt till now? Any doubt till now? Any doubt till now? I don't think any doubt is there. Easy part. Now what about prefix? This is a suffix. This is a suffix. What about the prefix? It can be that it is not the main functional group. So in case it is not the main functional group, then what you are going to write? Then you are going to use the term carbamoyl. What are you going to use? Carbamoyl. This is the currently widely accepted term. Okay. Though amido is also one term. Amido. But you are not going to write amido. What you are going to write is carbamoyl only. Clear? So when it is in prefix, what you are going to use? Carbamoyl. When it is in suffix, you are going to use amide. Clear? When amine is in prefix, you are going to use amino. When amine is in suffix, you are going to use amine. Only amine. And this is amide. Clear? Understood? Okay, fine. Next, ester. Ester, I think you already know ester, so I am not discussing ester. Ester I will take up a little later. Later I will take up ester. Okay. Ester you already know, it's a COOR functional group, right? And it's written as alkyl alkanoate. Format you know. Prefix, when I am going to talk about the seniority table, then I will tell you about the prefixes there. Okay. Fine. Nitrile already discussed. Achha. This nitrile, you will find another person related to the nitrile. It is not really needed, but still I will say you. This person is C triple bond N 1% you will find is this. What is this? This is NC. Now you will think just CN or NC is the same. And what is the problem? Just C টাকে আগে লিখেছি, এখানে N টাকে আগে লিখেছি. So what is the difference between C and N? No, there is a difference. NC if you write that it is not this nitrile, then you have to write it is an isonitrile. What you have to write? It is an isonitrile. This is the suffix. And the prefix will become isocyano. So you can see the difference. Cyano, isocyano. Though isonitrile is not widely given in a question format, but still always you should know it. Who knows whenever it is when it will be given, right? So isonitrile is NC and nitrile is CN. Please be careful, because in many cases maybe the question will be given NC, you will think it as CN and you will write it as nitrate. Marks will not be given to you. Simple. Clear? NC clear? Now another one that you have new, that is acid anhydride. What is that acid anhydride? Acid anhydride is nothing but this something like this. Carboxylic acid derivative is this, nothing more than that. Carboxylic acid derivative, 2 carboxylic acid will form this. Basically 2 carboxylic acid will form this acid anhydride. Okay, this is called acid anhydride. This is called acid anhydride. Acid anhydride. No, don't write it like this. The name is acid anhydride. The name is acid anhydride. Okay. Since it is a carboxylic acid derivative, for carboxylic acid what is the suffix? Oic acid. So for this we will be using oic anhydride. Okay. For this we are going to use oic anhydride. Prefix you will not require at this level, so I am not giving the prefix, not needed. Okay, at this level prefix is not needed for acid anhydride. Okay, clear? The acid anhydride suffix is only needed, just be happy with the suffix. Clear? Okay. Another one let me tell you, that is also not really needed, but reaction mechanism it might be given. That is called thiol. SH. OH2 you know, alcohol. This is thiol. Thiol is nothing but O replaced by H. This is called thiol. What is it called as? Thiol. Okay, and represented also by thiol. Suffix is also thiol. Okay. Prefix also you will not require much. I am not giving that. The important ones I am giving. Why will you do everything and it will not come only? Clear? Till this much? Any doubts? Any doubts till this much? No doubts till this much? Very good. Just the suffix and the prefix they need to be memorized, because those are the important parts. Obviously you need to memorize it. Okay, so this part is clear to everyone. Very good. Next, let us move on to the IUPAC rules. To the IUPAC rules, let us move on. There whatever part will be needed, that I will be adding all over there. Okay. First, rules of IUPAC. The basic rules I will be talking about. Whatever else it will be required when we will be doing the questions, then I will be telling. Okay. Now, the basic rule that you have to follow is the longest chain rule. This you have to follow at any cost. Longest chain rule. In normal cases, if there is a functional group, then this rule might not be followed. But if it is without any sort of functional group, then you have to follow the longest chain rule. So hopefully you all already know what is longest chain rule. So what is longest chain rule? Longest chain rule is basically you have to select that parent chain which will have the maximum number of carbon atoms. Clear? If a functional group is present, then you have to choose in such a way that the main chain gets the primary functional group. Clear? Okay, understood? After this you will be having the maximum substituent rule. What rule? Max substituent rule. Maximum substituent rule. In some cases you will find that there are more than one chain which has the same number of carbon but different amount of substituents, then in that case you have to choose that chain which will have the maximum number of substituents and minimum number of complex chain. It's also a very important point. Okay, clear? So longest chain rule, max substituent. Another rule that you need to keep in care is the lowest locant rule, which everywhere you will be using this lowest locant rule. Especially in functional group, double bond, triple bond, this position, lowest locant rule is going to help you out. So lowest locant rule tells us that there should be lowest possible locant, means lowest possible position that should be given to the functional group, double bond, that is unsaturation, or functional groups. Clear? This locant means position. Okay, locant means position. Clear? So these are the three rules which you need to keep in your mind before you begin with IUPAC nomenclature. Then, now let us start with the discussion of the various types of problems that come up in the IUPAC nomenclatures. Let me take up a different pen. This is the question answer session. Okay, question. We'll be trying to figure out through questions what is going to be the case. Okay, so let's take up one question. Let's check. This is the question. What is our first thing we need to do? The first thing we need to do is we need to check out for the main chain. The first and the foremost thing we need to do. So tell me, is the main chain going to be in this order? If I go in this order, then what is this part called? Does not have a name. You will ask what is the name? There is no name for this. If you have a benzene, there is a benzyl alcohol, there is a different thing. But this is nothing. What will I write? It's nothing. Then I have to name it as a complex chain. Then that will become a complex chain. Right? That I cannot do. So this is not correct. Okay? This way of numbering is not correct. Clear? Why? Because in the rule only I have said that the main chain must contain the functional group as well. Let me write it over here. Must have functional group. Which functional group? The primary functional group. Okay, the primary functional group must be there. And primary has to be there. Clear? So this numbering is not a correct numbering. So what is going to be the correct numbering? That also we need to know. So there is no the correct numbering. So we will get this. Just a minute. What is the correct numbering we need to know? If it is like this, the entire thing will be used. So now what is going to be the correct numbering? The correct numbering will be starting from here. Right? Because I have to keep the functional group in the main chain. So to keep the functional group in the main chain, even if the longest chain rule which was possible from this side, this part could have been the main chain, but we cannot consider that due to the functional group reasons. Clear or not clear? So the name won't be whatever you have put. The name is going to be what? The name is going to be 2. This is called ethyl group. This is nothing but ethyl group. So 2-ethyl. For 4 carbon, we use the term but. So but. N or in? Only N. So AN. All. Now, Position 1 you can specify, you cannot specify. Now few points that you need to note down from this part. Few points you need to make a note of from this part. What are the parts? Let me jot it down over here. Point number 1. N in I. E is dropped if followed by a vowel. If followed by a vowel. What does this mean? Right, there might be a question. What does this mean? This means that if the functional group's suffix begins with a vowel, then this ends E, ins E and ins E will be dropped. For example, you find out over here. I have not written butanol. No, it's butanol. Okay, the E of this butane has been dropped off. So it's butanol, not butaniol. That's not a word. Clear? This is one case. Understood? Why are we writing that? Right? Achha. Secondly, the word root table. That is why did I write butane not a fault. Though you all know this, why have I written butane, but still I'll just mention it once. Okay, if there is one carbon present, you use a meth. If there is two carbon present, you use it. If there is 3 carbon present, you use prop. If there is 4 carbon, you use but. You use 5 carbon, you use pent. 6 carbon, you use hect. 7, you use hept. This here you make a note. Here you make a note. Not sept. Okay. Sept you will not use. Sept you will use in the IUPAC nomenclature of inorganic, not organic. Okay. So make a note. 8 carbon you will use oct. 9 carbon you will use non. 10 carbon you will use dec. Okay. Here also. This will also be a different one. N it will be. Okay. N in case of again inorganic. Leave it, no problem. This is the thing you to remember. Meet, eat, prop, but, pent, hex, hept, oct, non, dec. Done. This is class 10 level. But still I just told you. Okay. Next question. Let's go to the next question and understand the next concept. This is clear. Why did we take that? Understood? Okay. Another one. Next question. Let us take CH3, CH2, CH, CH2, OH, CH2, CH2, no, not CH2, one hand, no, CH2, okay, CH2 and let's take here CH. Now you tell me how to solve it, or whatever will be the name of this compound. What is going to be the name of this compound? Main chain. What is going to be the main chain? Can I consider 1, 2, 3, 4, 5? No. Reagent already told before. Reagent is here. The functional group must be in the main chain. So this is I cannot do. So this thing I cannot do. Then what will I do? Then I have to mark it from 1, 2, 3, 4. Right? Because I should give the functional group the lowest locant. Here I have given ethyl the lowest locant. I cannot start marking from this side because then the methyl will not get, then the alcohol will not get the least locant. I need to follow the least locant rule. So to follow the least locant rule, the OH must be given the smallest position. So smallest position is 1 or 4. 1. So I need to give 1 to alcohol. Right? Here also 1 I need to give to alcohol. Nothing else I will give 1. Clear? So starting from this side, numbering 1, 2, 3, 4. Done. Done. Now how to name this structure? Which structure? This structure. How to name this structure? This is a complex chain. Side chains, root chain. Complex chain. Complex chain numbering is done in a specific way. Okay? Complex chain numbering is done in a specific way, which I am writing over here. Understand it. For complex chain, you need to check out for that carbon. What you need to check out for? That carbon which is attached to the main chain. Which one will you take? you have to check for that carbon which is attached to the main chain. So spot the carbon attached to main chain. Carbon attached to main chain. Whichever carbon will be attached to the main chain. Main chain is this one. Main chain is this one. This carbon is attached to the main chain. So we have to spot that carbon. What you have to do? You have to spot that carbon. Next step. Take that carbon. What is that carbon? This step. Okay, from that step I am coming down. From that step only I am coming down. So I have written that carbon. What is that carbon? That carbon is the previous steps, whatever carbon you have found out. Take that carbon as locant 1, or that is not a very good language, so write that. Assign that carbon locant 1. From here only I am getting assign that carbon locant 1 and select longest possible chain. Then you are going to apply the normal chain rule. Normal longest chain rule. Clear? Say the longest chain. Simple. So here what you have to do is, you have to, this is the main chain done. Now main chain we are not thinking about, we are thinking about sub chain or the side chain. So taking this carbon as 1, this carbon becomes 2. Any more carbon there? No, this is not a carbon. So 1, 2, only 2 are possible, right? This is a separate numbering, this is a separate numbering. What you are going to do, the first step is you are going to see which carbon is attached to the main chain. That carbon you are going to take as 1. That carbon will be 1. Now using that you are going to do the next steps. So first step, you spot the carbon attached to main chain. Then assign that carbon locant 1 and select the longest possible chain. Okay, no doubt up to this. Next step, what will you do? Word root. How many number of carbon is present? How many number of carbon is present? Let us see here. How many number of carbon present? 2 carbon present. So what is the name for 2 carbon? The name for 2 carbon is ethane. Right? Wait. Will be complete, then I'll explain everything. Ethane. Since single bond is there. Ethane. Right? Now you see, to this ethane, we have 1 chloro attached. 1 chloro. Not the position I am mentioning. 1 chlorine I am talking about. So chloro is attached. To which position chloro is attached? Second carbon. So like normal way you write 2 chloroethane. Think that this part was not there. Then what would have written? 2 chloroethane. Right or wrong? Then you would have written 2 chloroethane. Think this part is not there. 2 chloroethane. No doubt about that. Right. 2 chloroethane. Now you tell me, you have a main chain as well. So for the main chain, it's another butane. So how it is possible that in one compound there is both ethane and butane existing? It is not possible. Think it very logically. Chemistry is logical. In one compound, it is not possible for ethane and butane to exist simultaneously. That can be a mixture, is a different thing. But in one compound, I am saying ethane as well as butane. That is not applicable. That is not acceptable. Yes. Why it will be acceptable? In one compound, 2 different elements cannot be present. There is only one thing present, either ethane or butane. 2 things cannot be there. Understanding it? 2 things is not possible. Like in physics you have done graph. In physics you have done graph. Distance versus time graph and distance versus time graph. There, if the graph passes to 2 points, that is not a existable graph. Why? Because at 2 points, to different time, distance cannot be seen. Something like that was there. Maybe I am wrong, but something like that was there with the velocity probability. Okay, so like this here also, in one compound there cannot be 2 ethane butane. So why to make that change? So the change that we will make is over N. What we will make? Over N. If it is a complex chain and you have to write the word root. Then you will not write N in that. What else you will write? I you will write. What you will write? Ethyl you will write. Clear? So if you are going to write the word root for complex chain, then you are not going to use N, or I. You are going to use ethyl. Like this. Now, what to do if there is a double bond? No, double bond structures will not come in class 11, but if it is coming by some chance, then it will be ethynyl. In will add, and will add, and we don't have generally. Generally, in 11 it will be thicker bond. But if it is by some chance, some case it comes double bond, then it will be in will be added, nothing else than that. Okay, but no way it will be E will not come. It will be ethynyl, but not ethene. Understood? So what is the next point that you need to write? The next point you need to write is word root equal to total carbon present. Right? Here, do not write in N, I. Instead, write I. Clear? Example given above, set properly. Done? Understood what to do? Next. This name 2-chloroethyl butane. Again, question can arise. Ethyl, but I cannot see ethyl in the structure. If I write like this, understand everything. If I write like this, where is ethyl? I cannot see the ethyl in the structure. Then why did I write ethyl? And if I do not write any position, that automatically makes it one position. But at position number 1 there is no ethyl. Then why did I write ethyl suddenly like that? And at 2 position no chloro is also there. At 2 position there is no chloro. At 2 position there is no chloro. At 1 position there is no ethyl. Then how come the name becomes 2-chloroethyl butane? How? How is it possible? So you have to justify that. So in order to justify that, we had to bring again another modification in the naming of complex root. What is that? Whenever you are naming a complex root, you should be writing that inside a bracket. Which bracket? Third, fourth, fifth, no. Only first bracket. Parenthesis. So this you must write inside this. Clear? Now this complex root is attached to which carbon? This complex root is attached to which carbon? Second carbon? Main chain. Now coming to main chain. To the main chains, which carbon is this entire complex root attached? Second carbon. So this will become 2 complex chain, then the original main. Understandable? Clear or not clear? Understand it. Because this is a very important thing. You have to give the bracket, otherwise I explain why if you do not give the bracket what will happen. Then where is the ethyl at first position? Teacher will search. Nothing is there. 2, no chloro is there. Why did you write without a bracket? So you have to give the bracket to distinguish it from the main chain. That is not a part of the main chain, but it's a part of the complex chain. Clear? So the next step we are going to write is enclose the complex chain in parenthesis. Sorry. By parenthesis, right? And mention its locant. Mention its locant. This is the complex chain naming rule. So you see, I have not given the rule at once. Once I have given only the main rules. The rest whatever rules will be coming, that I will be providing you with the question only. So it's easier for you to understand. With the question only it will be coming. I am not going to give you separately like rules and all. No. Separately I will not give you. Possibly I will show you a question. From that I will be giving you the rules also. And automatically next question also you can. Clear? Understood? Why this part? How it is happening? What did we do? Where did the name come from? It's all understandable. I hope so. Done? Oh. We'll take up our next question. Okay, let's take up the next question. Next type of question. Next type of question is here. Yes, what is going to be the name of this compound? What is going to be the name of this compound? What is going to be the name of this compound? Tell me. What is going to be the name of this compound? All the gyans are written below, okay? Just note down the gyans in your copies. Okay. Understandable? The previous two were understandable, I hope so. Now focus on this question. How to name this compound? First you have to number, and here numbering is not either straight chain or branched. Now how to understand? We will take up branch chain or we will take up straight chain. Very simple method is there. Think yourself to be here. Okay. Think you are here. Think you are standing over here. That is to go. Okay. You are standing there. You are standing there. Move. You move along the bond. Along the single bond, double bond, whatever is there. You move along. Okay, fine. Here I have only one route. Only one route I have. So fine, I am standing. Now I come here. Well, I have two routes. I can go this side or I can go this side. Which side I will get more rasta to travel? This side I will get more rasta or this side I will get more rasta? Think about here rasta. ঠিক আছে? দাঁড়িয়ে ছিল তুমি এখানে. These bonds are on rasta. You have to travel maximum rasta. What you have to do? You have to travel maximum rasta. So to travel maximum rasta, will you take this rasta or this rasta? Of course you will take this rasta. Fine. So that is not going to be a part of the main chain. If we are starting from this corner, that is also a fact. If we are starting from this corner, that is not going to be a part of the main chain. Well, fine. Now clear? I am now over here. Now where to go? Straight or here? Again the same question. This side more rasta, this side more rasta. This side. This side is more rasta. So I will go again this side. That. Now sorted. Now I am over here. Straight only I have to go. No other option. Now I am coming over here. Now here should I go this side or should I go this side or should I go this side? Then should I go this side, this up, straight or down? Anywhere I mean to go because both are same rasta. Right or not? See, this side also one carbon, up also one carbon, down also one carbon. So wherever I want to go I can go because all are one carbon one. All are one carbon. So let me choose just straight. No problem. You can choose below one also. So which chain I have chosen is the straight chain. I have chosen the straight chain. So now let's see how much number comes. Let's check the straight chain. So 1, 2, 3, 4, 5, 6. My straight chain has 6 carbon. Now any other way is it possible? That also you have to check it. That also you have to check. I started from this carbon. Someone wants to start from this carbon. Very good. It's a problem. If it is having 6 carbon, it will be accepted. Just check. 1, 2, 3, 4, 5, 6. No problem. If you want to start from here also you come. But ultimately the name will be same. If you number it properly, the name will be coming same. Clear? I have taken the straight chain. You can take the branch chain as well. You can start from this carbon as well. Clear, not clear? Okay. But the chain strength should be 6. Because 5 chain you cannot take. 5 you cannot take. Okay. Understandable? Right? Like you cannot start from this carbon. If you start from this carbon, then 1, 2, 3, 4, 5 it will become. That 5 is not possible because 6 is possible. 5 we cannot take. Clear? You have to be alert at which chain to take and which chain not to take. Okay? Clear? Suddenly this got erased. So this you cannot take. Region you already know. Right. So I have taken the state chain to be the main chain. Doubt sorted. Now numbering. Which side to number from? I have numbered from this side. Someone can say, let us number from this side. What is the big deal in that? And let us number from this side. Why not? Why not? Question can come. Let us number from this side. 1, 2, 3, 4, 5, 6. Which one to take? Here will come into play your lowest locant rule. It's the very, very important one I told you. In this type of cases, where this side numbering or this side, whichever gives you the lowest value, that you have to take. Okay. Let us check which one gives us the lowest value. First, let me take about this side. Okay. First, let me take about let me take from this side. So what is the locant? Second position something is present. Third position something is present. Fifth position two things are present. You can take 2, 5 or you can take 1, 5. Does not matter in that case. Okay. Okay. Now if you one case you are taking 1, 5, one case you are taking 2, 5, that is not accepted again. Either you take 1, 5 or you take 2, 5. That is your choice. Now, if I number from this side 1, 2, 3, 4, 5, 6, right? Now, here you also have to take 2, 2. Then don't take 1, 2 and say lowest locant. No. If you are taking 2, 5, then this case also have to take 2, 2. If you are taking 1, 5, there you have to take 2, 1, 2 here. One case you are taking 2, one case you are taking 1, that is not accepted. Then obviously some will come this. Right? Right. Okay. So, first position is 2 plus 2. Achha. Then is fourth position. Then is fifth position. Now you tell me, which case it is more closer? Tell me which is more closer. That means consecutive numbers in which case it is present. Consecutive numbers. First case, this case you see, 2 and 3 are consecutive. 5 is also more or less consecutive. Here 2 and 2 and then 4 and 5. In between 3 is missing. 3 is missing. So who will have a lower locant? This one will have a lower locant. You add and check, it will have a lower locant. First one gives you 15. This is 30. Clear? So whosoever will be having the lowest locant, you have to consider that person only. You have to consider that person only. Clear? Clear? Lowest locant rule clear? Understood? Lowest locant rule to apply. Lowest locant rule. I am doing once again. Second position, if I am numbering from this side, then 2, then 3, then 5. What is the sum? 10. If I am numbering from this side, then how much? 2 plus 4 plus 5. 11. Clear? So who is having greater? Why? Due to this person. Whosoever is going to be consecutive numbers are there means it is lowest. That this concept you have to use when you will be doing the aromatic compound or cyclic compound. There it is always not possible for you to write down the lowest. Then you have to see who is more consecutive, that is the lowest locant. Did you understand? 2 and 3 are consecutive positions. So they will be having the lowest locant. Clear or not clear? Tell me. Understood? This thing you can apply. Check it. If it is clear, then tell. Clear or not clear? Okay, take 1 because last time you took 2, the answer was coming wrong. Take 1 and 2. Okay, don't take 2 and 2. Take 1 and 2. Okay. Clear or not clear? Clear or not clear? Clear? No doubt? Nice. So what is going to be the name? The name. Acha. The main one is this one. Okay. I am highlighting this one. This is the correct numbering. Okay. This is the wrong numbering. I'm cutting it so that you don't mess it up. This is the wrong numbering. Okay. The correct numbering is from that side. Region is also given at the side. Not erasing this part. You just take it. Okay. Okay. So what is going to be the name? What is going to be the name? Right. 1, 2, 3, 4, 5, 6. So the name must consist of a hexane. Right? The name must contain a hexane because 6 carbon. Done. Now what about the methyl groups present? What about the methyl groups present? There are not only one methyl group is not present. There are many methyl groups. How many? 1, 2, 3, 4 methyl groups are present. Then what should we do for that? We don't know how to write 4 in organic chemistry. So there comes that yarn. If two alkyl groups are present, use the term di. What to use? Di. Similar thing. If 3 alkyl groups are present, try. 4 alkyl groups are present, tetra, and so on will continue. This is not only applicable for alkyl group but also for unsaturation. There may be 2 unsaturation present, there will be 2 functional groups, same 2 functional groups present. Then in that case also, if it is in the main chain, then you have to use di, tri, tetra. Please remember, this is applicable only if it is in the main chain. That also I am writing. Only if the group is present in the main chain. Okay. For complex chain, this is not used. Clear? For complex chain, this is not going to be used. Some other names are there that I will be telling you in that. Whenever we do that part, we will tell you. Okay? These are not counted. No, not counted will be wrong. Not considered during alphabetical sorting. This is a very important term. This is a very important. This di, tri, tetra, this you will not consider during alphabetical sorting. But why alphabetical sorting? Because you will need in many cases alphabets to sort out. Like if ethyl, methyl both are present, then what will you do? Then E will come before M. That I will tell you. When such questions come, I will tell you. Okay. Next question only is based on that. So there I will write. So these are not considered during alphabetical sorting. Clear? These you will not consider during alphabetical sorting. So whatever is the name of the alkyl group after this, like if dimethyl, then methyl we will consider, not di's D. Okay. So hexane is done. Now what about methyl? How many methyl? 1 methyl, 2, 3, 4. 4 methyl. So for 4, which term we are supposed to use? Tetra. So tetra. Alkyl group is methyl, so tetramethyl. What are the positions of the 4 methyls? Not 1. We will not mention 1. We have to mention all 4. So what are the position of the 4? You are having 2, 3, you are having 2, 3, 5, 5. Done. Clear? There are positions where you can do it. Now tell me, any doubt is there? Any doubt is there till now? Till now any doubt? 3 parts are written. The name I have to arrange now. The name I have to just arrange now. Any doubt? Any doubt regarding to this? No doubt? Very good. So, the first I have to place the position. So, this I have to bring it at the first. First part is this. Second part will be the name of this prefix that will come up over here. Accelerate to shift. So next is tetramethyl, which will come over here. Done. And at the end it will be hexane. Clear or not clear? Rules and all understood. But which rule you have to follow where? The rules is very important. Which rule you have to follow where? That rule is very important. Okay? Understood? Any doubt? Till now any doubt? No doubts? Any doubt? No doubt. Very good. Clear? Okay. Next question. Let us go to the next question. Let us proceed to the next question. So this question is clear to you that how we have written the name. I have explained to you step by step that how to write the name. Right? Oh, let's move on to the next question. Now you can see that before a question a gyan is there. Because this gyan was necessary before a question only. Okay. So what is the gyan precipitation? The gyan is, if there are two alkyl groups present, it is called di. You will use the term di. If 3, then tri, 4, tetra, 5, whatever it is, like that. So 5 won't be present. Okay. Maybe 5 won't be present. In most cases, 5 might be present. If it is present, then you will know what to use. Pent. Right? Done. This is not only applicable for alkyl, but also applicable for functional group. Okay. Even if two functional groups, they also will use di. Clear? Okay. So these are the case. Now you can see another point written. For complex chain, this is not used. If a complex chain is placed twice, in that case, we will not use the term di, tri, tetra. That I will tell you when this to be told, not now. Fine. Another gyan I have given you, that is, these are not considering alphabetical sorting. This will not require in this question, but in the next questions you will require it. Di, tri, tetra, this we will not, this D, T and T, this will not take into consideration when we are doing alphabetical sorting. Alphabetically when we are sorting, in that case we will not take this. Okay, what do you mean by alphabetical sorting? That I will get to know in the next few questions. Okay, so let us know what is the question. The question is CH3, C, CH3, CH2, CH3, CH, CH3, CH, CH3, CH. This is the question and you are supposed to write the IUPAC name. So what is the first thing we do? The first thing we do is selecting the main chain. Selecting the main chain. Now the question is, how to select the main chain? How to select the main chain? Let us proceed step by step. What you will assume is, you are standing here. You will assume you are standing here and your rasta is the bond. What is your rasta? Your rasta is the bond. Clear? Okay. So you are here. You travel through this rasta. You reach over here. Fine. Now you have two rastas. This rasta or this rasta. Now it all depends on you which rasta you want to choose. You want to choose this rasta or you want this rasta. But you have to choose that rasta which is going to travel for maximum. That means which will make you travel for maximum distance. Here your aim is to travel the maximum distance. Okay. তোমাকে সবথেকে বেশি রাস্তা চলতে হবে. That means you have to take that path which has the largest number of carbon. That is actually the longest path. So this path has one carbon that I will not take because this path has more than one carbon. So which path I will be going in? I will be going in this path. So I now come over here. Now I have two options again, here or here. Then again here is more carbon, this side is more carbon. So I will again walk towards this side. So now I am here. I have only one way, that is this way. So I will go this side only. So I am here. Now you see I have three ways. Either I can go this side, either I can go this side, or I can go this side. Which side to go? Every side leads me to only one carbon. So I can go either of the side. Now it's your choice which side you want to go. I will go with the straight chain. So now I am finally over here. So I have traveled from this end to this end. So this is my long chain. Clear? Any other long chain you can consider? Like suppose you are beginning a journey from here and you are going in this way. No problem. That will also give you the same name. Fine? But what you cannot do is, that also will tell you what you cannot do. See, what you cannot do is this. You are beginning your chain from this person. You are beginning your journey from here and you are taking the chain like this. This is not possible. Why? Because it is giving you 4 carbon. That is not accepted. Because 6 carbon is possible. Next, you cannot create your chain like this. 5 carbon, that is also not accepted. 6 carbon is possible. So you have to know that which chain you have to take. Clear? So here the main chain is the straight chain. Now coming to the numbering. Numbering which side to do from? Numbering can I do from 1, 2, 3, 4, 5, 6, or should I do 1, 2, 3, 4, 5, 6? I have done 2 set of numbering. Which one to apply? So here what I will take help of is this rule. What is this rule? Lowest locant rule. So I have to take the help of lowest locant rule. So what does the lowest locant rule say? The lowest locant rule states that you have to provide minimum locant to the substituent as much as possible. Right? Now here one substituent is not there, many are there. So we have to add up the positions, or that is locant of the substituent in both cases. That means what you are numbering from this side, what is the locant sum, and when you are numbering from this side, what is the locant sum. Twice you will take the sum, and the sum you will find whose sum is more, that will be the answer. Okay. Now you see, for the first case, that is this case, what is the sum? For this case, what is the sum? See, at second position methyl is there, so 2 plus. Third position is there, 2 plus 3 plus 5 plus 5. What is the sum? 15. Now coming to this side leveling, what is the answer? See, 1, 2, 2 comma 2, that is 2 plus 2 plus 4 plus 5. How much? 30. So who is lowest? This one. So which numbering you will take? This numbering you will take. Which numbering is correct? This numbering. So this numbering is wrong. Okay, understood. Why is that numbering wrong? Because of lowest locant rule. The lowest locant rule is giving us 13 for this side towards right numbering. So we will consider this right numbering. So what will the name become? Which position methyl is present? Here, 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 and here. So 2 comma 2. See here, 2 comma 2. This 2 or 2 comma 2. This is 4 and this is 5. Clear? So the name becomes 2 comma 2 comma 4 comma 5. How many methyl? 1, 2, 3, 4. Tetra methyl. Main chain has 6 carbon. So hexane. Clear or not clear? 2 comma 2 comma 4 comma 5. Tetra methyl hexane. Tell me, understood or not understood? Understood? If you mess up the first part, that is you are numbering from the right side, then your answer will go wrong over there only. You will not get the correct answer. So you have to know which case and where you will be doing what. Okay, very important case. Nothing to worry about. It's an easy one. Okay. So this is clear. Done. Now let's move on to the next question. Let us see what we have in the next question. CH3, CH2. Let's write a little bit lower. The upper content do not get stated. CH3, CH2, CH3, C2H5, CH2, CH, CH3, CH3. Okay. So what is our first job? To select the parent chain. First thing, you have to just check the longest state chain. This chain. What is the number of carbon? 1, 2, 3, 4, 5, 6. 6. Okay, fine. 6. Now, other than this main chain, is any way 6 carbon possible? Check that. Other than the main chain, is any other way 6 carbon possible? Check for that. This way it is possible. If you do this way, we'll get more than 6 carbon. Check it. We'll get 7 carbon. See, 2 here and 4 here. 4 here and 2 here. That is also 6 carbon. All are 6 carbon. So whatever you try to take, everyone will give you 6 carbon. Okay, not 7. 6 only. Because 2 is 3. Okay. So there are 6 carbon possible from whichever end you want to take. Okay. Provided you don't take from this end until this much. That there will be 3 carbon. You take it from this side to this side. 1, 2, 3, 4, 5, 6. Clear? So anyway you take, it will give you 6 carbon. I am taking the state. Now numbering, which side should I do for? 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. For that we have the lowest locant rule. So let us first consider from this direction and one from this direction. From this direction, the locants are 5 plus 3 plus 3 plus 5 plus 3 plus 3. Only these 3 are there. So 5 plus 3 plus 3 only. That is going to give us 11. And when we are going to consider this value, then we are going to get 4 plus 4 plus 4 plus 4 plus 5. 4 plus 4 plus 5. So that is going to give us 13. So how much you are getting? Total 11 and 13. So which side is lowest? So what will the numbering start from? Clear? So this numbering is wrong. Clear? So which numbering is correct? Numbering from the right is correct. So what is going to be the name? 2 methyl is there. 4th position ethyl as well as methyl is there. So let us write. How will you write? 2, 4 dimethyl. 2, 4 dimethyl. 4 ethyl hexane. Which is going to be the name? Any doubt? No. But this is not going to be the name. Right? Why is this not going to be the name? See the gear, last gear and the second last gear. For complex chain, this is not used. Last gear considered only during the alphabetical sorting. Then they are not considered during alphabetical sorting. So we are doing alphabetical sorting. So this E and this D won't be compared. Who will be compared with? This M and this E will be compared. Who comes earlier? E or M? E comes earlier. So who should have been before? Ethyl. So the name will be 4 ethyl 2, 4 dimethyl hexane. Dimethyl hexane. Clear? Understood? What did we do? We did not compare the D, T and T with the whatever we had to compare with. Okay, clear? We will not consider that during alphabetical sorting. Okay? This point is very important point. Okay? Please take special care of the point. That's a very important point. Okay? I am writing over here. Though you already know it, I am writing over here. Name has to be written in alphabetical order. Okay? Alphabetical order, if you violate in name, then you are not going to get the marks. There only will lose your marks. Because you have violated the alphabetical order. You have to write ethyl first, then methyl. If you write methyl first, ethyl later, then that is not correct. Clear or not clear? Clear? Tell any doubt? Till this much, any doubt? Clear? No doubt? Very good. Next question. Now let us move on to the next question. Next question is here. Next question. Here is your question. What to do? You have to name this compound. So how will you name the compound? How are you going to name this compound? So how are you going to name this compound? Gyan I will write here. Before the Gyan, you can use your common sense as well. We have to do the numbering at first. So let's number 1, 2, 3, 4, 5, 6, 7. I have numbered from this thing. Someone may not agree to my point of view and he will say, I will number from this side. I cannot stop him saying that, no, you cannot number from that side. You can number from that side as well. 1, 2, 3, 4, 5, 6, 7. You are also not paying. Now you see, the position of the methyl and the position of the ethyl both are same. Both are same. One time ethyl is third, one time methyl is third, one time methyl is third, one time ethyl is. Like this it is changing. Right? 3, 5, 3, 5. Interchanging positions. So which side should be number 1? One side we are getting ethyl as 3. One side we are getting methyl as 3. Now who will get priority? That I cannot say. Even if we apply the lowest locant rule also will get 5 plus 3, 5 plus 3, 8. Both are 8. Then what to do? Then what to do? Lowest locant rule also you cannot apply over here. Because both will give you the same sum. So lowest locant rule also. See I am writing over here. 5 plus 3 equal to 8. And 3 plus 5 is also 8. So which one to consider? Question mark. Which one to consider? We don't know which one to consider. Then in this case, to our rescue, what will come is alphabetical order. So write down. When lowest locant rule fails to specify a particular direction of carbon chain, C means carbon, okay, carbon chain numbering. When lowest locant rule fails to specify a particular direction of a carbon chain numbering, then the group that comes alphabetically first, alphabetically first is given priority. What does that mean? That group the carbon chain is numbered from the direction of that group. Clear? That means wherever this group is present, from that side only I will number it. Clear? Now what does that mean? So let's understand over here. Here methyl is there, here ethyl is there. Who is more alphabetically first? Ethyl is alphabetically first. So priority will get to ethyl. So that means which numbering will be correct? This numbering will be correct. Clear? So this numbering becomes wrong. Why it is wrong, do you understand? I have provided reason why it is wrong. Clear? So the numbering becomes 1, 2, 3, 4, 5, 6, 7 from ethyl side. Clear or not clear? So what is going to be the name? At fifth position you are having methyl, at third position you are having ethyl. So 3 ethyl. Again alphabetical order, 3 ethyl, 5 methyl, 7 carbon means hep, so heptane. Tell me, clear? 3 ethyl, 5 ethyl, heptane. Understood? Why did we do? What did we do? Clear? Understood? Okay. Now, before moving on to the next part, let us little bit know about bond line. Let us learn little bit about bond line diagram. Bond line diagram. What is that? Achha. Suppose in front of you I am drawing a mountain. And why am I drawing a mountain? You will tell me, why are you drawing a mountain? Why will I draw a mountain? I am doing chemistry. Why will I draw a mountain suddenly? Definitely to not to sunrise. Then why will I draw a mountain? This is not a mountain. This is a compound that I am trying to represent to the diagram. Okay? Let's not take up a big compound at initially. I am taking a small compound at first. Okay? I am taking a small compound at first. Let's take, this is the compound. Okay? Let us take. Fine. Now you see, if this is a structure given to you and it is asked to name, you will be like, what? What is this? Randomly lines are drawn and they are saying name this. Lines are not drawn like this, like this, like this, and it is being told to you to name. No. This cannot be a compound. This is, what is this? A curve. These rounded corners, this is not nothing. What is this? This is rounded corner. But if you see the compound, they are always sharpened. These things. Clear? What does this indicate? In bond line diagram, hydrogens are not shown. What are not shown? Hydrogens are not shown. So let us make a Gyan box and let us do it. Understand the thing. What is not shown? Here I will be writing. Okay? Yeah. In the bond line structure, hydrogen not shown. Clear? Second point. All corners occupied. No. All corners indicate a carbon atom. All corners indicate a carbon atom means what? Means this corner, this corner, this is also a corner, this is also a corner. All these 4 corners are carbon. So here is a carbon, 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 carbon. Clear or not clear? All the four corners are carbon. Let me shift to a little bit this side and I will be drawing the equivalent structure. What is the equivalent structure? The equivalent state forward structure comprising of hydrogen. Achha. So all 4 corners are going to have carbon. That means this carbon has only one hand, so 3 hand is free. So there must be 3 hydrogen. So I can write CH3 bonded with another C. So bonded with another C. And this is also bonded with another like this. This C has 2 hands, you can see. So this C must be having 2 more hydrogens to fill in. So this C must have 2 more hydrogen. This C is bonded to another C which is further having 2 hands. So this also has 2 hands. And this is only 1 hand, which is C. So actually the compound, this compound and this compound is same. We have represented in this way where no hydrogen is there. Here hydrogen is there. Clear or not? Here you can directly see that carbon is seen. Here you cannot directly see carbon, but you have to know that all the corners will be carbon. Okay, later on when you do Fission projection, you will find also structures like this will come up. Next when we will do Fission projection, then I will tell you, not now. These structures will come up. Newman projection when you will be doing, this way structures will come up. This circle is also a carbon. Then different ways of representation are there. Don't think about that. But you have to think properly. Okay? This is also carbon. This 4 dots, and this is also a chain. This is a chain, this is also a chain. Clear? So what is going to be the name? It's a very simple name. It's a butane. It's a butane. Even this is a butane. What type of butane? N-butane. N-butane. Now what is N? Hopefully you all know a little bit of isomerism also, you know that N-butane is the normal butane, the straight chain butane. isomers when I will be teaching you isomerism, and then after this only, after I will be only we will be talking about isomerism, then I will talk about that there. Okay, clear? So hydrogen is not shown. All corners indicate a carbon atom. So in case diagrams will come up like this, you can do it. Clear? Fine. Now can I move on to the next question? Okay, just I give again because the few next questions that I will be giving will be based on content. Done? Okay, fine. Now let's do the next question. Let us do the next question. The question is here. Okay, let me use a straight line, but my line won't be straight. This is actually, I have not completed the question yet. Just hold on for a minute. Okay. Then you have now you tell me how will you name this structure? How will you name this structure? Tell me. This is a bond line structure given. How will you name this structure? Take a very simple approach. Very simple approach. Complex chain. Already I have told you how to apply for a complex chain. The rules are written over here. You can go back and you can watch it again. There is no problem. The rules are here. The same rule will be applying. Here it was a normal format written. Here it is a bond line diagram. So let's start. Before I start, I want you all to pause the video and solve it. First check whether you can take the approach or not, because you all don't study chemistry. That I know very well. So please pause the video. Try to do the question. If you cannot do, no problem. Check the answer. What's big deal in that? But you have to try. You have to try. Otherwise you cannot do. Clear? So try. I hope you have tried. I hope you have tried. So let's begin with the answer. Let's begin with the answer. So let's begin with the answer. First you locate the carbons. Where are the carbons? Carbon, 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 carbon. These are the carbons in the entire compound. Now you tell me, can the entire set of carbon be in one chain? No. What is going to be the main chain? Visible clearly, the main chain is going to be this one. This is going to be the main chain. Right? Right. So let's number it. There is a complex chain attached to the main chain. So that complex chain must be getting the lowest locant. So if I start numbering from this side, like this, then I won't be getting the lowest locant, because from this side, this is possible. 3 position is possible. So automatically this position is this numbering is omitted. I'll be starting the numbering from this side. Right? So now let's check out the name. According to the rules of complex chain, first we have to write the complex chain is attached to which position in the main chain. Then whatever name is there, that has to include the parenthesis. So now let's come to the parent chain. Let's come to the root chain, that is side chain or complex chain. Here I have told you the carbon that is directly attached to the main chain will be treated as first carbon, and using that only you have to do. You cannot take this as first carbon and you do 1, 2, 3. No, that is not at all accepted. Clear? So you have to do this as one carbon. You do not have a choice there. You have to take this as 1. Now you take this as 2 or you take this as 2. Both cannot be taken as 2, 3. So either you take this. Done. Done. Now, this group is a methyl group. This group is what group? A methyl group. Hopefully you can identify that this group is a methyl group. This group is a methyl group. So methyl is attached to which carbon? first position, first carbon. So I will write 1 methyl, or you can also write only methyl, no problem. How many carbons? 2 carbons. What is the name? Ethyl. Done. Any more thing? What is the number of carbons in the main chain? 6. So hex A. The name is here. Your required name is here. Your required name is here. That's 3,1 methyl ethyl hexane. Very difficult name? Not at all. Very good. Very, very good. Oh, next question. Let us move on to the next question. Next question, see, I will just modify this question only to make up a next new question. What I will do is, I will modify this question itself to make up a new question. That is, how I will modify this question to make up a new question. We copy this. Okay, fine. Keep it over here. Now what? Now what? Nothing. What change I have done? I have just repeated that complex chain only in that. Right? Carbons. Here, 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 here. These are all carbons. Now what is going to be the name? The previous name was 3,1 methyl ethyl hexane. So should I write di 3,1 methyl ethyl hexane? Even the name is very awkward, and obviously this is not the correct name. Now, then what to use? We cannot use di, tri, tetra in case of complex chain, that I have already told you here. This, for complex chain, it is not used. Here it is written. So for complex chain, we cannot use di, tri, tetra. So definitely this is going to be the wrong answer. Then what to do? I need a gyan. What to do? You all need a gyan, right? What to do? If this is not accepted, then what will be accepted, that I need to know. Right. Of course you need to know what will be accepted. So I am here to tell you what is accepted. The thing that is accepted is being written over here. In the form of a gyan box. Yeah. If a complex chain is present 2 or more times, if a complex is present 2 times, what to use? You will be using bis. What you will be using? bis. Bis. 3 times. Then you will be using tris. Okay, same line I am not writing, I am giving that sign. Okay, it is not 11. Hopefully you all can understand that. Fourth one, then it will become tetrakis. Pentakis, hexakis, it will go on, but generally we don't keep it. So bis, tris, tetrakis. These are very, very important. These are very, very important, and you have to memorize the name. When to use which one? That is the thing you need to know. Clear? So this answer is not correct. The reason you have already understood that you cannot use di, tri, tetra, all this in case of complex chain. Then what will be the answer? The answer will be simply bis 3. Clear? The answer will become bis 3 1-methyl 3. So what is going to be the correct answer? This is not going to be the correct answer. Correct answer will be bis 3 1-methyl hexane. Understood? Bis 3 1-methyl hexane. In biology, there are many where you will find bisphosphate, this bisphosphate, that bisphosphate. Like only you will find one compound in biology only, ribulose, not ribulose 1,5 bisphosphate. This you will find in biology one compound. There are many are there which is find. Another one you will find is triose bisphosphate. So where are these bis coming from? These bis are all these bis are the complex bis. That is why the bis reactive. Clear? So application is in biology mostly. Clear? So bis 3 1-methyl ethyl hexane is the structure. Is the name. Understood? Understood it? Any doubt? Any doubt? Tell this much. Any doubt? They are very simple ones, right? They are very simple ones, and there should be no doubt. Achha. Now let me discuss one important part. What part? Important. Why it is important? First we need to know. Suppose in the question it's given. Okay, suppose in the question is given. Often you will find this type of things given in the question. Very often you will find this questions. Now what students do? What usually students do? First I am talking about what usually students do. If you had to write the name of this, then students will think, Acha, carbon is here, carbon is here, carbon is here, carbon is here. Okay. This I am writing is an expected answer. Expected answer. Okay. This is the expected answer. First let me write a question. Otherwise, where will be the question? Question. First let me write is the carbon. Question. Okay. This is the question. Expected answer. And the real answer I will write on the next page. Let me copy this. Okay. This is the question. Expected answer. Carbon, 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 carbon. Fine. No problem. 1, 2, 3, 4. 1 chloro, 1 chloro, butane. Okay. That student has thought, it is correct. No problem is there. But it is not correct. Actually, this is wrong. Reason also I am telling you. But first let me talk about the real answer. The real answer. What is the real answer? The real answer is carbon. The real answer is carbon, carbon, carbon. So what is the name? Now you ask me, what did I just do? Both mean the same, then where is the problem? The problem is here. This you cannot consider as a carbon. You think logically. I am writing CH3, CH2, CH2, Cl. Like this if I even write, what does that mean? That there is a single bond automatically. Right? This is a contracted form. Actually it is single bond. Even if you write like this, suppose I can write this as also like this. CH3, CH2, CH2, Cl. Does that mean no bond is there? Does this mean no bond is there between C and C? You tell me. You tell me. Frankly, I am telling you. If I write this structure as this way, does that mean that there is no bond between C and C? Between C and C, no bond. Between CH3 and CH2, 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 no bond. Nothing is there. No bond is there. Is it even possible that no bond is there? It is not possible. So similarly, When I write CH2Cl, does that mean that there is no bond between C and Cl? Definitely no. So actually the structure is CH3, CH2, CH2, Cl. This is the actual structure. Right? So this indicates automatically a bond. So if I write like this and consider this to be a one carbon, is it even possible for my sense? No, it is not possible. It is not possible. Then what does this mean? That there is no carbon over here, the carbon is over here. That is why I have extended and showed a bond between it. Because the chlorine cannot be present like that there. That there is suddenly chlorine is on a carbon. That what does that mean? What does that mean? When you are drawing a line, that line means the carbon. The line means the bond. Then what is the use of drawing a line? If I am not going to show a line between Cl and C, then why will I use this bond structure? Do you understand what am I trying to say? If you take this circled part as one carbon, then you are wrong. Because even if you write anything like CH2Cl, whatever, this Cl and C does not have a bond. It will have a bond. The expanded structure is this. It is a contactless structure. But we are drawing an expanded structure where hydrogen is not there. But others will have to be shown. So this does not mean that here there is a carbon. It means that only carbon present is over here, and to this carbon there is a Cl attached. Please be very clear with this, because this is a very common mistake. Here there is no carbon. Here the carbon is there. So numbering is 1, 2, 3 only. There is no fourth carbon only present. You forcefully make one carbon here, there it is not correct. Understood or not understood? Tell me. A very important answer. Understood or not understood? This Cl is attached to this carbon. There is no such carbon here. Clear? Please keep a note, because somewhere or the other this make this mistake in the exam. Clear? Clear or not clear? Check properly and tell. Clear or not clear? Clear? One more question we will do, and then we will go for the functional group introduction. As of now, no such important functional group has been introduced. Now we will be going to the introduction of the functional group, and directly we move on to the polyfunctional group. Because one or two functional groups like oleic acid, like aldehyde, these you already know. So direct question I will not give you. Okay. Maybe one or two I will do a basic question. Then we will directly move on to the polyfunctional group of introduction. Okay. Before that, we will do one question. What is the question? The question is here. We have a carbon which is attached to CH3. This carbon is further attached to CH3. Fine. This carbon has been attached to CH2OH, and this carbon is attached to CH, which is having a CH3 group. This is attached to another CH3. This carbon is attached to CH3, which is further attached to another CH3. What is the name of the given compound? The compound might seem very, very big, and what is there? But it is a very easy one. This is the main chain. No other main chain is possible. No other main chain is possible. Only this can be the main chain, because I have to include the functional group in the main chain. Here is the functional group. That has to be the main chain. So this is going to be the main chain. It is the functional group. So carbon number 1, carbon number 2, carbon number 3, 4 this one or this one. I am taking this one. Done. So at third position I am having a methyl. At second position I am having a complex chain, and this is another complex chain, which both are same. Right? So I am having first 3 methyl, then I am having comma. Very simple. I think 2, 2. See 2 and 2. Both are second position attached. 2, 2. Bis for similar repetition. Right? 1 methyl. Here is, I did not number. Hopefully you have numbered already. This is the first carbon. This will be the second carbon, or this will be the second carbon. Either one it takes. So see, at first position you are having a methyl group. So 1 methyl, ethyl, butanol, butane, 1 ol. Hopefully you know that ol is the suffix of OH. Ol suffix. And. If you did not know, then know now that hydroxy is the prefix. What is the prefix? Hydroxy. Okay, I will keep on writing a few important parts like this only. So please keep an eye on whatever I am writing and try to note it down, because very important thing like this will come in, because I will not write separately that this is this, this is that. No. In questions, when I will be doing questions, to questions I am telling you many things. So please listen to what I am saying very carefully. Clear with the name? The name is clear, and how you are getting the name? Name is understood? Directly you are getting the name. But you have to do a little bit slowly. You cannot do very fast like that. Until your concept is clear, you cannot do this fast. So you have to a little bit slow. Clear? No problem with being slow, right? Okay? Okay. So clear with this? Done. Next, we will be moving on to polyfunctional groups. Our next topic is polyfunctional group. Nomenclature of polyfunctional group. Till now, the questions that we have seen, there were either no functional group or there were only one functional group, or there were only one functional group. But now we will be taking up those compounds which have more than one. See here, only one functional group. This one. Here no functional group. Like this type of questions. But now the question that we will be taking up, it is going to have more than one function. Then in that case, which one we will take? Which one are we going to take in that case? That we need to know. Okay. Before I move on to that, let me take a quick question. A very easy question. Let me give you one just to check. Okay. No gyan will be given on this question because you already have got the gyan, right? Suppose the question is this. Is this a polyfunctional group? No. This is not a polyfunctional compound. This is a simple nomenclature where only one functional group is present. So as we know, we have to follow the lowest locant rule. So this will be numbered as 1, 2, 3 and 4. Now this will get 4 locant. You cannot do anything. You are helpless. Here this will get 4 locant. This will get, because we have considered this as 1. If we consider this as 1, this will get 4. So either of the COH will get 4. So no need to worry about it. Clear? Right? Now how to name? How many carbon? 4 carbon. So it is but, then N, because all single bond. Then what? 1, 4, 2 positions, dioic acid. Dioic acid. Now, this percent will not be there. Clear? So, what is going to be the actual name? Butane 1, 4 dioic acid. Clear or not clear? When there is a vowel following the name, the E is not there. Have I given you the gyan before? If I haven't, then I'll write it over here. Let me just see. I don't think I've given this gyan. So let me just write it. No, it is written. See here. N in I. E is dropped if followed by a vowel. This thing we have applied there. N in I, the E is dropped if followed by a vowel. So E is followed by a vowel. Here another gyan I have given, that these are not considered during alphabetical sorting. So di, tri, tetra we are not seeing during alphabetical sorting. So the name stands as butane 1, 4 dioic acid. Clear or not clear? Clear? Okay. Next question. Now coming to polyfunctional group. So in this type of question, which one we will take it as priority? Which one we will give priority? That should be the prime question. What do I mean by that, right? The question that you all are thinking right now is, what do I mean by that? I understand. First, let me give you one question. Here's the question I am going to explain. Question. Suppose the question is, CH, CH3, CH3, CH, OH, CH2, C double OH. Now here, this is a functional group. This is also a functional group. Which one we will take? This one or this one? Someone can say, I will take from here. Fine. I cannot deny the fact. So 1, 2, 3, 4 or 4 here. I cannot deny. Right. Someone will say, I will take this 1, 2, 3, 4, 5, 6, 5. This is also not. But why will I deny the person who is taking OH as number 1? The carbon attached to OH is number 1. Because that is also a functional group. Then in this type of cases, what we have to do is, in this type of cases, we have to consider a priority table. So let me give you a gyan over here before I come to this part. The gyan is the priority table. What is it? Priority table. Okay, it is the priority table. Priority table, where it is starting as acid, कब से इस हाल में है. Sorry, my Hindi is very bad, whatever it is. Okay. Cyanide, isocyanide, Ne, aldehyde, O, K, A, T, A. This is going to be an order. I could not write it as well, so I am writing like this one. Okay. Acid. Acid means carboxylic acid. Say means sulfonic acid. What acid? Sulfonic acid, represented by SO3H. Is means ester. Ester is COOH. Hal means acid halide. Acid halide. That is, you will get a COX format. May means acid amide. Okay, amide. CONH2. Cyanide you already know. C triple bond N is cyanide. Isocyanide, that means N triple bond C. Aldehyde, you all already know what is aldehyde. CHO group. K, aldehyde O, kata. Ka means ketone. Ketone you already know what is a ketone. Ketone is this way. Kata, alcohol. Aldehyde ko kata. Alcohol. Alcohol means OH. Then comes thialcohol. Thiol, SH. And at the end it is amine. This is the order. After amine also there is ether. After amine you will get ether and then the substituent, the halogen groups. So this is the entire priority table which you have to follow. This is a very, very important one, because through this order you are going to write. In this type of question, in this type of question, you are going to see this functional group, this table, this priority table, and accordingly you are going to take the priority, the functional group which is there in the question. So acid कब से इस हाल में है? Cyanide ने aldehyde को काटा. Acid means COH, say means sulfonic acid, is means ester, hal means acid halide, May means acid amide, cyanide means cyanide, isocyanide is isocyanide, aldehyde is aldehyde. K means ketone, A means alcohol, T means thiol, A means amine. After amine also there is something that is ether, and hopefully we write it in red color only, otherwise we will think it as something else. So it's ether. After this you will get ether. Okay, and then you will get the haloalkanes, the halo groups, halogens. Okay, after you will get the halogens. Not actually halogens is wrong, haloalkane actually. So this is the priority table. Now coming to this question. Starting from here 1, 2, 3, 4, 5, 6. So I have this done. So what? How many carbon I have? 6. Now methyl groups are attached to few positions. So that you can write. First I have to write in alphabetical order. So 3 hydroxy. Then 4, 5. Dimethyl. Any more methyl? No. 4, 5 dimethyl. How many? Hex, AN1, oic acid. Again, the E has been omitted over here. If you see here, the E is not missing. Here, if you special notice here, E is not there because of the gyan that already has been given to you. Clear? So how did we reach out to the name? We have to memorize the priority table because that is going to be the answer. Done? Understood everyone? Check it properly because this priority table is the most important part. Please note it down. Okay? Please note it down. Very important. Okay. So I hope you all have noted it. Please memorize this because this is a very important topic and you need to memorize this. So you have to. You don't have a choice. Okay. Let's move to the next question. This question understood? How did we do? What did we do? Very good. Let's do another question. Next question. Writing over here only because I have enough space. Okay, if I give you this structure, the name of this compound is, tell me, pause the video, try it, and tell the answer. I hope you all have tried it. So let's see what's the answer. Carbons. Where are the carbon? Here there is a carbon, 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 here already a carbon is there which you can see. Right? So numbering will start from this because we know that acid cup say. Right? Acid cup say. So acid first, say later. This is the main function. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Done. So what is going to be the name? At third position there is a, what is the prefix for this group? I have not told you the prefix. Okay. So write down at the side. Let me erase this. So write down at the side as a gyan. Prefix. SO3H. Suffix. Sulfonic acid. Prefix. Sulfur. Okay. Prefix is sulfur. What is the prefix? Sulfur. Please remember. The prefix is sulfur. What is the prefix? Sulfur. Suffix is sulfonic acid. Clear? Okay. So 3 sulfur. Then pent. Tan. 1 oic acid. Any doubt? I hope by now you have already known how to write the names. Third position, sulfur is attached. So the sulfonic acid group is attached. So 3 sulfur. Pentane, 5 carbon. One position it is COH. So 1 oic acid. Any doubt? Any doubt? There should not be any doubt. There should not be any doubt. Right. Now let's move on to another question. That this will be the last question of this part. Then I'll move on to some other part. Okay. Question. Okay. Please be very careful with the question. Okay. This question might look a little bit tricky, but it is not tricky. Now tell me, what is going to be the name of this compound? What is going to be the name of this compound? What is going to be the name of this compound? Pause the video, try it, then I will do it. Okay, so I hope you all have already tried it. So now match your answer, okay? Match your answer. So we know that we have to select the main carbon chain. And that main carbon chain must contain the functional group. But whatever way I will try to select, it will not contain all the 3 functional groups. So definitely one functional group will be left out. So that has to be left out. So the main chain I can see is this one. This one will be the main chain. Right? I don't mean this part. I mean only this much. This is the main chain. Right? So that is the main chain. Now numbering, if I do from either side, I will get same. Because one side there will be, both sides there are COH. Right? So one will get a lowest local, right? So starting from here, 1, here is a carbon, I am marking the carbon. So here is a carbon, 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 here is a carbon. Here there is no carbon, okay? Please do not mark out the carbon over there. There is no carbon there. Then a carbon is over here, a carbon is over here, and a carbon here is always visible. So 1, 2, 3, 4, 5, 6, 7, 8. Done? So 8 carbon. So 8 carbon means I will write octane. Octane written. Okay, fine. Then, how many oic acid are there? 2 oic acid. So oic acid. 2 oic acid means dioic acid. Which position? 1 and 8. So 1 and 8 dioic acid. Written. Fine. So octane will be before the name as of now. So octane 1 combined dioic acid. Will the octanes E be there? No. So the octanes E will not be there. Right? The octanes E will not be there. So this E will be dropped out. So E gone. It will be octane. Right? So octane 1,8 dioic acid. Now what else? What about this? This is a complex chain. So as I have already told you how to name a complex chain. The naming a complex chain is done by this carbon is attached to this carbon. The first carbon of the complex chain is attached to which carbon of the main chain that I have to take in. So that will be numbered as 1. Now obviously I am not going to do this side too. Why will not do this side too? Because that won't include the functional group inside it. I need the functional group. So to do that, I will always try to keep the functional group in the main chain. Right? I will always try to keep the functional group in the main chain. So this will become this 1, 2. Now, I cannot write oic acid inside. I cannot write oic acid inside the complex chain because the oic acid is already in the main chain. So inside the complex chain, I cannot write ol, in, ein, anything out there. That sort I cannot write. Oic acid or on or ale or anything of that sort I cannot write. There I have to use the prefix only. There I cannot use any suffix. Do you understand? There I cannot use any suffix. There I have to use a prefix. Did you understand? In this case, I have to use a prefix. I cannot use a suffix in this case. Reason is very simple. Reason is because dioic acid is already mentioned in the main question. Then I cannot again write dioic acid inside the complex chain. Clear? Clear? Done? Next. So the numbering starts from here. So this is the carboxy. Okay. You did not know. So let me write again on the side. Again. COH. Suffix you all already know. It's oic acid. Prefix you all did not know. That's carboxy. Carboxy. Okay. So it's carboxy. So here it will become carboxy. Position 1. So 1 carboxy. But 1 carboxy. Done. Here this is methyl. This is methyl, right? So 1 methyl is also there. So 1 methyl. Ethyl. This is the entire name. 1 carboxy. So sorry. Not 1 carboxy. The carboxy group is at second position. If you can see properly. The carbon that has been marked is at second position. We cannot write that. Sorry, I'm very sorry. We cannot write that. Why? Just now I made the mistake. What is the mistake? The mistake I made was, I'm writing the mistake first. Then I will be directly. Since I made the mistake, let me write the mistake. The mistake is I wrote this. Why it is wrong? I made a mistake. Now why is this a mistake? That you need to know. Right? Very important mistake I made. By some chance, I made a very interesting mistake. I can give an expression for that. Now see, what is the mistake all about? Let me shift this a little bit this side. And let me bring it down. Okay, this could have been the name. This could have been the name and this will be written by many of you as the answer. This is attached to the position number 4, so we will write this. 4, 1 carboxy, 1 methyl ethyl, octane 1,8 dioic acid. But this is not correct. Okay, this can be one possibility. They are all expected answer. I am writing the expected answer list. Expected answers. This is expected answer number 1. Expected answer number 2. What is the expected answer number 2? This only, if you copy, I am copying this, and I will be changing only one word. But what I will change? Just see. Same answer copied. This one is changed to 2. This will be one answer. 2 answers already I have got. But unfortunately, both of them are wrong answer. Now, why are they wrong? If you remember, we have told you before only that, let me show you. First let me show you, then I'll talk. See here. We have to follow the lowest locant rule as well as the longest chain rule. Now the longest chain rule will be followed in such a way that the main functional group should be there inside the longest chain. Right? Longest chain should be there. But the longest chain must have the functional group that should be at the lowest position. Right? These are the conditions that we need to take care of. Now you come here, come back over here to the question. You see what has happened just now. Here, see. We have taken the longest chain. We have taken the chain having the functional group. But did the functional group get the lowest possible locant? You tell me that. Did the functional group get the lowest possible locant? No. It could have got the one position, this position, but this methyl won't be there. Why? That was the expression I will be giving. This is the expected answer. The expected answer is this. But actually it is not the answer. Why? You have put carboxylic acid group into the main chain, but you have not given it the lowest locant. The lowest locant possible is 1. Now you will say, 1 to is written here, then why is it not the correct answer? No. Then if you give the 1 to carboxy, then how did methyl come from? This is then if you are taking this, then 1 cannot come only. Then you have to write 2. Right? If 1 is coming, then this will be the main chain. Understanding? So I am copying this and I am writing this again. Understand it. Very, very important. See here. I am erasing this part. And I am writing the actual answer. Writing the actual answer. This is the actual answer. What is the actual answer? Number 1, this will be number 1, this will be number 2. So now you see this carboxylic acid group gets the lowest possible locant. Despite it is not in the main chain, but it has got the lowest possible locant. Clear? Because we will help this. We have to give the functional group lowest possible locant. That means our priority. Clear? So what will be the name now? 4. This becomes carboxy. 1 carboxy, I am not writing 1 because 1 is you write 1, you don't write 1. Same meaning. Carboxy. Total is ethyl. So carboxy ethyl. 4 carboxy ethyl. Octane 1,8 dioic acid. Did you understand? Tell me. Did you all understand? This is a very, very important type of question. You can see the mistake that you all will make over here. It is clearly spotted. What is the mistake you all will make? This is going to be the main chain. This won't be the main chain. This 1 and 2. This way. It is not the main. This is wrong. This is not the main chain. What is going to be the main chain? The main chain is going to be this one. Clear? We have to give the lowest locant to the functional group. Understood? Understood? Next. Next you can see some GAN is written. What is the GAN? The GAN is related to ester naming. The GAN is related to ester naming. Okay, I hope you have learned in class 10 how to name an ester. Name an ester. First, let me give you a brief idea about. Okay, first let me copy this because I will be reading 2 pages of this. Just a minute. Okay, suffix. First, let me talk about the suffix. So you know that the suffix is alkyl alkanoate. This way, this format it is there. Now what am I writing? Alkyl alkanoate. Many of you might not know what is this. Many of you might not know what is this. So what am I writing? Alkyl alkanoate. What's that now? Example I am giving you. CH3 COO CH3. This is an ester. This is an ester. Clear? Naming is done in such a way that one will get this either this group or this group will become alkyl and the other will become alkanoate. Here both are same, that is what I am saying. Now you understand. This side and this side, who is disturbed, who is not a continuous carbon chain. How will you identify? I am telling you. Which of this is not a continuous carbon chain? This side is not a continuous carbon chain. See here between there is an oxygen, but this carbon, this carbon is bonded to another carbon, but this carbon is bonded to an oxygen. So this is a disrupted, so this one will be the substituent. What it will be? The substituent. So this will become alkyl and this will become alkanoate. See in the noate there is an O, that means the oxygen is included in this chain only. Clear? In case of ether also we'll find alkoxy. Alkoxy means that O is included in that chain. Clear? There you have to consider this one as the substituent, entire thing. But here we will consider only this much as a substituent. In ether, both will be considered. So that I will tell you in ether, no need to break your head now. So this will become methyl. Clear? Methyl, and this is 2. So methyl ethanoate. Clear? Commonly it is also called a methyl acetate. But whatever you leave it, not needed. Methyl ethanoate is the main thing. Understood? You can see the longest chain will be more always. So this is an example. Alkyl alkanoate is just. Now, coming to the prefix. Now, prefix can be of two types. Depending on what the structure is, prefix can be very important. It can be alkanoyl oxy and it can be alkoxy carbonyl. Two ways it can, depending on what the structure is. Now, let me discuss here only. From the name, what can you interpret? You see, oxy. This oxy means what? Oxygen it is indicating. And this carbonyl is indicating that a carbon is separated. This carbon is separated. And this oxy indicates that oxygen is combined with an alkane. So from the name only you can understand that which case which one to use. Now I am giving you example so that you can understand that what is this. Example. See here. Very important. Please see the example properly. Please see the example. Okay. Suppose let me take any compound. Okay. And here I am attaching a ester like this. R is anything. Okay. This is an ester. And here also I am attaching another ester. But this time you see the ester how I attached. I have attached the ester like this. Here I have attached the ester. Now see, both the two cases, the attachment of the ester is different way. One is attached with the oxygen of the ester, one is attached with the carbon of the ester. So this both the cases, the naming will become different. Okay. Now when this is attached with the oxygen, please listen. Okay, because everything I cannot write. Something I will tell, I will not write all. Some things. When this is attached with the oxygen, what to do? We will write it as oxy separately because we cannot write any specific name. But this one is a continuous chain, if you can understand. So that will become a particular chain. So that will become alkanoyl. And this oxygen is a separated guy, the alone guy. So it will stay alone. Clear? So it is an oxy. So in this case, alkanoyl oxy. When bonding is with oxygen. Clear? When bonding is with oxygen, alkanoyl oxy you will use. Bonding is with oxygen, so you will be using alkanoyl oxy. Clear or not clear? Now come down to the second one. Here you see the bonding is with carbon. This side if I go, there is a disruption of this. Disruption with oxygen. In between oxygen is disturbed. So this is not a continuous chain. So I have to consider this part as a chain. So this part will be called as alkoxy and this is a carbonyl group. So this will be called carbonyl. Understood? Very simple name. So this will be called as alkoxy and to show that there is another carbon because there will be only one carbon only here. There cannot be more than one carbon. So there will be one carbon and to show that one carbon we will be using alkanoyl alkoxy carbonyl. Clear? So when bonding is with C. Clear? So when the bonding becomes with the C, we will be specifying a carbonyl group and we will be writing alkoxy carbonyl. When it is bonded with O, we will be writing alkanoyl oxy. Clear or not clear? Clear or not clear? We should do some question, then it will be more clear. So let us do one question. Okay. Question is here. We have here this person and we have here this person. Here we have Okay, now 10. What will be the 10? Okay, main chain and all that you have, I hope you have understood how to number main chain. So that I will be doing a little bit faster now because you are accustomed to it now. Okay, carbon, here carbon, here also carbon, here also carbon, here also carbon. Other carbon you can see. So numbering starts from this side 1, 2, 3, 4, 5. This side we cannot start from. Right. Now, carboxylic acid is there, so that will go at the end. Oic acid, pentanoic acid will go at end. That we are not bothered about because we know that. Now, bothered about this one and this one. What to name it as? Okay. First, we will name it as third position because position third comes before. So third position. In bracket you can write. Without bracket also you can write. Preferably you should write in bracket. Though it is not a complex set, but you should write in a bracket. Okay. You should write in a bracket. Okay. Okay. So, I am first talking about this one. So here just now I have told you that if bonding is with O, which one we will write? Oxy will be separated. Bonding is with O, oxy is separated. Bonding is with O, oxy is separated. So this name will become what? How many carbon? 2 carbon. So it, right? 2 carbon. It ethanoyl, because alkanoyl oxy. So ethanoyl oxy. Clear? Next is fourth position. Bonded with carbon, right? Bonded with carbon means alkoxycarbonyl. So alkoxycarbonyl. Alkoxycarbonyl. How much? Eth. So again it is ethoxycarbonyl. Clear? Then it is as usual pentanoic acid. Tell me, clear or not clear? Very, very important question. Ester naming. Ester naming is an important part. Understood? So when bonding you are doing with O, you will be using alkyl oxy. When bonding you are doing with carbon, you are going to use which one? Alkoxycarbonyl. Example is given here. Understand the example. And then we will move to the next part. Okay, so this is clear. No doubt regarding this. Let's move on to the next part. Here I will give you a little bit of gyan. The gyan is related to the prefix part. A little bit of gyan related to the prefix. Few common prefixes. Few commonly used prefixes. Like number 1, NH2, amino. Okay, these are all prefix amino. It I have already told you. CONH2, amido. Usually use amido or you can use carboxyl as well. Both are same. Carboxyl you can use or amido you can use. Carboxyl also you can write, amido also you can write. Okay, carboxyl. Next is OH. OH is hydroxy. Like I have already told you. That is aldehyde. Which is aldehyde, right? Aldehyde you can use this. Also. Clear? Sorry, not oxo. No, not oxo. Formine. Okay? Formine. Ketone. This is also. Then this group, I think I have already told you. Haloformine. And COH, it's carboxy, already told. Another one you remember, that is NO2, nitro. These are the things that you need to remember. Achha, one more you take down. That is cyano. So these are the few which you have to remember, because many times you will get polyfunctional group questions. There you have to use these prefixes. Okay? And these are the few common ones. Generally we will get about this only. Okay? Done. Next, let us go to the next question. Next question is here. Question. CH2, double bond CH, double single bond CH, double bond CH2. What is going to be the IUPAC name of the polycompound? What is going to be the IUPAC name of the polycompound? I want you all to pause the video and get an answer for this. Then I'll tell you the answer. So you have answered, I hope. So let's begin. What we have to do at first is numbering. Now, shall I begin the numbering from this side or from this side? That is a question, right? From this side, 1, 2, 3, 4, or 1, 2, 3, 4. That is a question. From this side, double bond is at third position and double bond is at first position from this side. This is from this side. And from this side, double bond is at first position and third position. So both the positions they are same. Both the position is same. Then from which side should I number? That does not matter only. So either two side you number, both are getting same points. So any side you number, right? So let's number from either of the side. Let me number from this side. The problem is here, right? Okay. So the name is how many carbon? 4 carbon. So bute. Bute. Then two positions there are double bonds. So 1, 3 di. Right? This should have been the name. This should have been the expected name, but this is not the correct name. It is wrong. Then what is the correct name? The correct name is buta. There is a A. Buta 1, 3 di. What is it? Buta 1, 3 di. So let us write over here the gap when multiple unsaturations present. Multiple unsaturations of same kind. It's not like one in one out. No. Then you cannot use A. But when multiple unsaturations of same kind is present in the main chain, then the corresponding word root becomes word root plus A. That means whatever is the word root, along with that you add a A. Example, bute plus A equal to buta. So you are going to use a word buta. Clear? You are not going to write bute. You are going to use buta. Clear with this? Any doubt? No doubt? Very good. Next, let's do another question. Now let's be a bond line diagram. Okay, this is a bond line diagram. So this is a bond. Here is a bond. What will be the name of this compound? What will be the name of this compound? Pause the video, get an answer. Then we'll discuss. Okay, so I hope you have got an answer. So let's start. First question that arises in our mind is which side to take from? Which side should I take the numbering from? This side or this side? See, from this side I can take, then I can get 1 carbon. Sorry. Then I can get 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, 6 carbon. Okay, this is numbering from this side. If I am numbering from this side, then I will get 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, 6 carbon. What is changing is the position. See here, when I am numbering from this side, the double bond is at 5th position the triple bond at first position, when I am numbering from this side, the double bond is at first position, the triple bond is at fifth position. So nothing but equivalent position. This is nothing but the equivalent position. Right? Because both the sides, the position is just getting reversed. What is happening is, from both the sides, the position is just getting reversed. Understood? So this is equivalent position. Equivalent position. So the positions are getting reversed. So in this case, the priority is given to the double bond. Clear? The priority is given to double bond. Where unsaturations are at equivalent position, positions, reference is given to double bond. Clear? They are at equivalent position. Means what? Lowest local rule you cannot apply. Both the side will get same. In that case, the preference is given to a double bond. This can also happen that both the sides are getting the same number. That is also possible. And I will show you in the next case only. This case you are seeing that it is getting reversed. Next case you will see both the sides the same number will come. There also this rule will be applied. Clear? So clear with the concept? Clear? When from both the side if we find the positions getting reversed or the positions are same, then we will bring the priority to the double bond. Clear? So in this case, which side will number from? Will number from this side. This will be the correct. Clear? So this numbering will not be correct. Wrong. Okay. So what is going to be the name? How many carbon? 6 carbon. So hexa. Right? Not hex. Hexa. Which position? Double bond, triple bond? We are writing first double bond. So double bond which position? First position and third position. Right? So hexa 1, 3. Diene. Right? Then I at fifth position. So 5I. But this is also not a correct name. This is also not the correct name. Then what is wrong with the name? What is wrong is you need to remove this E. This E will also not be there. Hexa 1, 3 di and 5I. This is also IUPAC rule only. That what is the IUPAC rule? That terminal E of E is dropped if suffix is if suffix don't write suffix, if it is followed by a suffix. Okay, it is followed by a suffix beginning with A, E, O, U or Y. So here it's a Y. So we have dropped off that. There, these are the rules. You might think A, E, I, O, U. Yes, right. That was for the first case we have already seen. A, E, I, O, U, you have to drop it. Where it is E, O, you cannot write or E, O, you cannot write. Then you have to drop it. But here the case is a different. There is a bonding case. That is clear. Understood? Next question. Let us go to the next question. Next question is here. CH, triple bond C, CH, double bond CH, single bond CH3. What is going to be the name of this compound? It's an easy question. I hope you have already solved it. So let's us now discuss. Which side should I number from? This side, so that is number 1, 2, 3, 4, 5. Or this side, 1, 2, 3, 4, 5. Both sides I have number. Tell me which side is the correct side. Preference will I give it to double bond. But what is the condition of preference of double bond? Condition of preference is double bond is very important. condition is only at when it is equivalent. Otherwise, no. IUPAC straightforward says that only and only you can give preference when only it is at equivalent position. Otherwise, you will not give preference to double bond. Like here, if my double bond is this way, so this is correct numbering. No, it is not the correct numbering. Clear. Double bond will be given priority only when it is both are in equivalent position. Clear. Now let us take the lowest locant rule. When I am checking for this side, okay, I am checking for this side, then I am getting second position double bond and fourth position double bond, total 6. When I am checking for this side, I am getting first position double bond, first position triple bond plus third position double bond, which is 4. So which side is lowest locant? This side. So which numbering will I take? This numbering. Clear. Lowest locant rule is valid for every case. Reference or double bond is given for equivalent position, that is coming later. Before that, you have to check for the lowest locant rule. Here I check the lowest locant rule, I take that both the case the lowest locant rule will be the values will be coming same because they are in equivalent position. Here also I told you the same thing, that both the side you take you will get the same value. But you have to check for the lowest locant rule at first, and that is what we did here. Clear? Clear what we did? We did the lowest locant rule that we have to do at first. So which side numbering we will take? From this side. Clear? So this is wrong. So what is the name? Pent. No repetition. So no penta. Okay. No repetition is there. So no penta. Only pent. 3. Third position. N. 1. I. Clear? The E is missing. Check here. Okay. The E is not there. Because the E is not supposed to be there. As the rule it is saying over here, the E is not supposed to be there. Clear? Because Y is there. Clear with this? Any doubt? Okay, next question. Writing over here only, it's a having space. CH2, double bond CH, single bond CH2, single bond C, triple bond CH. Now you see the question. Numbering from this side. 1, 2, 3, 4, 5. Numbering from this side. 1, 2, 3, 4, 5. Lowest locant rule apply. First is this side. 1 plus 4, 5. From this side. 1 plus 4, 5. So both the side, same case, equivalent position. I cannot judge by lowest locant rule. Then what will I judge by? I will judge by the preference of the double bond. So in this case, this double bond will get the preference. So this will become the primary numbering. This numbering will go down. Clear? Why is it going wrong? You understood? Because equivalent position, double bond has got priority. So if double bond gets priority, then automatically the numbering will become from the double bond side. Clear? So what will the name become? The name again will become pent 1 N 4 I. Clear or not clear? Here you see the example and here you see the example. Two example to different case. This is also equivalent position, but the position gets reversed. The lowest locant rule will come same, the sum will come same. Here also the sum is coming same because the position is also same. Clear or not clear? Position is also same. Actually the position is not same, it's reversed only. Here you also find it is reversed only. Position exactly cannot be same, it will be reversed. What do you mean by same? Same means the position I am saying this same. It will be reversed only. Clear or clear? Understood? Any doubt? Any doubt? Because this is a very important thing that you need to remember. Tell me clearly, clear to everyone? Okay, so I think it's clear to everyone. Now we will move on to cyclic compounds. Till now, whatever questions we have done, they were all open chain compound. Now what questions we will do? Those will be cyclic compounds. Okay, cyclic compounds. Be it cyclic or be it open. The basic fundamental 3 rules which I have told you before, those rules will be valid for all cases. That means you cannot ignore those 3 rules. Which 3 rules I am talking about? Showing you the 3 rules again. These 3 rules. Where did it go? Where did it go? Here. These three rules won't change for any case. Clear? This rule will be applicable for every case. Every case this is applicable. Clear? So you are doing now cyclic. Do not forget that you have to apply lowest locant rule at every stage. Okay. Thus, because in cyclic you will be most troubled with this lowest locant rule. You will see how you are troubled with that. Okay. So let's do questions and let's understand how to tackle the questions. Okay, so let's take up question. First question. Okay, first question. What is this structure? Please don't say square. That I also know it's a square, and we are not learning basic geometry, right? We are learning chemistry. That also organic chemistry. So don't say me square. What is this? This is a structure, a compound. What is the name of this compound? How to know? Right? Question is how to know. Now, if you remember, in the bond line case, I have told you how to identify bond line. Here I have shown you. Very good. Here I showed you. Every corner is a carbon. Every corner is a carbon, right? In the bond line, I have told you that every corner will be a carbon. That thing is also applicable in cyclo. So every corner is a carbon. Means what? Carbon, 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 carbon. So how many carbon? 4 carbon. 4 carbon, right? So I can write butane. If I write only butane, then what is the difference between? Then what will be the difference between this? This and this. Both will become same, right? But both are not same. One is cyclic, one is aliphatic, right? So we need to differentiate. So that differentiation is done by using the word cyclo. What is the word? Cyclo. So it is cyclo. The word is cyclo. Then you write butane. So cyclobutane. Clear? So whenever there is a cyclic structure, you have to write the word cyclo in front of the word root. Okay? Gyan is here. For cyclic structure, cyclo plus root word or word root, that is not root word, word root. Clear? Actually, this is a rule of IUPAC. I have told you in the first case only, when I was telling you about the IUPAC rule, the naming of IUPAC rule. There I have told, must have told this one. See here. Prefix has one part, this for this part. Cyclo, bicyclo, spiro. There I am now writing cyclo. For open chain, so nothing is there. We will not write open. No, open will not write. That is, nothing means open. But for cyclo, the 2 degree prefix comes in, that you have to write cyclo. Clear? So that is why we are writing a word cyclo before the root word. This is nothing but IUPAC format of writing. Still I am writing, but you already know this, right? This also I am writing, though you know, every corner is a carbon. Clear? Okay. So did you understand why is this cyclobutane? Okay. Next question. Next question. If I draw this structure, okay, these are all corners. Okay, I am just freehand drawing, so this might not join, but take it at its joined one. Okay, because it is not always possible for me to join it every time. Okay, anyway, just take it to be joined. Okay, Acha. What is this? How many carbon? 1, 2, 3, 4, 5, 6. Acha. One thing. In case of cyclic structure, you cannot break the chain. What do I mean by that? Like, in case of straight chain, suppose this is one straight chain and here is one substrate. You could have taken the main chain like this. This could have been the main chain. I'm just showing by lines, okay? This could have been the main chain. But here, this cannot be the main chain. Like, if you are taking this way, leaving out suddenly in between, this is not possible for cyclic. Clear? So in case of cyclic, the numbering is always on the ring only. Clear? Numbering will be done on the ring itself. Okay? Numbering done on ring. Numbering to be done on the ring. Clear? The outer carbon won't be numbered here. Okay? So 1, 2, 3, 4, 5, 6. Right? So first position I am getting a methyl. Right answer. First position I am getting a methyl. So 1 methyl, cyclohexane. Clear? 1 methyl, cyclohexane. Understood? Cyclohexane is one word, not divided into two words. Okay. Let us do another question. If I put here a methyl and here if I put a, what about now? What will be the answer now? Should we take methyl at position, the carbon, so you know, I am marking for few questions the carbon, later on I will not put that. Okay. Now, see, understand. Should I take this 1, 2, 3, 4, 5, 6 or the vice versa? Vice versa means ulta also I can take. What do I mean by that? Ulta means I can take this one as 1, 2, 3, 4, 5, 6. This also I can take. Then which one to do? Should I take 1, 2, let me write in a different color, otherwise you will only get confused. What I wrote, right? Let me take a different color. 1, 2, 3, 4, 5, 6. This can also be a possibility. This is also not wrong. Which one to take? Should I mark propyl as 1 or should I mark methyl as 1? There should be some rule to determine which one to mark as 1 and which one to mark as 2. So that rule is the alphabetical order. What is the rule? Alphabetical order. Follow? Alphabetical order while numbering substituents. While numbering substituents. Do not violate lowest locant pool. This is also a very important point. You go on marking, very important is this point. This point is far more important than the previous one. That do not violate the lowest locant rule. You go on marking in such a way that lowest locant rule is violated, then that is not a correct name. Then that will be the wrong name. You have to do in such a way that the lowest locant rule does not violate. Clear? Now you see here, 1 plus 3 is also 4 and 1 plus 3 is also 4. Position is as such. The position here is in such a way that from both the sides the sum comes same. So here lowest locant rule is not applicable. Here alphabetical order is applicable. But cases where lowest locant rule can be applied, you have to apply lowest locant rule first. Clear? So what is going to be the name? We are going to take alphabetical order. So this is methyl and this is propyl. P comes before or M comes before? M comes before. So it is going to be 1 methyl, 3 propyl, cyclohexane. Understood? Why 1 methyl? Because of alphabetical order. Clear? Lowest locant rule is not violated because from both the sides the sum comes same. So we have taken that number as 1 whose alphabetical order is coming first. Clear? Next question. Next question. Again I am drawing a hexane. So it is not looking like a hexane. Okay, fine. Now tell me, what is this structure called as? What is this structure called as? Pause the video, try to answer it, then check the answer. Let us solve the question. Very interesting question. Let us solve it. See here. Carbon first locate. Carbon, 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 carbon. I said no, all corners will have carbon. Carbon, 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 right? Carbon. Numbering is in the chain. That is on the ring only, because chain and ring cannot be combined for numbering. Numbering is on the chain, on the ring. So which side to number from is the again question is coming up. Okay, 1. I am numbering from this side. 1, 2, 3, 4, 5, 6. Fine. I number from this side. You may not agree and you will say, no, I will not number from here. I will number from here. 1, 2, 3, 4, 5, 6. Okay. Cannot deny. Cannot deny the fact. Correct. Another person says, no, I will not number from this side also. I will number from another side. Okay. That person also I cannot deny. 1, 2, 3, 4, 5, 6. See here. 3 types of numbering is possible. Which numbering will I take? 3 kinds of numbering are possible. Which one to take and which one not to take? Understand me, very important. I have told you that first thing you have to apply is lowest locant rule, and that is what will be throwing away all the rubbish options and will be giving you only the correct option. See here, I have 3 options. Suppose let me take the violet color 1 and violet color 5. Positions are 1 and 5. 2 methyls are there, so 2, 5. So total is 11. Blue ones 1 plus third position 2. So 1 plus 3 plus 3, 7. Now coming to the yellow one, 1 plus 1 plus 5. Now you see, the violet option is only automatically eliminated. So violet option is not correct. This option is not correct. Gone. This option is not correct. Gone. Now we have 2 options. One is blue, one is yellow. Which one to take? Lowest locant rule is valid for both. Then which one to take? Then in this case, we have to apply the this two are correct. Now for this two, we have to check alphabetical order. Moment the sum comes same, we have to go for alphabetical order. So ethyl will be more than methyl. E comes before M. So here this ethyl is getting first position. Here the ethyl is getting the 5th position. You can see the ethyl is getting first position, 5th position. Which one we will take? That position we will take. At which position? We will take which position? We will take which position? We will take that position at which ethyl is getting the greater priority, right? That means the numbering should start from ethyl itself. If the numbering is start from ethyl itself, then it is correct. Otherwise, it is not correct because of the lowest locant rule. Clear? Clear. So numbering starts from ethyl side. That means the blue one is correct. See here, blue one is correct. 1, 2, 3. Clear? 1, 2, 3. 1, 2, 3. Right? We will be going with this one, because this one is giving you ethyl greater position. So ethyl is at 1 and methyl is at 3,3. So the name is 1-ethyl 3,3 dimethyl cyclohexane. Clear or not clear? This is a very important question. Very important question. Please understand the question. Okay. Sorry, students. There is one error. One error is there. I am explaining this same question to you again once again. There is one mistake. We have not taken the fourth possibility. There is another possibility. Another possibility is here that we have not taken. Another possibility is there which we have not taken. This name won't be correct. There will be another name. See here. What is the possibility we have not taken? Acha, 1, 2, 3, 4, 5, 6. So we have numbered from this side. We can also number from this side. That possibility we have not taken. So I am telling this 1, 2, 3, 4, 5, 6. This possibility we have not taken. This possibility we missed out. That is why the answer was wrong. Anyway. So let me write the color codes. Otherwise I will only forget which one is what. Acha, here 1. Here starting with 1 and 5, 5. That means violet. This one is the violet one. Okay. See, this is a violet one. Starting with 1 and ending with 5, 5. So violet one. So 1 plus 3 plus 3. 1 plus 3 plus 3. 1. Achha, 1. So plus blue one. Right? And this one is the yellow one. Now we are using another one. Is this one to show the last case. What is the last case? I have started numbering from methyl 1. So 1 plus 1 plus 3. That is also a possibility. That gives you total as 5. Now you see the possibility of alphabetical arrangement is not arising only because lowest locant rule is only valid. These three all are wrong, right? This is correct because lowest locant we are getting. So what is going to be the correct name? The correct name is going to be 3-ethyl 1,1 dimethyl cyclohexane. Clear? What mistake we have made? You understand? We have not taken the fourth possibility. I did not look at that. Now I looked at that. The fourth possibility we did not take. That is why we got the 1-ethyl 3, capital. Actually, it is 3-ethyl 1,1 cyclohexane. Clear? Okay. I will not erase this page because you will also make the same mistake like me. I am very dumb in chemistry, so I made the mistake. Okay. So I am just cutting it off, but I am not going to erase the page. Okay. So you can understand where is the mistake. Or let me write here wrong. This one. Okay. This is wrong. Okay. I have written it that it is wrong so that you will not think it. Okay. Clear? This is the correct one. Four possibilities are there that we have taken. Previously we have taken 3 possibilities. That is why the answer was wrong. Understood? Clear? So when lowest locant rule is not applicable, at that point of time only you can apply the alphabetical order. Else you have to apply lowest locant rule only. Clear? No choice. Understood? Okay. Let's move on to the next question. Now you see, we will have a different variety of question now. Till now what we have seen, that there is a ring to which something is attached and that is a substituent on the ring. Now we will see, to a open chain the ring is a substituent. What do I mean by that? What do I mean by right? See, understand what I am telling about. Till now we have seen that this is a carbon chain which I am representing by a line. To the carbon chain we were having substituents. 1 substituent, 2 substituent, 3 substituent. This was the type of question which we have done before. After this, which type of question we came across was this type of question. This is question variety 1. Straight chain, substituent are there, number it. Second variety of question we came across was this type of chain, one substituent, this one further broken down into substituent. That means substituent is substituent. That was one type of question we did. Third type of question we did was aromatic compound. Sorry, not aromatic, cyclic compound. Like, let's say this is one cyclic compound. To this, we have a main chain. To this, we had a main chain. Now, what type of questions we will do? Is there is a main chain. To this main chain, we have a cyclic compound. Understood? This was to the cyclic compound main chain, and this is the main chain. This is the main chain, and this is the substituent. Clear? This is the variety of question that we are going to do now. This was the substituent, and this was the main. Here, there is a ring is the main chain. Here the ring is substituent. This type of questions we are going to do now. So let's begin. Question: CH3, CH2, CH3. Here I am attaching a. Acha, one thing you remember that if the number of carbons in the cyclic ring is more than that of the chain, then only the chain is the functional chain is the main chain. Okay. If there is more carbon in case of ring, then automatically the ring becomes the main chain. Clear? Please take a look at that. Okay. Now what to name this? We cannot name this as cyclopentane. Sorry, what am I saying today? We cannot name this anyway. What will we name this? Cyclopropane. No. What is the state chain doing there? State chain has got no name. We name it as cyclopropane. Right? Then we have to name it as something like complex chain. That means change also chain. That also we will not do. Then what we will do? In this type of question, we have to number the main chain. 1, 2, 3, 4. Again, do not violate the lowest local group. But this side it will get third position. But that is not correct. Acha, by the way, I did not cut the wrong also. They are all wrong. Okay. This blue one is also wrong. Yellow one is also wrong. Only correct is the green one. Okay. These I forgot to do. Okay. Clear? So second position is getting the lowest locus. That's why I keep on saying at no point you can violate lowest locus too. Okay. Ring must get lowest locus. Clear? Ring must get lowest locus. That will not be violated. Now, how to name it? Second position, cyclopropane. This is propane, right? Cyclopropane, butane. Now you tell me, in one compound both propane and butane is possible. Suppose you are given the name to cyclopropane butane. What will you draw? Propane or butane? Suppose this structure is not given. You are only given with the name. You have to draw the structure. Then which one we will draw? You will draw propane or you will draw butane? Obviously, it's a confusion. So we cannot write both propane and butane simultaneously in a name. Then what we will write? Simply, just like in case of compound chain, we have seen that we will not write ethane and methane both or ethane propane both. We will write ethyl and propane, right? So in this case, also in case of propane, we will remove the N. We will write "-ile". It will become cyclopropyl butane. It will become cyclopropyl butane. Clear? So very important one. Very important one. Ring as a substituent. Ring. These are all cases non-aromatic. Okay. Non-aromatic. No aromatic case is here. Aromatic case is different, and I will tell you when aromatic comes in. Okay? Just after this. We're doing a substituent. Cyclo plus word root plus ine. Clear? Here I am writing note no n in ine to be used with root word here. Okay, not to be used does not mean that anybody will not use. No, only in this case you are not going to use that. Clear? Not everywhere. Only in this case you will not use it. Understood? Clear? Another question let us do quickly and we'll move on to the aromatic part then. Okay, suppose I give you a question. What is the name of this compound? Very quick. Very quick. Please try it. Then see the answer. Explanation required. Because this is a very easy question. An explanation required. I don't think any explanation is required for you. Right? The name is 1-cyclopentyl. 1-cyclopentyl cyclohexane. Right? Still I am giving an explanation. See here. This is the attachment point, right? Which one is the main chain? Obviously, this is going to be the main chain, right? Because this has more number of carbon. Clear? Now this is xn again. I hope you all can see that. Attached at which position? First position. So 1-cyclopentyl cyclohexane. Clear? Very easy question. Nothing actually is there. Next question. Next question. Please tie up the question. Okay. More you answer, more better it is. Okay. Here is a which. Here it's a quick. What is going to be the name? Very quick. Very quick. What is going to be the name? I hope you have tried. Now let's check the answer. 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon. Numbering. 1, 2, 3, 4, 5. One way of numbering. 1, 2, 3, 4, 5. Second way of numbering. These are the two primary ways of numbering. Because methyl group you cannot start numbering. At all it is not correct only. It is not correct only. Why? Why? Because a functional group is present and you are charting your numbering from a substituent, that is not accepted only. You have to begin from a functional group. So functional group will be numbered as well. Okay. Basic of cyclic numbering. Cyclic naming says the functional group, the primary functional group will be fixed at position number 1, the primary one. Because after this one I will tell you if there are more than one functional group what to do. So primary functional group must be fixed at position number 1. Clear? So position 1 is OH. No other person is there. Okay. Now either go clockwise or go anti-clockwise. Both the positions I have checked it out. Now we will be seeing which one is having the lowest locale. Lowest locale to apply, check the answer. Clear? 1. Here you see 1 plus 2. Don't take 3 because 2 is the least one. Okay. And this is 4. 7. 1 plus 3 plus 4. 8. So this one is correct. Clear? Which one is correct? This one is correct. Okay. 1 plus 2 plus 4. That means violet one is correct. Clear? Violet one is correct. So wrong. Clear? Why did we do that? Understood? So what is going to be the name? 4-methyl cyclo pent 2 n 1 only. Okay, now naming rule does not change. Whatever you have done before, that is only the naming rule, but the way of naming has changed. That means the numbering process has changed. Nothing different than that, right? Next question. Next question is here. We are having, chalo, try it very quickly. Try it very quick. Try it. Okay, so let's see the answer. Carbon, 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 carbon. So it's a hexane, right? Now where to number from? As I've already told you that the principal functional group must be centered at position 1. Okay, writing it here. Principal functional group to be fixed at position 1. Primary functional group or principal functional group, whatever you say. Principal functional group fixed at 1. Clear? Primary functional group to be fixed at position 1. So who is having the maximum seniority in the seniority table? Of course, UOH is there, means it is first. Clear? Because we remember it is acid, cup. So acid is first of all. Then cup says hardware, but that is not there only. Acid is only first. Clear? And this is the ketone. Ketone is kata. Kata is long back. Ketone is long back. Okay? So center position 1 fixed. Now we can do only 2 cases. Clockwise and anti-clockwise. Right? Right. So we can do only clockwise and only anti-clockwise. So let's check out clockwise and anti-clockwise. 2, 3, 4, 5, 6. Clockwise. Clockwise. 2, 3, 4, 5, 6. Now which one to take? Same thing. Lowest locant rule. Okay? Okay. First let me take for the violet. For the violet color. 1 plus 3 plus 5. It's a 9. Right? For the green color, it's 1 plus 3 plus 5. It's also 9. So both the ways you are getting 9. That means position is just same. So from either side you number, your position is same. So who will you number? Alphabetical order. But alphabetical order also you cannot take. Like suppose you are going for alphabetical order, then ethyl should have been ethyl. That is carboxylic acid. That is ketone. So carboxylic acid, then ethyl, then ketone. Right? Carboxylic acid gone, already gone. First only. Carboxylic acid is first. But oic acid, O is so very late. Then should I send COH back? No, that I cannot do. Try to understand. আমি কি বলছি? আমি বলছি COH কে লিখি তো আমরা ওইক অ্যাসিড। ওইক অ্যাসিড লিখি তো? তাহলে যদি ওইক অ্যাসিড লিখি তাহলে O is to long back। মানে ও এর আগে তো ইও আছে, কেও আছে। তাহলে আমরা ওদের আগে না পাঠিয়ে ওকে আগে কেন পাঠাচ্ছি? We have to follow because our rule says primary functional group is fixed at 1. Then you apply alphabetical order. So alphabetical order is acting between ethyl and alcohol. Clear? Not alcohol, ketone. Clear? In between them you see. When I am writing 3 and 5, aren't the positions getting interchanged? So who comes first? Ethyl's E comes first or alcohol's O comes? E comes first. So in which case is E getting least locant? Case of the green one. In case of the green one. So which is going to be the correct? The green one. Clear? So the name will be following as 3-ethyl 5 keto cyclo hexane 1-oic acid. Any doubt? Fine. We have written a name and we are assured that this name is correct. But I am not assured. Why? I explained you. I gave you what to write, what not to write. But I am not assured that this is the correct answer. Why? Because by saying one thing, something struck my brain. And now I understand that this answer is wrong. That you also have to understand when you are solving a question. Okay. When I was telling you this answer, did I make you feel that I am saying you wrong? No. And this happens during exam as well. Yep. Where did I say it wrong? Somewhere I said wrong. Where is that? Let us make a copy of this slide and then I am explaining you. Why is this answer wrong? You will find me making errors like this intentionally. This was an intentional error. Why? Because I wanted to give you one lesson. Okay. See here. This was a copy slide. Now bring this slide. I said you that COH is centered at position 1. Fine, no problem. Then I said the remaining two positions, alphabetical order will be applicable. But while applying alphabetical order, you forgot lowest locant rule. That is the problem. What is the problem? Here, while applying the alphabetical order, you forgot the lowest locant rule only here, and that is never accepted in chemistry. As I said, everywhere you have to apply lowest locant rule. That you cannot forget only. You can forget your own name, you can forget everything, but you cannot forget to apply lowest locant rule before anything. Here you were going for alphabetical order, very good, but you did not check the lowest locant rule. What was lowest locant rule? Oxidal group, multiple bond, getting the lowest possible locant. When you are writing this, did you give keto? When is the ketone group the lowest locant? Possible locant is 3, you have given 5. How dare you give 5 when 3 is possible for ketone group? Did you understand? Where is the error? When 3 is possible for ketone, why did you give 5? You are not allowed to give 5 if 3 is possible. If it is not possible, then you have to give. If it is possible, then why will you give 5? There is the error. Clear? Here is the error. Understood? The error. So what is going to be the correct name? We are going to number from the side of the purple one. That is this one. Is the correct one. That is number. This is the correct one. So what is going to be the name? The name is going to be 5-ethyl 3-keto cyclohexane 1-oic acid. Clear? Where is the error? Here is the error. Big error is here. Understood the error? I intentionally get that error just to make you all understand. Achha, clear with this? Because this is one very common type of error which we will make. Alphabetical order told. So alphabetical order we will sort it out, but we will not follow lowest locant. We will not follow lowest locant. We will follow alphabetical order. Arey, matlab kuch bhi. You are supposed to follow lowest locant rule before alphabetical order. Then why didn't you follow that? Achha, understood this question? Now do one short question. Then we will move on to aromatic. One short question. Quickly. What is going to be the answer of this question? What is going to be the answer of this question? I hope you have tried it out. So the answer is very simple. This is not the main chain. This person is a substituent because the ring has more number of carbons than the chain. So this cannot be considered as the main chain. So it is going to be 1 propyl cyclohexane. Clear? Very easy question. Very easy. Okay. So we have completed this part. This part means the non-aromatic part. Now we are going to move on inside the aromatic. Where we are entering now? Aromatic compound. First tell me, what do you mean by aromatic compounds? What are aromatic compounds? Let me just give you a brief idea about aromatic compounds. Aromatic compounds. Aromatic compounds means those compounds which are having a sweet smell. Aroma. It may be a sweet smell. Usually a sweet smell. Aroma. They are having aroma. If they are having aroma, we are going to say aromatic compounds. Right? Now you know who is the major aromatic compound. Right? It's benzene. It's benzene. Right? Benzene we are going to consider. What does benzene look like? What we are going to read in the entire organic chemistry is benzene. This, I can also write it as this. I can also write it as this. This is due to resonance, which I will teach in the later organic chemistry. Clear? So this 3% are same, and this is called benzene. And what is the IUPAC name of benzene? Benzene is not the IUPAC name, but we will use benzene because we cannot write benzene's huge name. IUPAC has told officially benzene is applicable, but benzene is not the IUPAC name. Clear? But we will use benzene for every case. IUPAC name, if you have to name it, then it's very easy to name, right? Because you have already learned how to name. First carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon. This way the name. Cyclo, hex, more than one, hexa, 1, 3, 5, try. Clear? So this name is benzene's name. Cyclohexa 1, 3, 5, triene. This is abbreviated as benzene because every time we cannot write it huge name. This is abbreviated as benzene. Clear? We can write in all of these three formats. Whichever format question might be asked, you have to answer it that format. Now we have to learn about some few derivatives of benzene, because many a times instead of the name, they may give you the symbol, that means the structure, and you have to identify it. Okay, few derivatives and naming. Please take a note of it. Okay, benzene I have already shown you. Acha, one more thing, write down over here. If benzene, I don't know, whenever I will be needing it, I will tell you. Fine. Whenever I need it, I will tell you. Okay, I will give you one question, then I will tell you. Not needed now. Fine. Okay. One I am showing you. Benzene. If a benzene has a OH in its head, OH on its head, okay, then it is called as phenol. It is called as phenol. Clear? Benzene having OH on its head is phenol. OH may be here also, that is also phenol only. OH may be here also, that is also phenol only. Clear? Do not be tense. Like if I write a benzene and if I give a OH over here, if I give a OH over here, is it not phenol? Phenol only, na? Why not phenol? Why not phenol? See here, rotate it, na? Rotate it. Then what is this? Nothing but this only. It's also phenol. No need to get afraid. Whichever position one phenol is at, there is phenol only. That is one phenol only. Nothing. No problem at all. Okay, that phenol understood. Next, if I have a benzene group, benzene attached with a amine, then it is called as aniline. This is called as aniline. This aniline and phenol, both we will be studying in resonance. So the structure has to be near them, because both resonance we will be doing. When we will be doing resonance, we will do the resonance for both these. Clear? Now if you do not want to give this circle, instead of that if you want to give that line diagram, then either you can give this side alternate or this side alternate, right? And just like benzene we have done. What I mean is this: either you can give this side, this side, this side alternate, or you can give the ulta alternate like this side only. Either you give, both are injected. Okay. Okay. Next, benzene having a COH function. That may be here also. That may be anywhere. Then it is called as benzoic acid. What is it called as? A benzoic acid. It's called as benzoic acid. These are all very important ones I am giving you, okay? The most important one. This is called benzoic acid. Number 4. Benzene having a acid halide group. That is called benzoyl chloride. Is it called as benzoyl chloride? Benzoyl chloride. Clear? Number 5. Benzene having CHO group called as benzaldehyde. Benzaldehyde or benzene carbonaldehyde. Anything you said, it both are correct. Clear? Benzaldehyde. Another one which is a very important one, that is this percent, that is toluene. Clear? So these are the few important benzene derivatives that you need to remember when you are doing nomenclature. These are all important derivatives of benzene. There are many are there. You cannot remember so many. So whichever important things are there that I have told you, please remember this. Okay. Okay. Now quickly let's do questions. Now let's move on to questions. So here is our first question. Here we have our first question. Achha. What is going to be the name of this structure? Take time, but try. Okay, let's try. See here, whenever you find benzene attached to another ring, what I am saying, you find aromatic ring is attached to another cycloalkane. That is a cycloalkane. This guy is a cycloalkane. I think it is yellow. This person is a cycloalkane. So whenever you find an aromatic ring attached to a cycloalkane, the name you will be writing will be the derivative of benzene. Did you understand? The name you will be writing will be the derivative of benzene. Take the gyan, write the gyan. When aromatic ring is attached to cycloalkane, name is done as benzene derivative. Naming is done as benzene derivative. Clear? So what will be the name of this compound? This is going to be benzene. So the naming will be benzene derivative. So this is a compound chain. You can understand. A ring is also having something. So this will become compound chain. So numbering will be in the form of compound chain. Which position? First position only. So 1. Compound chain. Here if I start numbering, then this will be 1, 2, 3. Obviously I am not going from this side because that will be obviously eliminated by lowest level. Directly I can write 3. Third position methyl. Total is hexyl, cyclohexyl. Then I am writing benzene. Okay. Understood the way of writing? 1, 3-methyl cyclohexyl benzene. Cyclohexyl by 6 membered ring, non-aromatic. Right? Clear? One more question. One more question. Okay. Okay. So you can see to a long straight chain I have applied 3 benzene. What will be the name? What is going to be the name? Gyan, let me give you. Gyan. You all don't know that benzene can be substituent as well. So what will be the name when benzene is substituent? Very important Gyan, okay? When benzene is in substituent, when benzene is in substituent, it is written as phenyl. Written as phenyl. Okay? Bracket I'm writing pH. That means instead of this, if I write pH, that means also this only. Okay? So do not get like I wrote pH initially, then I erased it because you won't know what is pH. If I write pH, that means it is benzene is substituent. Clear? Clear? Okay? So the same question, if I write here pH, then also it is the same. Now name 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Two ways you can number. From this side, if you number, then we are getting 1, 2, 3, 4, 5, 6, 7, 8. Right? From this side, when I am numbering from this side, two sides. From this side, when I am numbering, I am getting 2 plus 4 plus 6, 12. From this side, when I am numbering, I am getting 3 plus 5 plus 7. That is 7 plus 5 plus 15. So obviously this side is the correct. So this side will be the correct number, right? So 2, 4, 6. Triphenyl. Okay. Clear? Very direct thing. Nothing like this and that. Nothing is that. Okay, very direct question. Clear? No doubt? Okay, fine. Next question. Benzene having 3 nitro groups. Then numbering from either side will give us the same result. Right? Fixing 1 at proportion 3, it will become 3, it will become 5. Either you fix, you will get only one answer. This is only one answer is possible. This is 1, 3, 5 trinitrobenzene. Hopefully you know that this is nitro group, right? This is nitro group. Acha. Nitrobenzene থেকে মনে পড়ে গেল, something I did not write over here. Nitrobenzene I did not write. No? Right. Nitrobenzene I did not write. Is also one important question. 7. Don't worry, I have it copied already. 7. If a benzene is having NO2 on its head, here it is called nitrobenzene. Okay? I forgot to mention at that time. Now I have mentioned. Okay? Achha. Now take some care. These are all very important points. See here. Benzene, this position, and even write those. This position, okay, that is position number 1 and position number 2. Which position? Position number 1 and position number 2. That means two adjacent positions. পাশাপাশি দুটো position. This is known as ortho position. represented by O. So if somebody will get O nitrophenol, that means it is orthonitrophenol. Clear? That means both are পাশাপাশি. Nitro on one and phenol immediately the next one. This is orthonitrophenol. In hydrogen bonding, I will tell you orthonitrophenol and paranitrophenol. One is intermolecular hydrogen bonding, one is intermolecular hydrogen bonding. Okay. Now, if benzene is there, this position, and leaving one position is there, another position. Leaving one position, another means 1,3. Then this position is called meta position. What position? Meta position. M. Benzene is there. One position here, one position here, exactly opposite. That is 1,4 position. It is called as para position. It is P. Clear? Understood? Clear? Clear or not clear? Done? So when it is O nitrophenol or P nitrophenol, then you can understand which one is what is O, what is not O, right? Hopefully you all can understand that. Oh, fine. Now let us do few more questions. Then this part will get over, and we'll start with isomerism next. Okay, let's do few questions quickly so that we can start with isomerism. Okay, question. Quickly answer. Okay, very quick. You have to improve your agility. OCH3 OH. Yes. Try it. Try it out. Done? Oh, fine. Let's start. Carbon is here. The carbon I am not marking because now by now you are accustomed to which one is carbon, right? Acha. Acid कब से इस हाल में है साइनाइड आइसोसाइनाइड ने एल्डिहाइड को काटा. We are searching for this person. This is nothing but ether. Ether. You find out this one is aldehyde. Here. Aldehyde. Aldehyde এর আগে কি কখনো এগুলো আছে? No. So aldehyde is the primary functional group. Alcohol is here. Ether is after this. Ether is last person. Okay. So this fix that position one. Not change it aldehyde. Fix that position. Now which side to check? We will take from this side. From this side, anti-clockwise or clockwise? Either you can take from this side or you can take from this side. This side or this side. Which side you will take? Which side will get the lowest locus, you will take that side. Whichever side you will get the lowest locus, you will take from that side. Clear? Here you see. 1, 2, 3, 4, 5. 4 and 5 positions. And from this side is 3 and 4 position. Which is lower? 5 or 4 position or 3 or 4? 3 or 4 obviously. So this side is the correct number. Clear? This side you are getting 3, 4. This side you are getting 5, 6. No. What? 2, 3, 4, 5. 4, 5. Sorry. You are getting 4, 5 positions. So 9 is more or 7 is more? 7 is more. 9 is more. So 7 will be the correct one. Right? So the numbering will be like this. So it's going to be 4. Hydroxy. If you remember, I have already told you hydroxy is the prefix, right? OCH3 is nothing but methoxy. So methoxy. This benzene with a CHO is called benzaldehyde. That's now we have told it. That's now we have told it. This is benzaldehyde. Clear? So we are going to write benzaldehyde, methoxy, benzaldehyde. Clear? Clear? Next question. Next question. And the last question. COH, Br, NO2, By seeing only I can understand one thing. By seeing only I can understand one thing, that I have to fix position 1, 2. Now I have two ways, this side or this side. I will check from this side, this side. 3, 4, 5, 6. 3, 5, 6. Summation is 14. This side. 2, 3. 2, 3, 5. 10. So obviously this side. Clear? So the naming will be, acha, this is hydroxy, nitro, bromo. First is bromo. So 2 bromo. Nitro hydroxy. Hydroxy. So 5 hydroxy. This is 2, 3, 4, 5. 2 hydroxy, 4 nitro. No. 3 nitro. 3 nitro. Benzoic acid. Right. Benzene having a acid. That is carboxylic acid and its top. That is called benzoic acid. So 2 bromo, 5 hydroxy, 3 nitro, benzoic acid. Clear or not clear? With this, we come to the end of nomenclature. Now what we are going to do next is isomerism. What we will do next is isomerism. Isomerism. Next topic is isomerism. So let us know what is isomerism. You have already learned in class 10 about isomerism. Isomerism means the structural formula will be different, but the molecular formula will be same, right? So compounds having same molecular formula but different structural formula are called isomers. Hopefully you all already know this. So compounds having same molecular formula, compounds having same molecular formula but different structural formula is called isomers, right? And the phenomenon is isomerism, that you already know. Isomerism definition is a basic definition because you already class 10. Classification of isomerism, that also little bit you have done in class 10. Isomerism. Classification of isomerism is done in two formats: structural isomerism and stereoisomerism. Structural and one side is stereoisomerism. Okay. Structural isomerism, 3 parts you have done in class 10. The remaining 3 parts that you are going to do in class 11. Stereochemistry is entirely new, it was not there in class 10. So under structural you are having, this is the color. Under structural you have chain isomerism, you have chain isomerism, you have position isomerism, you have functional group isomerism, then you have metamerism, then you have tautomerism, and at the last you have ring chain isomerism. These are the things you are having under structure, out of which the things you have done in class 10, chain, position, functional group. These 3 you have done in class 10, the remaining 3 is to be done. So the first 3 I will quickly sort it out because you all already know that part. Okay. Now coming to stereochemistry. Under stereochemistry you have 2 parts. Okay, and both the parts are entirely new. You have geometrical isomerism. Okay, let's change the color. You have geometrical isomerism. Okay, you have geometrical isomerism, and another one is optical isomerism. Okay, first let us complete the structural isomerism, then we'll go for the stereoisomerism. Okay, so let us start with structural isomerism. Structural isomerism. Number one, chain isomerism. Chain isomerism. What does that mean? The kind of isomerism you will find due to difference in chain length. Major point that you need to remember is difference in chain length. Difference in chain length. The type of isomerism caused due to difference in chain length is called chain isomerism. The definition has a very low chance of being asked in 11, but still you should just know it. Okay, due to difference of chain length, the isomerism that is caused is called chain isomerism. Clear? Like example one I will give you, you all already know the example. Example C5H12. This is what? Pentane, right? Pentane isomer. How many isomers are possible per pentane? 3 isomers are possible, right? N, iso and neo, right? That you already done in class 10. One is the straight chain you will make. How? 1, 2, 3, 4, 5. This is the N-pentane, right? Now if I do like this, this is isopentane, and if I do like this, sorry, then it is neopentane, right? Hopefully you can understand bond line structure. I have not used the carbons, right? You all know where the carbons are located. Here, 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 and here. Here, 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 here. All are having 5 carbons. Check. 1, 2, 3, 4, 5. Right now, the IUPAC names you need to write. Not only the common names, the IUPAC name also you need to mention when you are writing isomers. Okay? This is pentane. IUPAC name you have to mention when you are writing. Isopentane is the common name, not the IUPAC name. So common name you cannot write in the exam. IUPAC name you have to write. Pentane, isopentane. What is the name? 1, 2, 3, 4. 2-methyl propane, right? 2-methyl propane. What propane I am writing? 2-methyl butane. 2-methyl butane. And this is 2,2 dimethyl propane. 2,2 dimethyl propane. Right? So these are the isomers, and these are all chain isomers. Why? Because the main chain length is different. Clear? The which chain? Here I have written difference in chain length. Which chain length? The main chain length. Hopefully you all can know that. Right? Main. I am writing here main. Main chain length difference should be there. Clear with this? Any doubt? No doubt. Now let me give you a quick question. Quick question. See, I have 2 structures. 1. Okay? And I have structure number 2. Now you tell me, what do you think are these type of isomers? Which type of isomers are they? Which type of isomers are they? Okay, you may not know the answer. Fine. Then we will take up the question later. You may not know the answer, I have said. Because this is not only chain isomerism, something else is also involved. So you may not know the answer. So let us keep the question for later, but we will solve this question. It is a very interesting question. Okay? Fine. Chain isomerism done. Now next we'll move on to the next type of isomerism, that is position isomerism. Position isomerism. Position isomerism is the type of isomerism caused due to difference in the position of functional group or unsaturation, or it can be a substituent as well. So what causes this isomerism? Difference in position of functional group, unsaturation, and substituent. Clear? Main chain has to remain same. Main chain will not change. If main chain changes, then it is not position, it is directly chain isomerism. Clear? Because this is a common mistake that you all will make. So difference in position of functional group, unsaturation or substituent, this will cause position isomerism. Let's take an example. We have, let us take not the electron, sorry. We have this and we have this. The main chain remains same, but the position of the double bond I have changed. So these are all position isomers. Clear? These are all position isomers. This is but 1 in, while this is but 2 in. Clear? So position I have just changed. Main chain, no effect. Clear? No effect on the main chain. Because this is very important. Main chain cannot be affected. Main chain will be main chain. Okay. Now, in nomenclature I have told you 3 positions, if you remember. Ortho, meta, para. Last day only. Not last day, I mean before only. This one. This one I have told you. These are also position isomers. If you carefully see, these are also position isomers, nothing different. Main chain is the ring only, just positions we are shifting. So these are all position isomers. Clear? So example if I give you, another example if I give you, like second example. Benzene, if I write chlorine, chlorine. These are all position isomers. Clear? This is ortho dichlorobenzene. This is ortho dichlorobenzene. Ortho written by O, okay. Meta dichlorobenzene. Meta-dichlorobenzene, and this is para-dichlorobenzene. So these are also position isomers because the formula remains same, the main chain remains same, only changes in the position. Clear? Next type of isomerism. Number 3, functional group isomerism. Functional group isomerism. In this type of isomerism, we will find that the functional group is different. What is different? Functional group is different. Different functional group. Don't expect the molecular formula to be changed because it is an isomer, right? So different functional group will be present. How? Let's see an example. Let's take an example. C3H6O. This way it will be given in the exam. C3H6O. What are the isomers possible for this? Now, by seeing this thing, you can divide it into 2 parts. CH3, C2H5. But this becomes 8, right? So CH3 C2H5 is not a possibility for this. CH3 C2H5 is not a possibility. Why? Because you can see H3 plus H5 becomes H6. So it is not possible. So that means ether is not possible. What is not possible? Ether is not possible. Because for ether it is divided into equal alkyl group, right? So ether is not possible. This is how we are going to check out which one is possible, which is not possible. Ether is not possible from this because ether requires at least two side to alkenes. CH3, CaO, CH3 will if I give, then where will I place the other carbon? Here this side. Then the CH2 will be remaining. Still again it will become total 8. I cannot place here like how much is there? 6. No, here only C2 I cannot place. Then ether is not possible. Right? Then what are the other possibilities when we go? Either carboxylic acid, aldehyde, or ketone, or alcohol. Right? So is alcohol possible? C3H5OH. Is this alcohol? No. This is also not possible. Alcohol is also not possible. Why? C3H5OH is not alcohol. C2H5 is alcohol. Right? So the alcohol is also not possible. Then we are left out with ketone and carboxylic acid. Ketone, carboxylic acid, aldehyde. Acha. Carboxylic acid is not possible only. Why? Double O is not there. For carboxylic acid we need 2 O. That is not there. So throw out carboxylic. So we are left with 2 possible, aldehyde and ketone. Let us check. For ketone we need this and we need 2 more. So we can easily place it. So this is possible. This is called propan-2-one, commonly called as acetone. Very common name, acetone. Clear? This is possible. This is possible. Now another one is possible is aldehyde. Whenever ketone comes, aldehyde will come. Please remember, whenever ketone comes, aldehyde will come. Clear? Ketone coming, aldehyde has to come. How aldehyde will come? Let us check. Aldehyde means C double bond O with a H. So I have taken CHO from there. So from here if I minus CH, what will I remain? C2H5. So that C2H5 will be addressed over here. Clear? So how much? Propanol. Clear? So this is propanol and this is acetone. So these are the functional group isomers. Clear? These are the functional group isomer. Any doubt? No doubt? Okay. Another example, let's take C2H3N. This N percent is very important percent because N percent can form this way as well as this way. There are only 2 isomers you will get. Whenever you find nitrogen containing isonitrile, nitrile isomers, obviously. So how will be the arrangement? Arrangement will be like this C2, right? So it can be C triple bond N and there is another CH. This is one possibility. Another possibility is clear. These are the possibilities that can be done. So this is ethane nitrile, and this is methane isonitrile. Clear? These are also functional group isomers. Understood? 3 things we have done till now. We have done Fission isomers, chain isomers, functional group isomers. After doing these 3 things, now we will try out the question that I have given to you before. Which question? This question. This one. Okay. Now we will try out this question. Let's see. After doing all 3, now we can do the question. So here is the question. We have carboxylic acid group, we can see, but at one different position. Here it is over here and here it is over here. Different position I have given. So what type of isomer do you think is this exhibiting? Position isomer? Position isomer? So writing the answer, position isomer. Position isomer. Many of you will say it is position isomer, but actually it is very much wrong. Very much wrong. Position isomer is not the case. The answer is chain isomer. Why? Why? This visible position is different, then why will I write chain isomer? This is a very common mistake. Visibility is not the case. You have to do and get the answer. By seeing, if you could have done everything, then why do you need a pen and copy? Then by seeing only will do everything. Every time what you see is not correct. That's like that mango what he did, right? Seeing everything is not the case, right? You are deceived by these things. So see here, COH is a terminating functional group, right? Terminating functional group means what? The chain terminates with that, right? So if I take the main chain as 1, 2, 3, 4, 5, 6. Here if I take it as 1, 2, 3, 4, 5, 6. I can take it. But you are not giving the lowest locant to the carboxylic acid. You are not taking it in the main chain only first of all. You have to take the functional group in the main chain. No, you are not doing that. Then where will the main numbering start from? The numbering will start from the carboxylic acid functional group irrespective of its location. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Clear or not clear? So based on position, position को leap position, this is chain isomer. Clear or not clear? Now miraculously the position is coming, the amount of chain is also coming same, but this is actually chain isomer. Clear? This is actually what? Chain isomer. Difference in chain length. Clear or not clear? Clear or not clear? This type of question is interesting question. Understood? Still now did not understand. Fine. I will make one change to make you understand that why it is chain isomer. These are chain isomer. Okay. Why it is a chain isomer? Now see, I will make one change and you will understand why it is chain isomer. So let us copy this. Now see. This is not a position isomer, it is a chain isomer. See what change I will make. One line, entire line. I will remove one. Okay. Now you tell me. Just one I have removed. Now you tell me. Chain length is same, formula is same, but is chain length same? No. Then what type of isomer? Chain isomer. Now it is clear. Now it is clear. Last time I took hexane from both the sides is 3 3 like that. Last time it was hexane if you see. Both the sides will come same. That was the problem. This time I reduced it to pentane. Now one side will be more than the other. Acha, clear? Why it is chain isomer? Okay, this is not going to be functional group isomer, so definitely not, and not position isomer. Okay, but seeing COH is located there at another position, here it is little bit another position, but I am marking it is at position isomer. It is going to get wrong because it is actually chain isomer, not position isomer. Clear? Okay. Next, we are moving on to the fourth type, I guess. Yes, fourth type. Fourth type. Metamerism. This you have not learned. Metamerism. Metamerism means two conditions you need to remember. Okay, two conditions. Functional group, same. Okay, there is going to be no difference in the functional. Second case, uneven, not uneven, uneven will be not a correct word. Different distribution of alkyl groups on either side of functional group. Different distribution of alkyl groups. If it is there, then this type of isomerism is called metamerism. Example, obviously with an example otherwise how will you understand what is it, right? Example. Example is here. Suppose I have C4H10O, right? Ether, otherwise OH is a terminating group. OH is a terminating group. COH is also terminating group. CHO is also terminating group. These are all terminating group. I cannot give terminating group. I can give ketone or I can give aldehyde. Right? With ketone you cannot prepare any. With ketone also you can do. Here in this case with ketone also you can do, but I am doing with ether. Ketone also is possible. As far as I think ketone is possible. Wait, let me check. CH3, C2H5. No, ketone is not possible. Ketone won't be possible. Here, ketone is not possible. Okay. C double bond no, CH3. No, ketone will not. Ketone is not possible. Ether is the only possibility. Okay. So on this side I can write C2H5. On this side I can write C2H5. I can write two. Right. So I can write this as ethoxyethane. Ethoxyethane. Now O, one side if I shift C3H7, other side if I leave CH3. Ulta also you can write. This side you will write CH3, that side you will write C3H7. No problem. But I have to write. Okay. Then the name becomes methoxypropane. This is also the same formula. But if you see, this side you have ethyl. This side also you have ethyl. This side you have one propyl, one methyl. So we have changed the alkyl distribution on both the sides. If this is the case, then this type of isomerism is called metamerism, where changing is the alkyl group or other side of functional group. Clear? Understood? Understood? This is metamerism. Next we will read about tautomerism. Number 5, tautomerism. Number 5, tautomerism. You can say it as tautomerism as well. I say it as tautomerism. Okay. Number 5 is tautomerism. This is something which you have not studied before. Tautomerism is a new topic for me. So let us discuss about it. In tautomerism, in your syllabus, you have keto, enol, tautomerism. Okay. So what we will discuss is keto, enol, tautomerism or tautomerism. Clear? Keto, enol, tautomerism. Other than this, you have many other type of tautomerism as well. Those are in JEE NEET, but not in your IS syllabus. Okay. Like you have nitroso oxime tautomerism. Nitroso oxime tautomerism. Then you have amido to imido tautomerism. Another one you have is HCN and HNC tautomerism. Cyanide tautomerism. Clear? But which one we are going to read? We will be reading about only this one. Clear? These are not in our syllabus, but just I have told you. Okay. So let us read about keto, enol, tautomerism. Keto, enol, tautomerism. Now you see, in case of tautomerism, what will happen is the acidic H must reach the O. Okay. Here I am writing. Just I am writing over here. Get the box. acidic H must reach O. Okay, what I mean by this, that I will tell you in the next page. But acidic H must reach O. This is the sole criteria of tautomerism, which will be required for solving JEE mains questions as well. Let us see what do I mean by this. Suppose I have, okay, this is a hydrogen. I have just shown the hydrogen. Usually we don't show hydrogen in one line. Okay, here there is a ketone, that is double bond. What I mean by acidic H must reach oxygen, this hydrogen must reach over here. There only enol can be formed, otherwise not cannot be formed. Okay, so the sole criteria to check for whether tautomerism is possible or not possible is whether oxygen can get hydrogen or not. If oxygen cannot get hydrogen, tautomerism is not possible for that case. Clear? Now how will this hydrogen go here? In presence of a base, that means OH minus, right? OH minus. This electron pair will shift here. Clear? So what will happen? A minus charge will develop over here and the hydrogen will be free. This hydrogen will be taken up by this OH minus. Okay? Minus is here, this. Now, this can undergo resonance. Double bond. Okay, hopefully you all know what is resonance. A little bit idea of resonance you already know. The next time I will tell you what is resonance. Right? We have resonance later on, but right now I cannot help. I have to show a little bit of resonance. Due to resonance, this minus will form a bond over here, a double bond, and this double bond will break. Clear? So, remember one thing. Let me add a slide. Remember one thing. In case of homolytic cleavage, what is that? That also I will tell you. Homolytic, heterolytic, whatever. In case of homolytic cleavage, half arrow you will show that one electron goes here, one electron goes there. This will lead to the formation of free radical, represented like this. Okay, this type of thing is called homolytic cleavage, that I will talk about later. Just I am giving you an idea now. Homolytic cleavage. If A B bond breaks in this way, that means the entire arrow is pointing towards some element. Here you can see half arrow I have given. Half arrow towards this, half arrow towards this. Here the arrow is towards someone. Whosoever is facing the arrowhead, arrow mathata jar dike ache, that will get the minus charge. A plus B minus. This guy is getting the electron, so electron will be excess, so that is getting a minus charge, and electron from A is getting to B, that means A is getting a deficit of electron, so A will take up a positive charge. Clear? This is called, in chemistry, in organic chemistry, this is called free radical, which I will talk about later. Free radical. Okay, this thing is called carbocation, and this thing is called carbanion. Clear? These are not cation anion simply, these are carbocation, carboanion. Clear? Not carboanion, carbanion. Okay, clear? So whosoever is facing the arrow will get minus charge. Now let's come back over here. Just shift the slide a little bit. Arrow is towards this person. Here you see arrow is towards this person. So this person is getting a minus charge. So that I have written over here. Clear? Okay. So what will this result in? This will result in the formation of a double bond. Here. This double bond will break and oxygen will get a minus charge. Same thing. Arrow facing towards oxygen. So oxygen will get a minus charge. So this will be the structure. Now This in presence of water. The water was already formed over here. If you can understand, this will give you water, nothing but water, right? H plus and H minus will give you nothing but water only. So in presence of water, what will happen is, water structure, if you remember, is this way, right? This is the structure. One of the hydrogen from here will be taken up by this person again. What will happen? One of the hydrogen from this will be taken up by this person again. That means here also what will happen is OH minus. Okay. So actually the structure that will be formed is this structure. And this is called the enol format. And this is called the ketone format. Clear? This is the keto and this is the enol. What is happening is all this is happening. Clear? Clear? This is the mechanism of keto-enol comparison. Understood what is happening? Just simply it is taking a hydrogen. From the compound only it is taking a hydrogen. Clear or not clear? Let us do one more example. No, let us do the question only. Question. CH3 tautomers. What will be the tautomer? The isomers are called tautomers. Okay. So what will be the possible tautomers of this? I want only one. As of now, one. So it's very easy, right? Very easy. From here you remove one hydrogen. It will become CH3 C. Let me copy the question first. CH3 CH2 C double bond O CH3. You remove from here or here. Vapor is same. Vapor will be same. Okay. So I am doing only one. This, we use a different pen. This will shift here, right? And here one hydrogen will be going out. Let me expand this. Like, what I mean is, here CH2 is there, right? This CH2 is like this. Can I write like this? Right? So this hydrogen is going out. Right? So what is the immediate next step? Immediate next step is CH3CO minus. I am writing the step. You need not write the step. Directly your answer. Okay? If mechanism is asked, there only have to write the step. Otherwise, not needed. CH. Arrow towards carbon minus. Minus. Here arrow is away from carbon. Positive. C. Right? This minus and plus are very much attractive force. Plus and minus are very attractive. Right? So they will form a double bond. So CH3 C O minus double bond CH C double bond O CH3 plus H plus. Now you know what will happen. This person will come here. Clear? So what is going to be the final product? CH3 C single bond OH double bond CH C double bond O CH3. Right? Now tell, clear or not clear? Clear or not clear? This is going to be the answer. Clear? Clear? Very easy? Right. Now, if I give you a structure like this, usually in JEE this type of questions are asked. Given a structure, how many tautomers are possible? This type of questions are asked. How many tautomers are possible? 2 tautomers are possible. 2 tautomers are possible. Why? Because the position of double bond will change. Why? You tell me here which hydrogen can reach oxygen. Here if you carefully locate, here there is hydrogen. 2 hydrogens are there. 2 cannot reach. Only 1 will go. Here also 3 are there, but I will take only one. Here hydrogen is there. Here also hydrogen is there. This hydrogen is very far away. There no double bond is there to cause resonance. So it is impossible for this H to reach the O. Never possible. Never. Clear? So this H is not a possibility. This H, even if this is due, double bond is not there to take it to O. It can reach over here. Maximum. That also it cannot do. Here minus will be caused. Who will transport this minus will come here. Then what? Nothing. No problem. So even this H cannot reach. This H, yes, this H can reach. Minus will cause a bond formation here. This will break. And this will also cause a bond formation. This will also break. So this H and this H. Very good. So how many isomers? How many, sorry, tautomers? 2. Clear? This is how to sort it out. In JEE, the questions they will give you will be, structures will be like that. Then you will see what is this. But actually, if you try to count, clear with this part? These type of questions are often asked in JEE mains. Very often asked in JEE mains. Like one question I had, right now I cannot get it. One question was there. The structure was very awkward looking. Actually, the solution was very easy. Cannot get the question right now. Okay, I got the question for you. Let me write down the question. Okay, this was the question, and the question asks like, is tautomerism possible? The structure is to what is the structure? Actually, the question is very easy. Looking like the question is very difficult, but if you go solving it, you will find the question is very easy. Okay. Okay. Here 1, 2, 3. Not possible. Here you find what hydrogen is there. Easily hydrogen is there. So this is possible. Anywhere hydrogen is possible or not? Clear? Here hydrogen is possible. Here also it is possible. Anywhere you get it not. Very easy question. Okay. This is done. Now number 6 is ring chain isomerism. Number 6, ring chain isomerism. Usually from ring chain isomerism, no question is asked. Just we have to tell you, that is why we tell you. Nothing is there actually ring chain isomerism. What is happening is, a ring is getting, a main chain is getting converted to a ring. Okay, a main chain gets converted to ring. Full kotha is, open chain gets converted to ring. Writing here in very short. Open chain, ring. That is cyclic. Clear? Like if you want to check an example, then you find out. Clear? Hopefully you can number and name. I am not writing the number or name. So clear? Okay. Now we are completed with the part of structural isomerism. If you remember, we have started with the classification of what isomerism we are going to study. So I show it to you. Here you see, we have completed metamerism, we have completed tautomerism, we have completed ring chain isomerism. So we are done with structural isomerism. The next topic which we are going to start is stereoisomerism, which is completely new. Stereoisomerism. Let us begin with stereochemistry. Stereoisomerism. Stereoisomerism. First point. Formula same. This is to isomerism's only definition. Formula same. That already know. Second point. Structure is same. Structure is same, then how it is an isomer? It is an isomer. Because something is different, not the structure. Something else is different. What is different? In 3D it is different. Different spatial arrangement. What is spatial arrangement? Many of you say spatial arrangement as well. It's fine. That is arrangement in space. Okay, arrangement in space. In space, the arrangement will be different. So different spatial arrangement. Due to different spatial arrangement, their physical chemical properties will also be different. Okay, properties are different. Properties are different due to configuration, that is due to the spatial arrangement. Clear? Configuration in space. Clear? Properties will also be different due to the configuration in space. So the first type of stereo isomerism we are going to study is geometrical isomerism. Geometrical isomerism. The first one, geometrical isomerism. Geometrical isomerism is seen for alkenes. Usually it is seen for alkenes, and we will be also showing for alkenes only. Clear? Geometrical isomerism seen for alkenes. We will see for alkenes only. Alkenes. Seen for alkenes. Clear? How or what is geometrical isomerism? Geometrical isomerism means if you are passing a particular plane, then either same group of atoms are on the same side of that plane or on different side of that plane. What do I mean? Obviously the question is what do I mean? See here and understand. Suppose I have C double bond C, I have a R group. R is an alkyl group. Fine. Okay, first let me write the open chain. Suppose I am taking the example of C double bond C. Okay. I am taking the example of this. Oh, sorry. 1, 2, 3, 4. Now, without bond also it is okay. Really not wrong. Okay. So this is the structure I have taken for my consideration. Okay. This is a normally I write. Now what we are going to do is the geometrical arrangement. Now you see what will happen. C double bond C. Actually, in space we will write like this. Okay. I am writing Cl. I am writing H. Both sides to not Cl. Nah, Cl is not on the same side, right? So we cannot write both Cl on the same side. That much common sense you should have. Now, fine, no problem. Acha. This is student A. Student B writes the same thing, copies the same thing. Right, sorry, mistakenly copied different thing. Student B copies the same thing. What does he do? He just changes the position. Who is wrong? Who is correct? No, both are not wrong. Because both are within the same thing, then this must be isomer. So this is our isomer. These two are isomers. Clear? Here I will pass a plane of symmetry through the double bond. Through the double bond I will pass the plane of symmetry. Like this. Through the double bond. Here I have written a little bit back, so the line is not coming straight. But it will pass like this. Clear? Now you see. On the side, on one side, same atoms are there. Here, same atoms on one side. Here, different atoms on one side. So when there is same atom on one side, we call it as cis isomer. Clear? Similar atom will be on the same side of double bond. Okay. When it is not the case, then it is trans isomer. Then it is trans isomer. When different atoms are on the different same side. Different atoms are on the same side or same atoms are on the different side. Same thing. Clear? Understood? So let's write down that, otherwise we will forget. Same atom on same side means cis isomer. Same atoms on different side trans isomer. Clear? Understood? Any doubt? Okay. Understood? Now, I give you C double bond C, that is propene. How many geometrical isomers are possible for propene? How many geometrical isomers are possible for propene? Only one. Only one geometrical isomer. Why? Jolzel keep. Further you do the structure, right? Propene looks like C double bond C, CH3, 1 H is here and 3 H is here. Right? If I expand this, it will look like this. Okay, and 1 H is below the plane. Leave that. 1 H will be below the plane. That I am not showing. Actually, there are 3 H's. Right. 3 H's. Actually, there are 2 H's. Both are on the plane. I mistook it as third H. Leave it. Never mind. There are 2 H's. If there was a third H, that would have been under the plane. Below the plane. I mean, these are all on the plane. Because you all know these are planar. These are planar. Double bond is planar. Clear? Acha. That was my mistake. I admit. Okay. C, 2 H's are there. Double bond. C, H and CH3. Now, I cannot replace the H. Even if we replace the H, what will be the difference? What is going to be the difference? The H is on the different side only, no? H is on the different. Someone will say H is on the different side. Someone will say no, it is on the same side. Where the debate comes in? The debate comes in over here. Here to H is here also, here also, here also. Someone will say cis, someone will say trans. Then what? This is not only there are no geometrical isomer. Only one, that is the structure itself. Clear? No cis-trans geometrical isomer are possible for this. The structure itself with an isomer and that is a geometrical isomer. Clear? So if the question is asked, smallest cis-trans isomer shows which alkene? Butene. Clear? Clear? Just know it, I am not writing it. The smallest alkene to show cis-trans isomers is butene. Okay. Done. Geometrical isomer is done. For ISC it is done. For J, not done. Many more are there. Plane of symmetry, center of symmetry, axis of symmetry, many things are there. That is to be done in JE class, not here. So right now, let me complete the ISC first. Okay. These things are also there in JE. Much more is there in JE. Okay. Next, I am going to the second part. Optical isomer or optical isomerism. Now coming to an entirely interesting and difficult part as well, I will say. Quite difficult, but very interesting. Optical isomerism. First, you need to understand what is optical. Optical means something related to light. Right? You have an optic nerve. You go to an optical shop to buy chashma that are all related to your vision. A light. Mukatha is light. So optical means something related to light. So these optical isomers have been found out by using light, plain polarized light passing through some solution. There we find that light is deviated towards left or towards right. From there we have said optical activity. Left side is levorotatory, right side is deuterorotatory. That we will talk about a little bit later. First you need to know about optical meaning, that is light. Optical means light. How is light created over here? We will be passing plain polarized light through the solution, and then we will see if the solution is deviating the light towards right or towards left. Then we can say that it is going to be optically active. Clear? Optically active. So first thing we need to know about is optical activity. Optical activity. What is optical activity? Optical activity means when light is passed, it can bend the light, it can deviate the light towards right or towards left. That is called optical activity, and this is due to the presence of chiral carbon only. Clear? Optical activity. This is the first condition for optical isomerism. Optical activity has to be there, otherwise how can optical activity isomerism happen, right? Second one is chiral carbon. What is the carbon? Chiral carbon. Not era carbon. Chiral carbon only. But this will prove to be an exception in some case. Okay? Why? Because we will see meso compound. After this only I will tell you about meso compound. There you will find, despite the presence of an chiral carbon, no optical activity. Okay? So chiral carbon, optical activity. What is optical activity? When you pass polarized light, through the solution, if it is going to bend the light, then it is optically active. Clear or not clear? Clear or not clear? Now let us discuss a little bit about chiral carbon. What is a chiral carbon? Optical activity understood. Very good. But what is chiral carbon? See, understand. I have a carbon. Okay. I have a carbon to which I have a COOH group attached. I have a NH2 group attached. I have a hydrogen group attached, and I have a R group. That R group is not hydrogen. I am writing it over here. R is not hydrogen. Except hydrogen, anything else it can be. If it is hydrogen, not a chiral compound. If all the four groups attached to the carbon is different, what I said, if all the groups attached to a carbon is different, then the carbon is said to be chiral carbon. Which carbon? This carbon? No. The carbon to which the four different groups are attached is said to be the chiral carbon. Here. So what is chiral carbon? The carbon to which four different groups / atoms are attached. Clear? So the carbon to which four different groups or atoms are attached, it is said to be chiral carbon. Now chiral carbon only will not be this. This is amino acid structure. This won't be the only chiral carbon. I have just shown an example of chiral carbon. Okay, don't take this is the chiral carbon. Exactly will draw this and come. No. Any others are also possible. Clear? What is this? This is nothing but amino acid general structure. Amino acid general structure. Clear? But please remember that if R becomes H, that means it is glycine, then it is not optically active. Clear? This is amino acid general structure. H, C, COH, NH2, H. This is called glycine, and this is optically inactive. Okay? Because this is not a chiral carbon. Optically inactive. I have just written it aside. This R must not be H in this case. Clear? Now you understand. If the four different groups, if the groups are different, Okay, let me go to the next one. See here, understand. Tetrahedral geometry, right? Single bond sp3 sp3 hybridization is tetrahedral geometry. That much you remember. sp3 hybridization is tetrahedral geometry. So how does tetrahedral look like? Like this, right? So let me align in such a way. COH, H, R, NH2. If I place a mirror here, what is this? A mirror. What will happen? Mirror reflection. Right or wrong? Right or wrong? If I take in the mirror, this will be this. Simply, NH2 will exchange position. Nothing else. Just left becomes right, right becomes left. This will also happen here. Now, if I am picking up this image and trying to place it on the second image, this is image number 1, image number 2. Image number 1 থেকে ধরে তুলে image number 2 এর উপর থাপা. Will it be exactly overlapping the second image? What am I saying? Understand? Image 1 I have picked it up and I am trying to place it on image number 2. Will it exactly overlap each other? Acha, you will say this NH2 and NH2 are ulto. Are that much ulto you ignore. That you ignore. That is not the case. That can be COH as well. No problem is there. But will it exactly overlap each other? If I am picking up the image as it is, not rotating back, মানে উল্টো করে দিলাম না image তো it no, not that. If I am picking up this image as it is and placing it on image number 2, will it be exactly overlapping each other? No. The inversion don't consider. Okay, that COH has become HOC, it will not exactly overlap. That you don't consider. Think it as COH only. Even if it is COH only, then will it exactly overlap? No. It won't exactly overlapping. Right? Right? So chiral carbon, if you take mirror image, they will never be exactly overlapping. Clear or not clear? If any case, any chiral case, take the image, you will never get exactly same. That means one image will not completely overlap the other image. Clear or not clear? Clear or not clear? So this is very important. Tell me, clear or not clear? Clear? This type of compounds are called enantiomers. What is it called as? Enantiomers. Enantiomers. This is called enantiomers. That means, what is enantiomer? Non-superimposable mirror image. Non-superimposable mirror image. Clear? Non-superimposable mirror image of each other. So they are mirror image, right? But they are non-superimposable. So they are enantiomers. Clear? Clear with enantiomers? Non-superimposable mirror image of each other. Mirror image will be there and they will be non-superimposable. Then we'll call them as enantiomers. Clear? Now another one. Achha, you have not learned Fission projection actually, but this type of representation is Fission projection. Okay. Okay. Here every junction is a carbon. Here is a carbon. Here is a carbon. Okay. Achha. H, OH, OH, CH3, COH. Okay. This is the compound I have taken. If I have to take a mirror image of this, what will it be? If I have to take a mirror image of this, both the waves will shift that side. So mirror image will be, we copy this only, we have to draw it. This will be the mirror image. So these two are enantiomers. Again the same case. These are enantiomers because H will go on OHZ and OH will come on HZ. Those are not superimposable. So they are optically active. Okay, this is optically active. Okay. Okay, this is also optically active because they are also not superimposable mirror image. That is enantiomers. Right. Now, suppose, did I copy it? Now, if I give the same compound, okay, if I give the same compound and I give another compound to you, like here H, OH, CH3, COH, OH, H. Are these two enantiomers? No, these are not enantiomers. You take the mirror image of this, you are supposed to get this, but this structure is not this. Then this mirror image is not this. Then they are not mirror image of each other. They are not superimposable, that is correct. But they are not the mirror image. The fact is they are not superimposable. Fine. But they are not the mirror image of each other. Then how can we call them as enantiomers? Then there must be some other name. That name is called diastereomers. What is the name? Diastereomers. 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 Diastereomers means non-superimposable non-mirror image of each other. Clear? They will be non-superimposable, but they won't be the mirror image also of each other. Then this type of compound is called diastereomers. Understood? Clear? Any doubt? No doubt? Next one. Okay. I am giving you a structure. The structure is, first let me write a formula. The formula is okay, and this is a famous question. Tartaric acid came in half yearly also. Tartaric acid. Okay, how many stereoisomers are possible? How many stereoisomers are possible? Okay, acha. That deuterorotatory and levorotatory I said once. In details, it is not there in ISC, so I did not expand it. I just said you the name. Levorotatory and deuterorotatory. If it is going towards the left, it is levorotatory. Going towards the right, deuterorotatory. History geography of that is not needed. Okay. Tartaric acid. Number of stereoisomers 3. Right? The question came in RPD, right? 3. 3 isomers are possible. Number 1. DNL. DNL is possible. Like, you don't want to draw the danda. We were drawing a danda icon, so between danda. You don't want to draw a danda. Fine, don't draw danda. Actually, the danda is nothing but 2 carbon, representing the 2 carbon. If you want to draw danda, very good. If you don't want to draw danda, don't draw. No problem is there. You can draw 2 carbon. Clear? That danda, no one is forcing you to draw. No one is forcing you to draw the danda. Okay? Okay. So I am not drawing a danda this time. See, 2 carbons I have drawn. Hydrogen is on one side. OH is on this carbon only. On the other side I will write, not on the same side. COH on the matha. Same I will go for this. Below COH. This side it is H. I can write this side H, I can write this side OH. Please do not write this side OH, this side H. That is not possible. Okay, don't interchange the position. Okay, this is one. Okay, this is one. Number 2, COH, COH, H, C, H, OH. Now see, I have interchanged the position. One I have kept that side, one I have kept this side. Because I knew that that can also happen and that can be an isomer. This is one case. Okay. Now if I have drawn this, then why not the ulta? That means OH here, H here, that is also possible. So that will be the mirror image of this. That will be the mirror image of this. Right or not? If I place a mirror over here, then whatever I will get, that will also be an isomer. Right? So that isomer I have to draw also. COH, C, HOH, C, OH, H. Right? So these are the 3 possible isomers for tartaric acid. Very famous question. 3 possible isomers of tartaric acid. These are the 3 possible isomers of tartaric acid. Now question will be, why are we not taking the mirror image of part number 1? Why no mirror image of part 1? Because that is a meso. What is that? Meso. That is a meso compound. So no mirror image is possible for that. It is, I mean, you can place it in before of a mirror, but no mirror image will be taken for that. That is a meso compound. Okay. What is meso compound now? Right? Very good question. What is a meso compound? Let us know about meso compound. We have learned about enantiomers, non-superimposable mirror image, diastereomers, non-superimposable non-mirror image. Right? Now comes meso compound. Now comes meso compound, the exceptional person. Meso compound is the exceptional person. Meso compound. As I have told you before, that chiral carbon containing compound is optically active, but this compounds, despite having a chiral carbon, is optically inactive, and this is called meso compound. Despite having a chiral carbon, it is optically inactive, then this type of compound is called meso compound. Why it is optically inactive? Due to symmetry, and that symmetry is not taught to you in ISC. Okay, that can be center of symmetry or position of symmetry. Either due to center of symmetry or due to position of symmetry, this happens. Okay, clear? Example, we will give. First let us write the definition. Despite, okay, please frame it. I am writing the main part only. Despite presence of chiral carbon, optically inactive due to center of symmetry / position of symmetry. Or you can write simply symmetry, because types of symmetry I have not done in ISC. Okay. Example, right. Tartaric acid only, meso compound. You see, you pass a plane from here. Change the color. Okay. I have passed a plane from here. What will you do? Lower part. Wait. Let me do it for you, then you will understand. This lower part. This lower part, if I place it on this, not exactly. Now I have to reverse it. Now I have to reverse it on this. Okay, because this is not side by side view. Na? You are not taking a side view of this. Initially what you are taking is side view. You can see side view. These are two different compounds. You are taking a side view of this. This is the part of the same compound. This is not a mirror we are placing in between, breaking the bond and placing. So here you have to bend the lower part on the upper part. What I am meaning you can understand. This lower part, you will be bending it. Clear? That means it will become exactly like this, whatever you have seen above. This thing, when you bend it and place it on that, exactly the upper part will come. Okay, that means what I mean is this will be bended. So if I bend, not bended, very bad English, bent. So this will become like this. Now when I place it on this, exactly it will fit on that. Exactly it will fit on that. So this same compound is called meso compound. Exactly it will fit on that. Okay, clear? Here why am I bending it? Before I was not bending. Because those were two different compounds. One entire compound I am taking a mirror image. How dare I bend it? One entire compound I am taking a mirror image. How dare I can bend it? Here from a bond of that compound I am taking a mirror image. Okay, so I cannot bend the bond and break it. No, so I have to turn it over. Clear or not clear? So they are mirror image of each other. Superimposable mirror image of each other. So if it is superimposable mirror image of each other, they are meso compounds because they cannot be optically active. Clear? So another point just add on over here. Superimposable mirror image of each other. Superimposable mirror image. Clear? Actually, it is not superimposable mirror image. It is actually the symmetry. Again, this is actually the plane of symmetry. Actually, the plane of symmetry is cutting through it. Okay, we are calling it as a mirror, but actually the plane of symmetry is going from there. Okay, did you understand? This is optical activity. There are three types of things we are going to learn in optical isomers. All right, done. Done. This ends isomerism part. Next, we'll be beginning with the electron displacement in covalent bond, inductive, hyperconjugation, Mesomeric. These are the main parts of the chapter that we'll be taking up now. Okay, achha, let us write this then. This is mesotartaric acid. Mesotartaric acid. Okay, mesotartaric acid. This is D-tartaric acid. And this is L-tartaric acid. Clear? Understood how to do optical isomers? Okay, fine. Next we'll be starting with electron displacement in a covalent bond. Electron displacement in a covalent bond. So this is done. Our next topic is electron displacement in covalent bond. Electron displacement in a covalent bond. And this is completely new topic for you all. This is completely a new topic for you all, and this is going to be electron displacement in a covalent bond. Electron displacement in a covalent bond. As you have already learned maybe about polarity, there also the electron gets shifted, but here the electrons will be displaced. Right, in covalent bond, electrons used to get shifted towards one atom due to higher electronegativity. Here electrons will get displaced due to certain factors. In electron displacement in a covalent bond, इसके अंदर हम कुछ factors को पढ़ने वाले, ठीक है? पहले नाम लिख लेते हैं उसके बाद पढ़ेंगे, ठीक है? Number 1, we are going to study about is inductive effect. Inductive effect. Number 2, we are going to study about is mesomeric effect. अच्छा, before mesomeric, electromeric. Sorry, electromeric effect. Electromeric effect. थर्ड में हम लोग जो पढ़ेंगे वो है मेसोमेरिक इफेक्ट और रेजोनेंस इफेक्ट, ठीक है? मेसोमेरिक इफेक्ट या फिर इसको हम लोग बोलते हैं रेजोनेंस इफेक्ट. वी ऑल्सो कॉल इट एज रेजोनेंस इफेक्ट. नंबर 4, we are going to read hyperconjugation effect. Hyperconjugation effect. Okay. Also called as low-bond resonance, or another name we have that is called Baker-Dathan effect. Baker-Dathan effect. Baker-Dathan effect. So these are the 4 major topics that we are going to cover in the next few parts. Okay. So first, let us begin with inductive effect. Before beginning with inductive effect, two things I will tell you. What I will tell you? Two things I will tell you. And those are the very important things which will create the base. Okay. So I will waste a page over here. So never mind. If you find in organic chemistry plus charge on less electronegative atom, प्लस चार्ज अगर लेस इलेक्ट्रोनेगेटिव एटम पे हो जाए, क्या कह रहा हूं मैं, प्लस चार्ज अगर लेस इलेक्ट्रोनेगेटिव एटम पे हो, प्लस चार्ज अगर लेस इलेक्ट्रोनेगेटिव एटम पे हो तो वो स्टेबल होता है. क्या होता है? स्टेबल होता है. समझ में आ गया? अगर प्लस चार्ज लेस इलेक्ट्रोनेगेटिव एटम पे हो तो वो स्टेबल होता है. ठीक है. तो अगर नेगेटिव चार्ज मोर इलेक्ट्रोनेगेटिव एटम पे हो तो वो स्टेबल होता है. ठीक है. ये कंपैरिजन ऑर्डर में काम आएगा, इसीलिए लिखवा दे रहा हूं. ठीक है. प्लस चार्ज लेस इलेक्ट्रोनेगेटिव एटम पे स्टेबल, माइनस चार्ज ज्यादा इलेक्ट्रोनेगेटिव एटम पे स्टेबल. ठीक है. समझ में आ गया? समझ में आ गया? प्लस चार्ज लेस इलेक्ट्रोनेगेटिव एटम पे स्टेबल, माइनस चार्ज ज्यादा इलेक्ट्रोनेगेटिव एटम पे स्टेबल. ठीक है. अब आ जाते हैं इंडक्टिव इफेक्ट पे. इंडक्टिव इफेक्ट, अब देखो जरा इंडक्टिव इफेक्ट का मतलब क्या है, पहले वो समझना है. देखो होता क्या है कि व्हेन देयर इज अ कंपाउंड वी हैव सी 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 सी, द टर्मिनल इज ऑक्यूपाइड बाय CH3. वेरी सिंपल चीज, जो टर्मिनल पोजीशन पे है वो CH3 है. अब होता क्या है कि EN का डिफरेंस तो यहाँ पे है नहीं, EN का कोई डिफरेंस नहीं है, पर फिर भी क्या होता है कि ये जो CH3 है वो इलेक्ट्रॉन डोनेट करना स्टार्ट कर देता है. मतलब वो इलेक्ट्रॉन शिफ्ट करना स्टार्ट कर देता है. किस तरफ? इस तरफ इलेक्ट्रॉन शिफ्ट करना स्टार्ट कर देता है. ठीक है. ऐसे इसने इसकी तरफ शिफ्ट किया, अब ये कार्बन इसकी तरफ शिफ्ट करेगा, ये कार्बन इसकी तरफ शिफ्ट करेगा, ऐसा चलता जाता है. इसी शिफ्टिंग को, अच्छा किस बॉन्ड की तरफ से शिफ्टिंग हो रहा है, आई मीन थ्रू विच बॉन्ड द शिफ्टिंग इज हैपनिंग, सिग्मा बॉन्ड. सो सिग्मा बॉन्ड के तरफ, जो थ्रू द सिग्मा बॉन्ड अगर शिफ्टिंग ऑफ इलेक्ट्रॉन्स हो जाए, मतलब डिस्प्लेसमेंट ऑफ इलेक्ट्रॉन थ्रू सिग्मा बॉन्ड इज कॉल्ड इंडक्टिव इफेक्ट. क्लियर. So first point you will write displacement of electron along sigma bond. You have to take care that it is along sigma bond. Along pi bond electron cannot be displaced like this, and that is not inductive effect. Clear? So along sigma bond if it is displaced, then it is inductive effect. Now the question, why it will be displaced? Right, any case it will not be displaced. It will be displaced only displacement of electron along sigma bond when a electron withdrawing group or electron repelling group is attached at one end of the chain. ठीक है. कब होगा? जब हम एक इलेक्ट्रॉन डोनेटिंग ग्रुप या फिर इलेक्ट्रॉन विथड्रॉइंग ग्रुप को चेन के टर्मिनल में ऐड करेंगे, तभी ये होगा. ठीक है. ऐसा अगर हुआ तो ये रिजल्ट करेगा डेवलपमेंट ऑफ पार्शियल पॉजिटिव पार्शियल नेगेटिव चार्ज. ठीक है. डिस्प्लेसमेंट ऑफ इलेक्ट्रॉन अलॉन्ग सिग्मा बॉन्ड मेरा इलेक्ट्रॉन विथड्रॉइंग ग्रुप और इलेक्ट्रॉन रिपेलिंग ग्रुप इज अटैच्ड टू वन एंड ऑफ द चेन, रिजल्टिंग इन डेवलपमेंट ऑफ पार्शियल, क्योंकि ये पूरी तरीके से तो हुआ नहीं है, पार्शियली हुआ है, तो पार्शियल पॉजिटिव एंड नेगेटिव चार्ज. ठीक है. इन ऑर्डर ऑफ डिक्रीजिंग मैग्नीट्यूड, decreasing magnitude. In order of decreasing magnitude, or in decreasing order of magnitude, whatever. क्लियर? मतलब क्या है? मतलब समझो, मतलब है कि ये इस CH3 ने C को दिया. अच्छा, ये एग्जाम्पल से मैंने समझाता हूँ, ठीक है. You are having 5 pens. What you are having? You are having 5 पेन. 5 पेन है तुम्हारे पास. तुमने दिया किसी को 4 पेन. तुम्हारे पास क्या है? पेन की एक्सेस आई है या फिर डेफिसिट है? डेफिसिट है, तो मतलब तुम्हें पेन चाहिए होगा. तुम जोड़ सकते हो और पेन, तो तुम्हारे सिर पे आ जाएगा प्लस चार्ज. तो यही केमिस्ट्री में जब भी इलेक्ट्रॉन कोई डोनेट करता है ना, तो उसके सर पे प्लस चार्ज आता है. क्या आता है? प्लस चार्ज. तो इसने इलेक्ट्रॉन डोनेट किया है, तो इसके सर पे आ जाएगा प्लस चार्ज. क्योंकि इसने डोनेट किया इलेक्ट्रॉन, तो इट विल गेट अ प्लस चार्ज. विल इट गेट अ कंप्लीट प्लस चार्ज? नो, इट विल गेट अ डेल्टा पॉजिटिव चार्ज, पार्शियल पॉजिटिव चार्ज. अब जिसके पास इलेक्ट्रॉन आया है उसको क्या चार्ज मिलेगा? उसको नेगेटिव चार्ज मिलेगा. मिलेगा कि नहीं मिलेगा? तो इसको मिलेगा नेगेटिव चार्ज, इसको मिलेगा नेगेटिव, डबल नेगेटिव, इसको मिलेगा ट्रिपल नेगेटिव, ऐसा. ठीक है, समझ में आ गया? ठीक है. अब सबसे हिट करने वाली जो बात है इस केस में, वो इधर लिख रहा हूं, बहुत ही इंपॉर्टेंट है. इंडक्टिव इफेक्ट is applicable up to थर्ड कार्बन. किस कार्बन तक? तीसरे कार्बन तक ये एप्लीकेबल है, मतलब इतना तक. इसके बाद नेग्लिजिबल हो जाता है. तो मैंने दिखाया भी 3 कार्बन के लिए ही. समझ में आ रहा है बात? क्यों ये थर्ड कार्बन के बाद एप्लीकेबल नहीं है? क्योंकि ये डिस्टेंस डिपेंडेंट इफेक्ट होता है. क्या है? डिस्टेंस डिपेंडेंट इफेक्ट होता है. ठीक है, डिस्टेंस डिपेंडेंट. ठीक है, ये डिस्टेंस डिपेंडेंट इफेक्ट होता है. इसी कारण थर्ड कार्बन के बाद इसका कोई इफेक्ट नहीं है. ठीक है, समझ में आ गया? कोई प्रॉब्लम नहीं होना चाहिए, क्योंकि ये इजी पार्ट है. पहला पार्ट इजी है. अच्छा, ठीक है, समझ में आ गया सबको? ये एक परमानेंट इफेक्ट भी होता है, क्योंकि इसके लिए कोई स्पेशल कंडीशन हमें नहीं चाहिए. इलेक्ट्रोमेरिक जब पढ़ाऊंगा इसके बाद, तब समझ में आएगा कि कंडीशन चाहिए. यहाँ पे कोई कंडीशन नहीं चाहिए, तो ये परमानेंट इफेक्ट बन जाता है. ठीक है, चलो, ये समझ में आ गया? कोई दिक्कत नहीं है? ओके, चलो अब यहाँ पे आ जाओ, ज्ञान ले लो थोड़ा. यहाँ पे परमानेंट इफेक्ट, ऑल एल्किल ग्रुप्स. कोई भी एल्किल ग्रुप ले लो. अच्छा, हाइड्रोजन को मत कंसीडर कर लेना, उसको छोड़ के कोई एल्किल ग्रुप लो, तो वो हमेशा. अच्छा, अभी मैं टर्म नहीं लिखूंगा. ऑल एल्किल ग्रुप्स act as electron repelling group. समझ में आ गया? कोई भी एल्काइल ग्रुप ले लो, वो इलेक्ट्रॉन रिपेलिंग ग्रुप की तरह ही एक्ट करेगा. यू कैन नॉट फोर्स एन एल्किल टू एक्ट एज इलेक्ट्रॉन विथड्रॉइंग ग्रुप. सो ऑल एल्किल्स विल बी एक्टिंग एज इलेक्ट्रॉन रिपेलिंग ग्रुप. क्लियर और नॉट क्लियर? क्लियर? अंडरस्टूड? I think you have understood. Okay, fine. Next, we are coming to. अब जैसे कि मैंने डेफिनेशन पे कहा, आप इधर आओ, थोड़ा डेफिनेशन देखो. डिस्प्लेसमेंट ऑफ इलेक्ट्रॉन अलोंग सिग्मा बॉन्ड व्हेन अ इलेक्ट्रॉन विथड्रॉइंग ग्रुप और इलेक्ट्रॉन रिपेलिंग ग्रुप. सो 2 केसेस है हमारे पास. एक हो सकता है इलेक्ट्रॉन विथड्रॉइंग ग्रुप, एक हो सकता है इलेक्ट्रॉन रिपेलिंग ग्रुप. उसी के बेसिस पे हमने आई इफेक्ट को, अच्छा इसको शॉर्ट में हम लोग आई इफेक्ट लिखते हैं. ठीक है, आई इफेक्ट का मतलब क्या है? इंडक्टिव इफेक्ट. ठीक है, आई इफेक्ट. आई इफेक्ट को वी हैव टेकन इट एज प्लस आई इफेक्ट एंड वी हैव टेकन इट एज माइनस आई इफेक्ट. अब अच्छे से समझ रहा है कि ये प्लस क्या ये माइनस क्या। अच्छा अभी मैंने कहा कि प्लस कब आता है, जब इलेक्ट्रॉन डोनेट किया जाता है, इलेक्ट्रॉन हटा दिया जाता है एक एटम की तरफ से, इलेक्ट्रॉन जब डोनेट कर दिया जाता है तब प्लस आता है सिर पे। तो प्लस आई इफेक्ट उस केस में बताएंगे जो इलेक्ट्रॉन रिपेलिंग ग्रुप है, ठीक है। जो इलेक्ट्रॉन रिपेलिंग ग्रुप है वो प्लस आई इफेक्ट दिखाएगा, जो इलेक्ट्रॉन विद्रोही ग्रुप है वो माइनस आई इफेक्ट दिखाएगा, ठीक है। तो इसका मतलब क्या है, ऑल एल्काइल ग्रुप्स एक्ट एज इलेक्ट्रॉन रिपेलिंग ग्रुप। तो इसका मतलब क्या है, ये लोग क्या दिखाते हैं, प्लस आई इफेक्ट, ठीक है, प्लस आई इफेक्ट। एक और लिख लो यहाँ पे, ऑल हैलाइड्स और ऑल हैलोजेन एक्ट एज इलेक्ट्रॉन विथड्रॉइंग ग्रुप, ठीक है। इसका मतलब है माइनस आई इफेक्ट। क्लियर, ऑल हैलोजेन्स विल बी एक्टिंग एज इलेक्ट्रॉन विथड्रॉइंग ग्रुप्स, ओके, ठीक है। प्लस आई इफेक्ट, माइनस आई इफेक्ट। नाउ वी नीड टू स्टडी प्लस आई माइनस आई definition. I think you can write it down, that I am not giving you, I am just giving you the keywords, okay. Plus I effect due to presence of electron repelling group, due to presence of electron repelling group, due to presence of repelling group, इलेक्ट्रॉन रिपेलिंग ग्रुप के प्रेजेंस के लिए जो इफेक्ट लगता है वो प्लस आई लगता है। और इधर ड्यू टू प्रेजेंस ऑफ इलेक्ट्रॉन विथड्रॉइंग ग्रुप, ड्यू टू प्रेजेंस ऑफ इलेक्ट्रॉन विथड्रॉइंग ग्रुप, ओके, क्लियर। नेक्स्ट, प्लस आई इफेक्ट ऑर्डर, प्लस आई इफेक्ट ऑर्डर। अब ऑर्डर का मतलब क्या है, क्वेश्चन में आएगा कंपैरिजन करो कौन ज्यादा कौन कम, उस केस में हमें ऑर्डर पता होना बहुत ही जरूरी, ठीक है। अब फॉर आईएससी लेवल, ओनली द 1 डिग्री 2 डिग्री 3 डिग्री इफ यू डू दैट मच इज ओके। मतलब आईएससी के लिए ये लिख दे रहा हूँ, आईएससी के लिए 3 डिग्री मोर स्टेबल दैन 2 डिग्री, मोर स्टेबल दैन 1 डिग्री। मतलब 3 डिग्री क्या है, 2 डिग्री क्या है, 1 डिग्री क्या है। देखो 3 डिग्री कार्बन का मतलब क्या है, जो कार्बन 3 और कार्बन से जुड़ा है उसको 3 डिग्री कार्बन बोलते हैं, ठीक है। 2 डिग्री कार्बन का मतलब जो कार्बन और 2 कार्बन से जुड़ा है। 1 डिग्री कार्बन का मतलब एक कार्बन से जुड़ा है या फिर अकेला है, ठीक है। तो प्लस आई के इफेक्ट के ऑर्डर के अनुसार 3 डिग्री कार्बन ज्यादा स्टेबल होगा, 2 डिग्री कार्बन कम स्टेबल होगा, 1 डिग्री सबसे कम है। क्यों है समझना पड़ेगा, तो देखते चलो। 3 डिग्री का एग्जाम्पल लेते चलो, देखो ऐसा लिख रहा हूं, ठीक है, ठीक है, लिख सकता हूं ये। अब 2 डिग्री लिखो, ठीक है। अब 1 डिग्री लिख रहा हूं, ठीक है, ऐसा लिख सकता हूं, या फिर मैं ये लिख दूं पहले, चलो ठीक है, और एक लिख देते हैं ऐसे, ये दोनों 1 डिग्री है, ठीक है, एक ही बन गया, नहीं कुछ तो गड़बड़ हो गया, H2H5 लगा, ये रही हो, यहाँ पे, हाँ ठीक है। अब समझो, मैंने कहा था कि कोई भी आर ग्रुप है, आर का मतलब एल्काइल है, ठीक है, इतना तो अभी तक आ चुका, समझ में आ चुका होगा कि आर का मतलब क्या है, एल्कील है, इसका मतलब क्या है, एल्कील है। तो मैंने कहा था कि कुछ भी एल्काइल ग्रुप आ जाए वो हमेशा क्या इफेक्ट शो करता है, प्लस आई शो करता है। ठीक है, कोई भी आ जाए तो वो हमेशा प्लस आई शो करता है। तो अगर वो प्लस आई शो कर दिया तो इसका मतलब क्या है, ये ऐसे कन्वर्ट करेगा, ये ऐसे करेगा, ये भी ऐसे करेगा। ठीक है, तो ये दोनों सब मिलके इसके ऊपर रोटेट करें। मान लेते हैं इसके ऊपर एक प्लस चार्ज है, इसके ऊपर भी प्लस चार्ज है, इसके ऊपर भी प्लस है, इसके ऊपर भी प्लस। ठीक है, अब देखो ये जो कार्बन है, ये जो कार्बन है इसके पास इलेक्ट्रॉन नहीं है। ये चाहता है कि इलेक्ट्रॉन दो, ज्यादा से ज्यादा इलेक्ट्रॉन उसको दिया जाए, तो उसको तीन साइड से इलेक्ट्रॉन मिल रहा है। ठीक है, दूसरे वाले पे आओ, ये इलेक्ट्रॉन दे रहा है, ये दे रहा है। अरे हाइड्रोजन तो नहीं दे सकता, हाइड्रोजन तो इलेक्ट्रॉन नहीं दे सकता। ठीक है, यहां से एक साइड से मिल रहा है, यहां से तो किसी भी साइड से नहीं मिल रहा है। अब बताओ, सारे कार्बन के माथे पे प्लस चार्ज है, पहले वाले में तीन साइड से मिल रहा है उसको, दूसरे वाले में दो साइड से, तीसरे वाले में एक साइड से, चौथे वाले में मिल ही नहीं रहा है। तो बताओ, प्लस चार्ज को इलेक्ट्रॉन चाहिए होता है तो उसको जितना ज्यादा दोगे उतना उसका अच्छा होगा, होगा कि नहीं होगा? You need electron and you are being given electron from three different sides, so you will be more sufficed, you will be more satisfied. So बहुत सही। so पहला वाला जो है वो हमेशा ज्यादा होगा सबसे, दूसरे वाले से ये वाला ज्यादा और इससे ये वाला ज्यादा। समझ में आ गया कि नहीं आया? सिंपली कंसेप्ट है, कुछ डिफिकल्टी नहीं है इसमें। समझ में आ गया? कोई डिफिकल्ट नहीं है इसमें। ठीक है, अब आईएससी के लिए, आईएससी में तो ये आएगा नहीं, पर स्कूल एग्जाम्स की बात कर रहा हूँ मैं, आईएससी मतलब स्कूल एग्जाम ही ना, तो उसके लिए इतना तक ही इट्स ठीक है, हो जाएगा। ठीक है, पर जेई नीट पे तो नहीं होगा, जेई नीट में नहीं होगा। ठीक है, तो इधर आ जाओ, अगले पेज पे लिख दे रहा हूँ जेई नीट में क्या याद रखना है। जेई ऑर्डर ऑफ प्लस आई इफेक्ट, क्या याद रखना है? एक लंबा सा चार्ट है, उसको आपको पूरा याद करने का है। ठीक, और जेई नीड यू टू रिमेंबर C minus greater than N minus greater than O minus. This I have already told you, but you know all this. Greater than C double bond O, single bond O minus. Greater than 3 degree, 2 degree. Already told. Greater than phenyl, which is benzene. C2H by ethyl. Greater than CT3, greater than CD3, greater than CH3. What is CT3? You have read, no? The isotopes of hydrogen, right? Tritium, deuterium, and protium. So this is tritium, deuterium, protium. Because questions in JEE are usually asked, very good times it has been asked based on the CT3, CD3. Because this is a different type, right? So this is the order you to remember for plus I effect for JEE. Clear or not clear? Okay, this one I have shown you for carbocation, though I have not told you in intermediate, but I have just shown for example. Okay. Okay. This is clear to you that you need to remember this thing for your J. Done. Now let us come to the minus I effect. Now we will come to minus I effect. So plus I effect is clear. Plus I effect is clear that due to presence of electron repelling group, whatever is taking place is plus I. Now we will go for the electron withdrawing group, the minus I effect. Clear? Now let us come to minus I effect order. Minus I effect order. I will be explaining you with the help of carbanion only. Okay, with the help of carbanion I will be helping you. But carbanion will come a little bit later because I have not told you about reaction intermediate. Okay. So first thing is for ISC. NO2 greater than cyanide, greater than carboxylic acid, greater than fluorine, greater than chlorine, greater than bromine, greater than iodine. Halide. Greater than OH, greater than benzyl. This phenyl. Clear? This is the order you are going to remember for your ISC. Now coming to your JND. Obviously, you have to remember this part is JEE as well. But along with this, you need to remember few other things. Okay. H3O plus greater than NF3 plus greater than NR3 plus greater than NH3 plus greater than NO2 greater than cyanide greater than carboxylic acid greater than fluorine, chlorine, bromine, iodine greater than OR greater than OH greater than C triple bond C greater than NH2 greater than phenyl. Clear or not clear? So you have to remember both of this. So try to remember the lower one JNE, then you can remember the IC directly. It will come. Clear? This is the order that you have to remember for inductive effect. Clear or not clear? Clear? Understood? Okay? This is all about I effect that we are going to study. All about I effect that we are going to study. Now we'll be solving a little bit of questions. Little bit of question means one or two. I have one right now. If I can't recall anymore, then I'll tell you. Otherwise, one is enough for now. Because actually the questions are based on carbon ion that we have not done on. Okay. So let's do one quick question. Then we'll go for the next effect, electromeric effect. That's it. Question is, why is chloroacetic acid more chloroacetic acid stronger than acetic acid? Stronger than means stronger acid. Okay, stronger means stronger acid. And this usually comes for 1 marks. 1 marks. We'll write something. No, you have to write the point. Otherwise, you will not get marks. Right? So, why is chloroacetic acid stronger than acetic acid? I will tell you to pause the video and try out. Then I will be telling you the answer. I hope you have tried it out. Now look at the answer. See, first you have to draw the structure. Now tell me the structure of acetic acid. CH3COH. So it is like this. Chloroacetic acid is CH3COH, it will be CH2ClCOH, nothing more than that. Right? Don't expect Cl between that. Right. Now what will happen? Here you will find that CH3 donates the electron. Now, again the concept is of carbon and carbon. Little bit carbon concept comes in. Okay. Here I am giving you a trick for now, but actually that is not a very good trick. The color is only not visible. The trick is acidic character. Okay, acidic character proportional to minus I effect. Do you understand? More the minus I effect, more will be the acidic character. By that also you can write. But directly if you write that one, that will not actually work out. Okay, see here. Let me shift this little bit this side. I will be explaining you with the carb-cation carbon ion way. Maybe you will not understand exactly what is carb-cation carbon ion now. After some time when I talk about reaction intermediate, there I will tell you what is carb-cation carbon ion. Clear? Then you will understand. Then you can come back and watch it here. Okay? Okay. If I remove a hydrogen, what will I do? If I remove a hydrogen, I cannot remove hydrogen like H. I have to remove it by H plus. Right? So that means I am removing it like this. Like this. So what I will be getting resulting is CH3COO minus. Similarly, here I will be getting ClCH2COO minus. Now here you find donation of electron, donation of electron. Donation. Donation of electron over here, here attraction of electron. That means withdrawing of electron. Now you tell me. You are already filled. You have ate too much. बहुत खा लिया. और खाओगे? सिंपल एग्जाम्पल. बहुत खा लिया. पेट पूरा एकदम ठूस गया है. और भी खाओगे? नहीं खा सकते. तो इधर माइनस मतलब एक्सेस इलेक्ट्रॉन है, उसके बाद भी इलेक्ट्रॉन उसको दिया जा रहा है, तो वो लेगा? नहीं लेगा, वो अनस्टेबल बच जाएगा. पर यहाँ पे देखो माइनस ज्यादा इलेक्ट्रॉन, यहाँ पे इलेक्ट्रॉन खींच रहा है, तो ये इसके लिए अच्छा है. क्लियर और क्लियर. सो दिस इज व्हाई chloroacetic acid is a stronger acid than this, so it will easily release the H plus because this is stable. But do not write that this one and this two. Do not write that one is unstable. No, one is very much stable due to resonance. Okay, one is stable due to resonance. But you have to write that in structure 2, due to presence of chlorine, due to presence of halogen, the minus charge on O atom is dispersed due to minus I effect shown by the halide group. Clear? Do you understand? So the answer will be due to presence of Cl atom minus I effect is shown and negative charge on O is dispersed. Clear? That is why EgH plus facilitation. H plus easily released. More the H plus easily released, more acidic it is. Clear? Simple concept. Very, very simple concept. Okay, understood? Clear? Next we will be beginning with electromeric effect. Electromeric effect. Electromeric effect. Electromeric effect. What do you mean by electromeric effect? Electromeric effect is called as E effect. Just like inductive effect, I effect, electromeric effect, E effect. Okay. Just as I effect was divided into two parts, plus I effect, minus I effect. Similarly, electromeric effect is also divided into plus E effect, minus E effect. But before that, let me tell you what is electromeric effect. So electromeric effect is basically the complete transfer of pi electron. Focus on the word pi electron. Complete transfer of pi electron. Acha. Covalent bonding is going on, so the pi electron will be shared. Okay. Complete transfer of pi electron, that is shared pair. Okay. Or shared pair of pi electron. Pi electron will be present in a multiple bond only. So pi electron of a multiple bond to whom? To myself? No. To one of the shared atoms. Clear? To one of the shared atoms. To one of the shared atoms. In presence of attacking reagent. In presence of attacking reagent. This thing is called E effect. Is called E effect. That is electromeric effect. Okay. Now, which are the important points that is to be noted from here is pi electron in presence of attacking reagent. Clear? In presence of attacking reagent. There has to be one attacking reagent. There has to be one attacking reagent to facilitate this electromeric effect. Clear? Now, from the definition you have come across 2 points. What is the 2 point? This is a temporary effect. Last thing we have learned in case of inductive effect was permanent effects. I am showing you. Inductive effect was a permanent effect. Permanent effect written. But this effect is not a permanent effect. This effect is not a permanent effect. It is a temporary effect. Okay. Temporary effect. Why temporary effect? Because it is going to occur only in the presence of attacking reagent. You remove the attacking reagent, electromagnetic effect would not occur. Clear? So this is temporary effect, occurs in presence of attacking reagent. Right? What is attacking reagent actually? That you will get to know in details when you read hydrocarbon chapter or at the end of GOC. Towards the end of GOC, when we will discuss about the reaction, there I will tell you a little bit about this, and in hydrocarbon we will use everywhere. Okay, this is a temporary effect. Second, this effect is applicable in multiple bonds. Right? This is applicable in multiple bonds. And if we have seen inductive effect, that is applicable in sigma bond, multiple bond. Right? The definition of inductive effect was only displacement of electron to sigma bond. Clear? That was a saturated carbon chain. Clear? Still did not understand what is electromeric effect. Must know about an example. Obviously, I will give you an example. But before that, let me discuss about the 2 types of electromeric effect. E effect. First one is plus E effect. And second one is minus E effect. What is plus E effect? What is minus E effect? See here. In inductive effect, plus I effect was those who used to donate electron, and minus I effect was those who used to accept electron. But here donation and acceptation of electron is not happening, because both the cases donation is happening. And both the cases acceptation is also happening. Then we cannot justify in that way. That is why for E effect, plus E effect, we will say when the attacking group, when the attacking reagent gets attached, understand, gets attached to the atom which receives electron, which receives transferred electron. Did you understand? Or to that atom to which the electron is transferred. When the attacking reagent gets attached to that atom which receives transferred electron, or the electron is transferred to that atom. Okay, better is which receive the transferred electron, better I can write to that atom, to the atom to which electron is transferred, Clear? When the attacking reagent gets attached to that atom to which the electron is transferred, then we call it as a plus A effect. Clear? So you have understood that plus E effect, opposite will be minus E effect. So when attacking reagent gets attached to the atom to which electron is not transferred, then we will call it as a minus E effect. Clear? Clear? Now let's take the example. First, let us take about plus E effect. Understand? Okay. Achha. Suppose we have a alkene. Basic structure of alkene is this. Here, whatever is there that I am not showing, I am just showing it this way. Okay. Something is there. Something is something. You take whatever it is. This, if I attack it with a H plus, that's a electrophile. Now what is electrophile? No need to break your heads now. Just know the word. Expression I will give later. That is an electrophile. Okay. This electrophile will attack the deficit center. This electrophile will attack on that part where the electron is more. That means it will attack on the electron rich center of the alkene. Electron rich center, H plus. When does the atom carry a plus charge? When it is short of electron. So it will attack the part which is already short of electron. No, it will attack that part which is deficit of which is having an excess of electron, because it itself needs electron. So it will attack the electron rich center of this molecule. That is a substrate molecule. Okay. So this H plus will attack the electron rich center of substrate molecule. Okay. This thing is called the attacking reagent. This thing is called the attacking reagent. Attacking reagent. And this thing is called the substrate molecule. Okay. So what will happen? Electron will shift from here to here. Opposite also you can do, because both are having shift, so that's not pattern. Okay. So what will happen? This way, one will get a plus charge, one will get a minus charge. Right? We have a H plus. Now this H plus will attack plus side. Definitely it will not attack plus side, because it does not need more deficit of electron. It needs more electron. So it will this person. So the H plus with this H plus will attack this side. Right? So if it is going to attack this side, then what will be the formation? Formation will be C plus C. Clear or not clear? Minus plus neutral. Do not give any other minus over here. Understood? So this is called plus E effect. Understood? Plus E effect. Now let us go for minus E effect. Same thing I will take, but a little bit different. What is that? Achha. Let us take okay. Take it ketone. Now with this I am taking attacking reagent cyanide ion. Attacking reagent cyanide ion. Okay. This is the attacking reagent. Attacking reagent. This attacking reagent is called cyanide ion. Now you tell me that this cyanide ion has a minus charge. When does a person have minus charge? When it is already having excess of electron. So Cn minus has excess of electron. Will it attack to the electron rich center of the molecule? No. It will attack to that part which needs electron. That means this case, this thing will attack the electron deficit center of the molecule. Right? Minus charge আছে মাথার মধ্যে, that means electron বেশি আছে. So it will be attacking that part which actually needs electron. Right? So this will be attacking the electron deficit center of the molecule. And this person will be attacking the electron rich center of the molecule because it needs electron. But this person has electron, so it will be attacking the electron deficit center of the molecule. Clear? Understood? Achha. This person is called electrophile. I told the name, so I'm just writing it. Later on I will explain it. Okay? Electrophile. And this person is called a nucleophile. A nucleophile. Clear? So what will happen? Bond will break towards this side. In this case, you cannot break the bond in this way. It is not possible. Not at all possible. Clear? Bond will break towards that person only who will be having high electronegativity. So oxygen has high electronegativity, so bond will break towards that side. Clear? It cannot happen that bond you are breaking towards carbon. Not possible. Okay? But previously you see both were carbon. So you could have broken it this side also, this side also. But both you cannot do either of that, right? So here it will be clear. So what is going to be the next step? We have carbon. Carbon will get a plus charge. Single bonded with O, which will get a minus charge on its head. This will be now attacked by Cn minus. Now this Cn minus will attack this electron deficit center of the atom. The electron deficit center of the atom. So what will be the product? The product will become C. Now you can write in this way CCnO minus. Clear? So this will become the final product. And this is minus E. So did you understand that when it is a nucleophile, it will attack the electron deficit center of the molecule. When it is electrophile, it will attack the electron rich center of the molecule. Understood? Clear? Okay? Very good. So we are done with electromeric effect. Next thing that comes up is the most important part. Mesomeric effect or resonance effect. Mesomeric effect or resonance effect. Most important part. So let's begin with mesomeric effect or resonance effect. Long topic, this will take time. Resonance effect slash resonance effect slash mesomeric effect slash mesomeric effect. Okay, so you can write it as R effect or M effect. Usually we write it as M effect, but actually R effect or M effect is same. R effect slash M effect. Thing is same. Okay, now let's understand what is mesomeric effect. Let us understand resonance effect. Okay. See, suppose I tell you ozone. What I tell you? Ozone. Everyone knows ozone. Ozone has this structure. Okay, ozone has this structure. Here is a minus, here is a plus. Don't keep this. Here is a minus on this one, and here is a plus on this one. By seeing this structure, you can tell that double bond has a lesser length than single bond. So of course, this bond length should be more than this bond length. Right, very good. But experimentally it was seen that both the bond lengths are same. How? It is very much evident that double bond is lesser than a single bond. Then how come both are same length? That means there is something that is happening in the compound which is making both of them similar. Researches after researches led to ultimately this concept of resonance. Then ultimately what happens is double bond one time comes here as well. So we will represent it by a dotted line. Though a dotted line is not visible right now. Actually we will represent it by a dotted line because the double bond comes here as well. Okay, and this side as well. So it is like this. Clear? That is why both are same. That is why both are same. Understood? Why both are same? So this concept is called resonance. How did this happen? That you have to understand that how did this happen. Now let us talk about resonance. So one molecule, two or more structures if I am assigning. to describe all the properties of that compound, all the properties of that compound, all the properties of that compound. Then merging all these structures, one particular structure called resonance hybrid will be formed. This phenomena of representing one molecule by two or more compounds is called resonance. Understood? What am I saying? One molecule I am representing by more than one compound. Sorry, more than one structure. Two or more structures. Clear? And those two or more structures is capable to describe all the properties shown by that compound. Clear? Clear? If all those properties, all those structures are able to show the properties of the compound, then those structures forming the actual structure is the intermediate of that structure, all the structures intermediate structure, and it is known as resonance hybrid. And those structures are called canonical structures or resonating structures. This is called resonance. Yeah, did not understand anything? First write the definition, then you will understand. If a molecule can be assigned two or more structures, okay, all the structures will not explain all the properties. One structure may be explaining this property, other may explain this property. So if a molecule can be assigned two or more structures, none of which is capable to describe all the properties of the compound, okay, but as a whole all the canonical structures should describe the properties, but one canonical structure cannot describe all the properties. Clear? All the known properties of the compound, if the molecule can be assigned two or more structures, none of which is capable to describe all the known properties of the compound, then the actual structure is an intermediate of all these structures and is called resonance hybrid of this structure. That means if I mix all these structures, whatever I will get is a hybrid structure, that is called resonance hybrid. Clear? This is nothing but resonance. That means one compound I am presenting more than one structure. Simple meaning. Clear? These structures are actually called as canonical structures. Okay. These structures are called canonical forms / resonating structure. Clear? So please remember resonance hybrid. Please remember canonical form, resonating structure. Tell me, clear to you? Clear to you? Clear? Very good. Now you should also know the definition of resonance effect. Actually not needed because this will not be asked. But to have a concept, you need to know the definition. That's all. So just giving you the definition for resonance, copy it, maybe put it in your brain if you can, otherwise just ignore, no problem. Now if it comes in the exam, then don't tell me that I have not told you. It's already told, it's your duty to memorize it. The polarity developed within a molecule polarity develop within a molecule. This case is happening within a molecule. Okay, no intermolecular thing is happening due to interaction of one or two pi bonds with lone pair of electron present on adjacent atom, that means next atom. Clear? On next atom. In your syllabus what you have is pi bond only, pi bond LP. Other many things are also there. This is called resonance effect. Clear? This is resonance effect. Clear? Okay, now let us take up some examples. See, if I write CH2 CH CH CH2, okay. Acha, one thing I did not write, that was a very important thing. Resonating structures are separated by this thing, okay. This arrow you have to give. When you are showing resonating structures of a particular compound, you have to give this arrow. If you don't give the arrow, no marks. Now you see here, this is structure number 1. Okay, the original compound is a resonating structure. If you think the original compound they have given is not a resonating structure, then you are wrong, because the original compound is also going to be a resonating structure. Clear? Understood? The original structure is also going to be a resonating structure. Alright? Understood? Any doubt? No doubt? Very good. Now you see, this double bond will shift here. What will happen? This double bond will shift here. Okay. This double bond will shift here. Achha. If you cannot understand why they shift there directly, I can shift here. Right? So what is going to be the canonical structure? CH2. Okay. CH plus, right? CH minus, right? CH2 plus, right? Structure number 2. Possible? Possible? Very much possible. Now plus and minus পাশাপাশি বসে আছে and no bond between them, that is not possible. So we will not write this structure. What we will write is, we will directly write a bonded structure. Clear? No intermediate step we will show. When you are writing, directly the bonded structure you will write. So CH2 plus sorry, CH2 minus CH double bond CH single bond CH2. So when you are writing, you will write directly this step. But you know that there is an intermediate step, but you will write this. Another structure is possible. What is this? See here, I have shifted this side. I can also do ulto. Ulto means I can shift this side and I can shift this side. That also can be possible. Right, like this. So in that case, what will happen? Nothing. This will become plus and this will become minus. Between there will be no change. There are no other resonating structure is possible. Understood? What we are doing? Just shifting position of bond. Just shifting bond position. Okay? Just shifting bond position. Nothing else is happening. Clear? Understood? Okay, another example. Suppose you have CH3. Suppose you have CH3 C double bond O. Okay, this is acetate ion. Acetate ion, right? Right. What will happen? Resonance can be possible. How? This minus can form a bond over here. Moment the bond forms here, this bond will break over here. So resonating structure. One bond formation means one bond breaking. Remember this always, okay? One bond formation, other bond has to break. Clear? Resonating structure. Two resonating structure. In exam, they will ask you how many resonating structures are possible. Okay? And whose contribution is more to the resonance hybrid. Clear or not clear? Next we are going to discuss is the relative contribution of structures to resonance hybrid. Okay? Now the next topic is relative stability of resonating structures. Relative stability of resonating structures. Now actually what I have told to you is that there are many canonical structures which actually gives a resonance hybrid, and that is said to be the actual structure, right? Now which structure will give more contribution to the resonance hybrid, that how will we know? We have to check by this method. Clear? Relative stability of resonating structures or canonical forms of resonating structures. Okay, there are 5 rules. Okay, important 5 rules. Actually a 6th one is also done, and I will tell you when it is needed. Actually 5 rules you have to study. 6th rule is not very important, but maybe sometimes it is used. Clear? So relative stability of resonating structures means which canonical form contributes more to resonant hybrid, contributes more to hybrid. Clear? So you have to find that. That means you have to make a comparison between two canonical forms, and you have to get it that which one is going to contribute more to the resonating structures. Clear? So that we are going to understand now. Okay? Clear? No definition of relative stability structure, just a concept. Clear? Now straight we'll move on to the questions. With questions we'll understand. Okay? Okay, let us move on. We have a question over here, so this one we'll do later on, not now. Okay, see this question. You can see the question that there is a resonance going on, and this has been shown. Two resonating structures have been given in the question. Okay, oxygen lone pair I have shown it. Actually, it will not be shown. You should know that oxygen has a lone pair. Okay. Okay. Now you see 1 or 2. Which one is contributing more to the resonance hybrid? How will you check? There must be some order of the rule. It's not like I am telling you 6 rules and you are applying any one possible. Right? That you cannot do. You have to apply one rule that you have to apply at first one. You cannot apply that at any other point. So there must be a order of application of rules, and that order we are going to study. Clear? It's not like randomly any rule you will apply. That is not possible. Clear? So the first and the foremost rule is calculate the number of pi bonds. What is the first rule? Number of pi bonds. Clear? So let us make a note of that. We copy this slide. Rule number 1. Change the color better, right? Rule number 1. What is the rule number 1? Rule 01. I will be writing in short, okay? No brief description I will not write. Okay, see here. More pi bonds, more contribution. Clear? More pi bonds, more contribution. What did I write? So more the number of pi bonds, more will be the contribution to the relative resonance hybrid. Clear? More pi bonds, more contribution to the hybrid of the resonating structures. Resonance hybrid. Clear or not clear? Clear? So more the number of pi bonds, more contribution to the resonance hybrid. Now come to the question. See here. Pi bonds we have to count. Is there any pi bond over here? 0 pi bond. Here how many pi bond? 1 pi bond. Okay. Please do not say 2. Otherwise I'll beat you up if you say 2. So this is 1 pi bond over here, right? So who is having a more contribution? 2 is having a more contribution than 1. Decided by rule 1. Clear? Decided by rule 1. First and foremost rule is count the number of pi bonds. If that rule does not suffice, then we'll move on to the second rule. Clear or not clear? Tell me. Clear or not clear? So more the number of pi bonds, more will be the contribution to the resonance hybrid. This is the first rule. Okay, fine. Now let's move on to the next question. See the next question. Two resonating structures have been given. You have been told to write which one has more contribution to the resonance hybrid. Fine. So let's check. How many pi bonds over here? 2 pi bonds I hope. One over here, one over here. How many pi bonds over here? 2 are here only. So here also 2 pi bonds. Now what to do? Pi bonds here also 2, here also 2. Now what to do? That is a big question mark. So what we will do here is we will go for rule number 2. We will apply rule number 2. What does rule number 2 say? Let us know. Rule number 2. Rule number 2. Octet complete. Octet, hopefully you know what is octet. Octet complete. More contribution. Octet complete, more contribution. So if the octet is filled, if the octet of an atom is filled, that structure will, not one atom, all the atoms, octet is fulfilled, then that structure will be contributing more to the resonance hybrid. This is the second rule. Now let us apply here, then you will understand. Okay, now tell me, here is the octet fulfilled, here in this oxygen, octet is fulfilled. We write the 2 pi electrons over here, 2 pi. Now let me fill up the electrons, see here. See here, how many oxygen bonding it has been done? 2. So must be there are 2 lone pairs. 8 done. So it is already having a fulfilled octet. Carbon too you can see fulfilled done. This oxygen same condition, 2 lone pair. Done. So octet complete. No problem. Now come here. Acha. Oxygen and mathay plus. And people will think that oxygen is having short. That means deficit of electron. But actually no. Oxygen and mathay plus dekhei, no need to comment that 2 lone pairs, one lone pair is not there. That is not the case. Oxygen is having a plus, but it is having 2 electrons in it. So don't dare say that oxygen does not have the lone pair. Clear? So this oxygen also have fulfilled octets. 2 lone pairs are present on that oxygen. Clear? This is due to formal charge. Okay. Now come to this carbon. Done. Come to this oxygen there. Come to this oxygen there. This oxygen will create the problem. Because oxygen has got a minus charge on it. Oxygen, if you can see, it has got a minus charge on it. Clear? Acha. 1, 2. How many? 2 here. So there must be 1, 2, 3, 4. Now you see, there should have been 4. But since there is a minus charge, that means there is almost 2 more electrons in it. So this is also a fulfilled octet. Clear or not clear? This is also going to be a fulfilled octet. Clear? So everyone has 8 electrons. So that means everyone's octet is fulfilled. Octet fulfilled. Octet fulfilled. Now what to do? And second rule says that octet must not be fulfilled in one case. Then we can comment which one is more, which one is this. But ekhane to dutoই fulfilled hoye geche. Then what to do? Dono fulfilled ho chuke hain. Karenge kya? Iske liye लाना पड़ेगा third rule. We have to do third rule. So let's come to the rule number 3. So using rule number 1 and 2, we cannot determine whether 1 is more contributing or 2 is more contributing. So for that we need a third rule. What is the third rule? A very simple rule. A very simple rule. The third rule states that neutral greater than charged. What does that mean? That means neutral resonating structure will be contributing more than the charged resonating structure. What do I mean? Neutral resonating structure will be contributing more than the charged resonating structure. That means the resonating structure having some charge will be contributing less than the resonating structure having no charge. See this question. Here you see structure number 1 has got no charge, but structure number 2 has got a plus and a minus charge. So automatically by rule number 3 we will be saying that 1 is more contributing than 2. Rule number 3, that is neutral greater than charged. Clear or not clear? Tell. Clear? So rule number 1, the first and the foremost rule is counting the pi electrons, pi bonds. Pi bonds say rule 1 not applicable. Come to rule number 2. Octet of all the atoms is complete or not, that we will check. If you find incomplete octet in one case, then automatically the other case will be more stable, more contributing. If both cases octet complete, then second rule will not be applicable. Go to the third rule. Third rule states that neutral will be contributing more than charged resonating structure. Clear till here? Clear up to here? Okay, fine. Next question. See the question. How many pi bond? 1 pi bond, 1 pi bond. So both are having 1 pi bond, 1 pi bond. So rule number 1 eliminated. Rule number 1 not applicable. Okay. Next rule. What was the next rule? The next rule was octet checking. Now if you find, then all the octets are complete. If you check properly, then all the octets are complete. Okay. See here. Carbon to you can see already. Hydrogen to ignore. Oxygen 2 bonding here, 2 lone pair over here. This carbon has got a minus over there, so automatically 2 electrons are already inside that. So this is already having 8 electrons. Done. Okay, done. This side also you see carbon has got 8 electron. Oxygen has got a minus over it. So 1, 2, 3, 4, 5, 6, 7, 8. Done. So all octets are all complete. So octet. So rule number 02 invalid. Come to rule number 3. Rule number 3 says charge more than uncharged. Uncharged more than neutral, more than charged. So this is also charged as well as this is also charged. See here, minus here, minus here. So both the cases charged. So we cannot even apply rule number 3. So rule number 3 is also not applicable. Then what to do? Then we have to move on to the second last rule, that is rule number 4. What is rule number 4? Rule number 4 states that negative charge, understand this, negative charge on more electronegative atom. En means electronegative. Okay, more electronegative atom is more stable. Actually, negative charge on more En atom is more stable. So it contributes more. That means actually minus charge on more En atom will be more contribution. So that means in the resonating structure, when minus charge is on the more electronegative atom, that structure will contribute more. Clear? See the example, it will be more easily understood. See the example. Here if you see clearly, then minus is on carbon. Here minus is on oxygen. Who has a greater electronegativity? Oxygen or carbon? Obviously oxygen. So which structure will be more stable? Structure number 2. So structure number 2 is more stable than structure number 1. Rule number 4. Clear or not clear? Rule number 4 will be stating that minus charge on more electronegative atom is more stable, so contribution of that resonating structure will be more. So here carbon has a minus charge, there oxygen has a minus charge. Oxygen minus charge is more stable than carbon minus charge. Clear? So we can write that structure 2 is more stable than structure 1. Actually, it will be contributing more. Why? Due to rule number 4. Clear? Clear to everyone? Okay, fine. This question you cannot solve right now. This requires the rule number 6. Acha, clear with rule number 2. Any doubt? Any doubt till here? No doubt? Okay, fine. Let us move on to another question. Come to this question. 3 structures are given and you have to compare them. Okay. So let's check. First, you will be during প্রথম দিকে you do rule wise. Okay, rule 1, rule 2, rule 3, rule 4, rule 5, all the rules. Okay, as and when you get used to doing this, you can skip the rules, no problem. You can skip the rules as and when you get used to it. I'm saying as and when you get used to it. If you don't get used to it, then you cannot do, obviously. Clear? Okay, see here. This structure 2 and 3 both are charged. One is not charged. One is not charged. So based on that you can bring. But our first rule is not charged and uncharged, right? Our first rule is not charged and uncharged. So if by some chance, question is asked, how did you say that one is more stable than 2? Suppose the question is, write the order of the relative contribution, give reason. Then reason what will you give? You will say that one is uncharged and 2 is charged. Then you may not get the marks. I'm saying may not. Okay, underquote, may not get the marks. Why? Because that is not the first rule that you have to apply. No, that is the third rule you are applying, not the first rule. What is the first rule? That you have to apply first. What is the first rule? Count the number of pi bonds. First structure has 2 pi bonds, rest structure has 1 pi bond. So the first structure is more contributing than the other 2 because of number of pi bonds. Clear? Uncharged is correct, but that is not the first rule. Clear? That is not the first rule. So 1 is more stable than something which we do not know yet. This is happening due to rule number 1. Okay, not rule number 3. Clear? Now what do we put on that dash dash? Structure 1 sorted. Now we have structure 2 and structure 3. Doubt. What is the doubt? Both are having 1 pi bond. You can see that. Second rule if I apply, all are having octet complete. That you can see. All are having octet complete. So second rule failed. Third rule if I apply, both are charged, failed. Fourth rule if I am coming to, then minus charge or higher electronegative atom, more stable, more contribution. Here to both are carbon. Then where is higher electronegative coming from? Both are carbon. See here, the charges are on carbon only. So there is no question of higher electronegativity minus charge, right? Then what to do? Rule 4 is also not applicable over here. Then we have to take the help of rule number 5. Then you have to take the help of rule number 5. Acha. If you use your common sense also, then also you can understand that if I keep a plus charge, best example I am giving you with a magnet. Okay, a magnet has 2 poles, a plus and minus, north and south pole actually. So I have taken one plus side of a magnet and the minus side is this side. Another magnet I have taken, let us say, with a plus side here, minus side here. What will happen? You try to take them closer, bar magnets. You try to take them closer. What will happen? Will they get very much attracted to each other? No. They will get repelled. But if the same thing I repeat by taking a minus instead of that plus, then what will happen? Then they will get attracted. That means what? If I do this same thing with a minus plus and this way, what will happen? This thing will get attracted. So this will be getting attracted. But this thing will get repelled. Right? So same thing you have to apply over here. If 2 opposite charges are present together, that together means so one atom cannot have plus and minus. No, together means side by side. Clear? If 2 like charges are present side by side, repelling will happen. So that is not going to be very much stable. So if unlike charges are present adjacent, then it is more stable. Clear? That means two different charges if present side by side adjacent to each other, very stable. So that will be contributing more. If two unlike charges are present together, more contribution. Like charges present adjacent is very unstable, it will not contribute more. That you have to apply here. Now you see rule number 5, how will you apply? What did I say? Like charges present adjacent, definitely not stable. So contribution gone. Unlike charges present adjacent, contribution more. Now you see here, this thing is present more closer and this thing is present distant. Distance is a factor. Here the distance is more, here the distance is less. So who will be more stable? Of course, this person is more stable. The number 2 is more stable. Plus and minus will try to make a bond in between, right? So that is going to be more stable. So what will be the correct order? 1, then 2, then 3. Understood why 2 and why not 3? Because 3 plus and minus is separated. There is a separation of charge. Here plus and minus, they are located adjacent to each other. So if there is an adjacent to each other, then definitely they are going to contribute more than the structure number 3. Clear? So it is going to be 1, 2 and 3. By this one is by rule number 5, which you have just now learned. Clear or not clear? Now let us write down the rule number 5. So rule number 5. Rule number 5. Unlike charge, if present adjacent, contribution. Clear? So unlike charge, present adjacent, contribution increased. Clear or not clear? Now there is a 6th rule as well, which I am writing here. It's an I effect. I effect. Clearly I effect. Straightforward I effect. You know what's an I effect? Electron withdrawing group, electron repelling group. That you already know. That is a 6th rule. So what we have learned here? Rule number 1. First and foremost rule. Calculate the number of pi bond. Second rule. Octet complete. More contribution. Third rule. Neutral. More contribution than charge. Fourth rule. Minus charge. More stable or higher electronegative atom, more stability, more contribution. Clear? Number 5, rule number 5, unlike charge, present adjacent, more contribution. Like charge in adjacent, obviously less contribution. And rule number 6, inductive effect. These are the rules which you need to do in the same order. Clear? Okay. Now coming to this question. Two resonating structures have been shown to you. Order of the resonating structure. It is A greater than B or B greater than A. What to do? You see here, rule number 1 is not applicable because both are having same number of pi bond. Rule number 2, that is also not applicable. Octet complete. Rule number 3. Rule number 3 not applicable. Charge is both cases. Rule number 4, higher electronegative atom. That is also not possible. Both are on the same. Rule number 5. Unlike charge, like charge, there is only one charge. So unlike charge, like charge concept is not coming only. Then what to do? Then we have to take the help of the last person, that is rule number 6. This rule cannot be violated. Clear? That means even in rule number 6 it is not coming, it is not usually it is not seen. Maybe higher class it is seen, but as of now it is not seen. Now, what to do? Tell me, minus charge needs electron or it can donate electron. What to do? Minus charge needs electron or it can donate electron. Which one? Example let me give you. Very interesting example. Okay. You are having, let us take, you are carrying a stack like this. You are carrying 10 kg. Hypothetical, okay? Hypothetical. Thinking as hypothetical. 10 kg लेके जा रहे. 10 kg you are taking. Okay. Okay, chalo. 2 more persons are there. Empty. 2 more persons are going, just going. They are not taking anything. Okay. What will you do? Achha, 2% are there, another person, let us take another person carrying 2 kg. Okay, what will you do? Will you take that 2 kg from that person, or will you give 10 kg, some amount of 10 kg to that person? Which one will you do? You have two a person are going empty, khali hate jacche, and one person is carrying 2 kg. What will you do? Will you take that 2 kg, or will you give the some part of 10 kg? Obviously, you are going to give some part of 10 kg, right? So similarly, here is the case. If the carbon is having a minus charge, it does not need an electron. It does not need electron. It is already having more electron. It needs to donate the electron to disperse the minus charge. So automatically plus IFX group will decrease the stability. So their contribution will automatically decrease. Did you understand from where to where I am going? You are having 10 kg of things. Another person is having 2 kg of things. You are not going to take 2 kg of things to increase your load to 12 kg. No. You are going to give some amount of 10 kg to reduce your load. So similarly, if there is a minus charge, it will not take any more electrons. It will be donating those electrons. So if any plus I effect group is present in that case, that is going to be highly unstable. Clear? But minus I effect will be facilitating it. So that means minus I effect will be making it more stable. So we have to see here minus I effect case. Clear? Now you see. Acha, we know that sp2 carbon is electronegative. sp2 has higher electronegativity. No? Percentage S character increases, electronegativity increases. This is already known to you. Chemical bonding only you have done. Character S character increase means electronegativity increase. So sp2 will automatically have more electronegativity than sp3. No doubt about that. So this carbon, you check it out. This carbon is sp2 hybridized. Now don't ask me how to find out hybridization. That you have already done in chemical bonding, and there also you have done organic also first part you have done. Though I have not done because chemical bonding it is done already. Clear? That carbon is sp2 hybridized. sp2 hybridized means more electronegative. So what it will do is it will pull electron from here. So is it good for the minus? Is it good for the minus? Very good for the minus because it is pulling the electron from it, dispersing the negative charge. So minus I effect very good for the minus. Right over here. Minus I effect very good for the minus. Clear? So B structure as of now you can see is okay, fine. Achha. Why will it not pull electron from here? Definitely it cannot pull. That is far away from that. We cannot do also that. Okay, only that carbon can do it because distance factor is there. Okay. Now coming to question A. Minus charge is over here. So we are going to consider this carbon as well as this carbon. Clear? Here only one possibility was there. Here we can take two possibilities. Now you see here this carbon. What is the hybridization? sp2. sp2 hybridized. sp2. Okay, let me give you a little bit reminder about what is hybridization. You might have all forgotten what is hybridization. Definition I will not give here, so don't need to worry. Hybridization is somewhat intermixing of orbitals. Whatever orbitals you are mixing, that number of orbitals only you will get. You have learned that there are different types of hybridization: sp, sp2, sp3, sp3d, sp3d2, sp3d3. So d3, d3 is not applicable in organic because you know carbon cannot have d orbital. Fine. So we in organic will deal with sp, sp2, sp3. This is a brief idea of only hybridization. Percentage S character proportional to En. This also you all should know. Sp greater than sp2 greater than sp3. En order. Okay. Achha. Next thing is hybridization. How to find hybridization? Hybridization. Achha. Please remember that this formula I am giving is only for organic. Okay. Do not end up applying it in other places. Clear? Achha. So it is going to be sigma bond. What is it going to be? Number of sigma bond. What is it going to be? Number of sigma bond. Number of sigma bonds. Please remember that the sigma bonds I am saying also includes hydrogen. Okay, a hydrogen you have ignored, that is not going to be correct. Suppose example I am giving you. Let us take it is not like this. Let us take it is like this. Wait. Let's take the compound is like this. Right? What is the hybridization of this carbon? The double bond is present. This carbon hybridization. 2. Hybridization sp. Is the hybridization sp? No, definitely not sp. Right? Definitely not sp. Because sp is for triple bond, sp2 is for double bond, sp is for one. But sp can also be for other case. Two double bond. Two double bond also sp. That reason I am telling you just now. Wait, hold on. That also I am telling you why. Acha. SP, this is SP, definitely not SP. Why not SP? Just now I told you sigma bond, then you are seeing one sigma bond, you are seeing two sigma bond. But who will see the other two hydrogen? Hydrogen is also there. Who will see that? I will see. There is hydrogen as well. Who will see? I will see the hydrogen. No. You will only have to see the hydrogen. So it is definitely not SP, it is sp2 because there is a hydrogen also. That hydrogen if you don't consider, then you will go wrong. Clear? Hydrogen will not be shown in bond-like structures. So here is a hydrogen. Then to carbon 4 and done. Otherwise the carbon 4 and is not done. Now you see how many remember? 1, 2, 3. So it is sp2. Clear? So this carbon is sp2 means this carbon is also sp2. Understood? Clear? Way to find hybridization is number of sigma bond. Please do not apply this rule in inorganic. Inorganic sigma plus lone pair will come. Clear? Here carbon cannot have lone pair. That is why I am not saying it. Clear? But in inorganic sigma plus lone pair of electron. Okay? Clear? Now. See here. Suppose I have CH2 double bond. CH2 double bond. CH2. Acha, this carbon will have more, no? This is not possible only. There. Acha, suppose we are having C double bond, C double bond C, double bond C. Okay, clear? Here hydrogen 2, here hydrogen 1, here no hydrogen, here 2 hydrogen. Acha, clear? What will be the hybridization of this C? What will be the hybridization of this C? SP. SP. This carbon is sp hybridized. Please note it carefully. Sp is not going to be always triple bond. Sp can be two double bond as well. That's the case. See in this case. That is why I said the formula is there sigma bond. How many sigma bond is there? Two sigma bond. That is sp only. sp2 is not the case. Clear? So two double bond is going to be sp and not sp2. These things you need to take care of. Acha, where did I get deviated from? Okay, hybridization clear. Just to give you a basic idea. Now come here. sp2 hybridized. This carbon is sp3 hybridized. Two hydrogen are there. So sp3 hybridized. Now, sp3 hybridized is going to be the least S character. Achha, S character also have to say. sp is going to have 50% S character. sp2 is going to have 33.33% S character. And sp3 has only 25% S character. So who has least? sp3. So sp3 is not electronegative. sp3 is electropositive. Clear? So if sp3 is electropositive, then it will donate electron. But minus does not like electron. Is it as if you are giving more weight to this? 2 kg weight also you are giving to this person. That is not liked by the minus. So this will be little bit unstable. little bit. Why little bit? Because sp2 is also here to take away the load. Right, those I have given. sp2 is also here to take away the load. So it will be kind of tug of war. What is giving, what is taking. That means this person is giving and this he is also giving to this person. So as a result, the net load will be lesser. But one person is giving, one person is taking, and in another case only giving. Which one is easier? Only giving is easier. Right or wrong? Only giving is easier than taking and then giving. So automatically, whose contribution will be more? B's contribution will be more than A. Rule number 6. Did you understand? Why it is rule number 6? Because other rules are not coming. Now rule number 6 also why it is B greater than A? That you have to understand from the diagram. Clear or not clear? sp3 is giving. It is minus I attacking. Plus I also happening. Minus I plus I. Both are taking place. And here only minus I. Which is going to favor minus? Only minus I is going to favor minus. Clear? So to some extent minus I's power is diminished by plus I effect. So this B gets more power than A. Clear or not clear? This is all about relative stability of resonating structures which you have to study from this part. Now tell me, any doubts from this part? Any doubts from this part? Tell me. No doubts? Okay, fine. Done. That will be resonance. Next topic we are going to start with hyperconjugation effect. That is also called Buchanan effect. Hyperconjugation effect or Buchanan effect. So let's begin with hyperconjugation. Before starting with hyperconjugation, we need to know about what is exactly alpha hydrogen and how we will count alpha hydrogen. Okay, now you see, to a double bond system, the carbon attached and the hydrogen with that carbon is alpha hydrogen. Sorry. Now, what do I mean? See here. Suppose I have CH2 double bonded with CH2. Here, other than this two carbon, any other carbon is not there, and both these two carbon are involved in a double bond, so there is no alpha hydrogen. Clear? So in this case, no alpha hydrogen. Clear? Because both the carbons that are present are involved in the double bond. Okay. Now, if the structure is CH double bond CH2 single bond CH3, then how many alpha hydrogen? Then 3 alpha hydrogen. How? This carbon and this carbon, they are involved in this double bond, but this carbon is not involved in the double bond, so this carbon is called the alpha carbon. Clear? And alpha carbon, whatever hydrogen is attached with the alpha carbon is said to be alpha hydrogen. Clear or not clear? So how many hydrogen? 3. So what is the number of alpha hydrogen? 3. Clear? Another one. If I take this way, then how many alpha hydrogen? 6 alpha hydrogen must be. These two carbon are attached with the double bond, but these two carbon are not, so this will be alpha carbon. Clear? Now, if I write CH, CH2, CH3, CH2, CH3, then what? Then this is not the alpha carbon. Very important. The carbon will be considered as alpha carbon if it is just next to that carbon which is involved in the double bond. Involved in the double bond, just the next carbon, that is this one is an alpha carbon. This is not the alpha carbon. So there are only 2 alpha hydrogen, not 5 alpha hydrogen. Clear? Understood? Only the next carbon will be involved. This carbon will not be termed as alpha carbon. Done? Clear? Now coming to the next thing, it is called Buchanan effect, hyperconjugation effect. Hyperconjugation effect, also called as Buchanan effect. Okay. When a CH bond is attached to a unsaturation or to a unsaturated system or a benzene ring, okay, when a CH bond is attached to a unsaturated system or benzene ring, comma, the sigma electron of CH bond interact or enter into partial conjugation with the unsaturated system. This is called hyperconjugation effect. This is also called no bond resonance. Please remember, sigma electrons are used. Okay. the sigma electrons are there. In normal resonance, electron. No bond breaking takes place. Here bond breaking will take place. Second, also called Buchanan effect and no bond resonance. Clear? When you have to tell which one is more stable, which one is less stable, and you do not get any other option, then you have to do for hyperconjugation effect. Okay, this is called AH effect. Okay, next, number of hyperconjugating structure. Actually this is a resonance, right? So there must be resonating structure, but we will not say resonating structure, we will say hyperconjugating structures. So what is the number of hyperconjugating structures we will get for a compound? That will be equal to number of alpha hydrogen. Clear? Whatever will be the number of alpha hydrogen present in that compound, that many number of hyperconjugating structures we will get. Now whosoever hyperconjugating structure number is more, their stability will be more. That means actually we have to count for number of alpha hydrogen, whosoever is more stable. Clear? Understood? One question we will do. Arrange in decreasing order of stability. Yes. Now tell, arrange in the decreasing order of stability. Pause the video and try it. Okay, so I think you have tried already. Now let me do it. Here, alpha carbon is this one. So how many alpha hydrogen? 3 alpha hydrogen. Here, alpha carbon, 6 alpha hydrogen. Alpha carbon, 12 hydrogen. Alpha carbon, 9 alpha hydrogen. So maximum stable 3, followed by 4, followed by 2, followed by 1. Clear? Very easy type of question. Nothing at all difficult. Clear? Oh, next we will come to homolytic bond fission. Okay, first let me talk about bond fission. What is bond fission? What do you mean by bond fission? একটা bond যদি ভাঙে, if one bond breaks, then that is called bond fission. Now this bond fission can be of two types. One can divide equally or it can divide unequally, right? So bond fission, two types. Okay, first let me write that breaking of bond is called bond fission. Breaking of bond equal to bond fission. Another term which is very common here is bond cleavage. Okay, cleavage means again the same. Now this is of two types. What are the two types? Equal division, and it is called homolytic cleavage. Equal division, then it is homolytic cleavage. Unequal division, then it is heterolytic cleavage. Heterolytic cleavage. Clear or not clear? Now you see. Homolytic, heterolytic is very easy to understand. Homolytic. Heterolytic. If I am having A, okay, A, one breaks. Actually, this line that I have given, that represents 2 electrons, right? So 1 electron will go to the left atom, 1 electron will go to the right atom. If this thing is happening, then we will call it as a homolytic cleavage. And you can see I have not given a complete arrow. The arrow is not like this. The arrow is half arrow, showing that it is homolytic cleavage. Don't give a complete arrow in homolytic cleavage. Okay. So this will result in the formation of like this, something like this, having 1 electron. This something is called free radical. Clear? So homolytic cleavage results in the formation of what? Results in the formation of free radicals, right? Now come to heterolytic cleavage. Suppose you are having A, B. Okay. Then either B will get the complete electron or A will get the complete electron, depending on whosoever's electronegativity is more. I am taking B electronegativity more than A. Clear? So A will have a deficiency of electron and B will have excess of electron. Then this is called inorganic chemistry carbocation, and this one is called anion. So heterolytic bond fission results in the formation of carbocation and carbanion, while homolytic bond fission results in the formation of free radicals. Clear? So definition of homolytic cleavage I am not making you write, because you all can write it. What is homolytic cleavage? A type of cleavage between 2 atoms in such a way that each bonded atom will retain 1 shared pair of electrons. Then clear? Next. Order of stability. Order of stability of alkyl free radical. Alkyl free radical. What do I mean? See here. Suppose I write CH3C, CH3, CH3, and this is a free radical. Another one I write CH3, C, H, CH3, free radical. Another one I write CH3, C, free radical, H, H. Another one I write H, 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 free radical. Who is more stable? Obviously this person. Actually numbering, let us number it first. 1, 2, 3, 4. So who is more stable? Obviously 1 is more stable. Why? Because this carbon requires electron, and there are 3 ways that he is getting electron, because these are all plus I effect group already discussed. So they all are giving electron to this person, and this person requires electron, so this will be more stable. Then this will be this hydrogen cannot give electron, but these 2 are giving. Here only 1 person is giving, here no one is giving. So 1 greater than 2, greater than 3, greater than 4. That means 3 degree greater than 2 degree greater than 1 degree. Clear? So 3 degree is more stable than 2 degree than 1 degree. Next, benzyl free radical. Benzyl free radical. Acha, one more thing I forgot to tell you. That is this free radicals are sp2 hybridized. Okay, free radicals are all sp2. Just remember it, not of much use. Okay, benzyl free radical. That means a benzene is there, a CH2 is there with a dot. This is highly stable. Why? Again, due to resonance. Due to resonance, it is very much stable. How? One electron comes here and another electron comes from here. So as a result, simple resonance. Right? Now again one will come here, this will come here. Then again this will come here. This will come here. Right? So benzyl free radical highly stable due to resonance. Highly stable due to resonance. Clear? So benzyl free radical highly stable due to resonance. Due to resonance. Clear or not clear? Now we are going to read about heterolytic cleavage. Heterolytic cleavage, and we have to read in details about carbocation and carbanion because we will need that forever in chemistry. Okay. Okay. Now we are going to know about heterolytic bond fission. So as I have already told you before, heterolytic bond fission means where there is no equal distribution of electron. You have seen in homolytic cleavage there was equal distribution of electron. That means দুটো অ্যাটমের কাছে একটা একটা করে ইলেকট্রন গেছে. Here one atom will take both the electrons. Clear? So one atom will have deficit of electron, one atom will have excess of electron. So there will be plus and minus charge created. Right? This I have already told you before. Homolytic cleavage. Sorry, heterolytic cleavage. Heterolytic cleavage. If there is a bond AB and we take B's electronegativity to be more than A's electronegativity, then the electron will shift towards B, forming A plus and B minus. This A plus in organic chemistry is called as carbocation. Carbocation. Clear? If that A is a carbon content, A is a carbon. Clear? And B is called as carbanion. Clear? So we are going to discuss in details about carbocation and carbanion now. Okay. First, let us talk about carbocation. First, we will talk about carbocation. Carbocation. Carbocation is a group of atom. It can be a group of atom. It can be one atom, that is carbon atom as well. So I will say it is a group of atom containing positively charged carbon atom. It can be a group of atom, it can be a single atom, but usually it is a group of atom. Group of atom containing, so please listen, group of atoms containing a positively charged carbon atom, a positively charged carbon atom. Group of atoms containing a positively charged carbon atom. Understood? C plus has only 6 electrons. This is called sextet of electrons. Clear? Where 6 electrons? Obviously in the valence shell. So C plus has only 6 electrons in the valence shell, because 2 electrons are taken away by the carbon ion. Clear? So the carbocation has how many electrons in its valence shell? 6 electrons in its valence shell. This can be a question. Okay, all these are MCQ questions. Okay, look here. If I write CH3Br, electron shifted, so resulting formation is right. Clear? This is called methyl carbocation. Methyl carbocation. Okay, remember carbocations are sp2 hybridized. Carbocations are sp2 hybridized. Okay, clear with this? Any doubt? Similarly, if it is like this, shifted, the carbocation will be like this. In this case, it is 1 degree carbocation, here it is a 2 degree carbocation. Understood carbocation? Now come to relative stability of carbocation. Relative stability of carbocation. If we have to compare between two carbocation, who is more stable, then for that we need some rules, and that rule is a very simple rule. See here, I am explaining first with a example. Okay, this example I think I have given before also. $2,000 kg load you are carrying. Very good. You get 3 people who are ready to take your load, take your part of your load. Very happy, very happy. So will you easily accept them? Yes, very happy. Very happy. Give some load to this, some load to this, some load to this. Very happy. Yes, very happy. Very good. Now, if instead of this person, another person is there, will you like this? They are also carrying a load and they are giving you the load. They are trying to give you the load. Already you are carrying 2000 kg load. Okay, and they are trying to give you 2000 kg load. You will not accept. You will not accept this. Right? This is the case in case of carbon ion. Now come to the case of carbocation. In case of carbocation, what is the case? You are empty-handed. You are empty-handed. Okay. Three persons are there. They are having too much weight. You want weight. You want what? You want weight. They can give you. He can also give you. He can also give you. So you are very happy to take the weight because they can give you weight. Right? Now, if there is one person who is like you, an empty one, then what? Can he give you any load? No, he cannot give you any load. But you are getting load from two sources. The third source is not giving you any load. Right? Similarly, if I close this load also, it means this person is also empty. Then this person also cannot give. So you are getting load from one person. Right? So same, this is the case with carbocation. Exactly the same case with carbocation. If it is a 3 degree carbocation, then it is getting its electron from 3 different sides. CH3 is a plus IUPAC group. So CH3 will give electron from 3 different sides. So very happy. This C is very happy. It needs electron. It is getting electron from 3 sides. Very happy. So the largest is 3 degree tertiary. Clear? Now second, if I close one way, H, C, positive, CH3, CH3. Still from two ways it is getting, still it is happy, but not happier than this person, right? Closing another way, H, C, H, positive, CH3. One way it is getting from happy, but not happier than this person, right? Last person, not at all happy, nothing it is getting, always close. Clear? So most stable 3 degree, then 2 degree, then 1 degree. This is also 1 degree. Clear? So 3 degree carbocation most stable. Clear? Now come to benzyl carbocation. Stability of benzyl carbocation. Same thing as we did for benzyl free radical. Due to resonance, benzyl carbocation is highly stable. Due to resonance, benzyl carbocation is highly stable. Do I need to show the resonance? Okay, let me show it once. Already I have shown it for free radical, same thing. So due to resonance, benzyl carbocation is highly stable due to resonance. Even benzyl free radical, benzyl carbanion and benzyl carbocation all are stable due to resonance. Clear? Clear? Right. Now if you can memorize this chart. Memorize this chart if you can. This is about carbocation stability order. If you can, then memorize. If you can't, leave it. No problem. Clear? If it is possible, then memorize. Otherwise, leave it. Understood? This is all about carb cation. Next, we are going to start with this carb anion. Alright. Next topic is carb anion. Carbocation done. Now we'll be discussing about carb anion. So we have discussed about carbocation, that is positive charge. Now what we are going to discuss is negatively charged, that is carb anion. Carbon having negative charge. Carbocation was sp2 hybridized, if you remember. Carbon anion is sp3 hybridized. So the shape is tetrahedral, and for carbocation it is trigonal planar. Okay. Now, what is exactly a carb anion? It is a species. It is a species which contains a carbon atom carrying a negative charge. Clear? So if a carbon carries a negative charge, so how many electrons it will have? 8 electrons. Clear? C minus means it is having 8 electrons. So C itself has 6 electrons, and minus means 2 more you have given it to it. So it is having 8 electrons. Clear to it? Clear? Now, just like we have discussed for carbocation, the stability, for carbon anion also we will discuss the stability, relative stability of carbon anion. Now you see, whatever you have seen for carbocation, ulta. Why ulta? Let us see. Relative stability of carb anion. Now, in the case of carbocation, I have told you that the carbon itself is deficient, so it needs electron, right? So more the way it can get electron, more stable it is. So 3 degree was most stable, followed by 2 degree, followed by 1 degree. Now in case of carbon ion, the carbon already has more electron, so it will not take in a more electron. That means, understand, person having already 4 kg load, another person who is having 2 kg load is giving 1 kg to this person. Will the person who is having 4 kg accept that 1 kg? No, because he is already having a 4 kg weight. Why will he take 1 kg weight? Right? So this is the case having with carbon ion. But if it was a carbocation, that means the person is empty handed, and this person who is carrying a 2 kg mass is giving 1 kg. So he is very happy because he needs mass. This is the case for carbocation, and this is the case for carb anion. Did you understand the difference? Carbocation, carbon ion. So if you are already having electron, you will not take any more electron, right? If you are having electron, then you will not take any more electron. So the case in carbocation was 3 degree, 2 degree, 1 degree. Now it will be ulta. That means 1 degree greater than 2 degree greater than 3 degree. Clear? Why it is so? Let us explain an example. See here. Same example I will take, whatever we have taken for carbocation. Carbocation, when we have explained, we have taken one example. The same example we are going to take over here. See, CH3, 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 negative, CH3, CH, CH3, negative, CH3, C, H, H, negative. Okay, let us take this 3. Another one you can also take, that is CH3 negative. Now you see, if in case of minus it was plus, then definitely first one is very much good. But here minus is there, and this minus is being donating electron from 3 side. Minus does not need electron, but it is getting electron from 3 side. So will it be highly stable? No. Already it is having more electron, you are giving it still more electron, so it will be obviously unstable. So this is not going to be stable enough. So this is unstable. Clear? Now here it is getting from 2 sides electron, still unstable, but less unstable than this. Clear? That means more stable than this first one, more stable than the 3 degree one, but still unstable. Clear? Similarly, this one is getting from one side, more stable than the 2 degree one, but still unstable. And this last person is not getting any electron, from any side. So this is a stable one. So order will be clear. Why it is 1 degree greater than 2 degree greater than 3 degree, and obviously CH3 minus is also 1 degree only, but I am writing it separately. Clear? Why it is 1 degree greater than 2 degree greater than 3 degree in case of carbon ion, and in case of carbocation it is 3 degree greater than 2 degree greater than 1 degree. Very very important. Here it is 3 degree greater than 2 degree greater than 1 degree greater than CH3 positive. Clear? And in case of carbon ion it is just ulta. Understood? Carbon ion stability order understood? Any doubt? So you are going to explain it on the basis of plus I effect. Clear? Simply plus I effect you are going to discuss about. Okay. Next, if you find out benzyl carbon ion, that I am not doing, that you can do, no problem with that. Next, a little small topic is there, that is called carbene. Not very much needed, but a very small topic called carbene. Okay, a small topic, carbene. Quickly let us discuss carbene. See here, carbene is basically a neutral carbon. Okay, neutral carbon. That means carbon will not have positive or negative charge. Neutral carbon, in which carbon will be bonded to two neutral groups. Okay, to two monovalent atom. It can be an atom or it can be a group. Clear? And this neutral carbon will carry a lone pair of electron. Did you understand? Two keywords are there. Bonded to two monovalent atom and carries a lone pair of electron. So 2 points are there to be noted. Lone pair of electron will be there and will be bonded to two monovalent atom. Okay, clear? Now this carbene is generally produced either by photosynthesis or by pyrolysis. That is pyrolysis actually, whatever you say. By pyrolysis or pyrolysis. That means cracking, breaking down. You know, right? Breaking down of alkenes at high temperature. Clear? Now this carbene is of two types. One is a singlet. If I am drawing the orbital structure, then I will get two type of structure for carbene: singlet structure and triplet structure. Okay, just memorize this structure because carbene is not usually asked. Singlet structure for carbene. If I am drawing a singlet structure for carbene, then the carbon is here this way, orbital diagram, you know, right? This way two electrons are there, rest two orbitals are empty, and here there is two bond. So what hybridization will be this? You can see one bond, two bond, and this. So it is sp2 hybridized. Clear? One sigma bond, one lone pair. So sp2 hybridized. Hybridization you can find out, right? Sigma bond plus lp. So sigma bond plus lp. So 2 sigma 1 lp. sp2 hybridized. This is 3. Clear? This is singlet structure. Now if I come to triplet structure. Then the structure a little bit change. How? One like this. Clear? Let us shift it properly. Let's draw it a little bit properly. Triplet structure, one this way, another one this way, two below empty, this side R and this side R. So hybridization is SP. That means linear shape. Clear? Linear shape. Clear? So what is the shape here? Linear shape. What is the shape here? Trigonal, planar. That's all you need to read from carbene. Nothing else. Carbene is generally not asked at all. Okay. Okay. Next we are going to go to the reaction part, which is an important part. Okay. Now we are moving on to the reaction part, which is very, very important. Okay. First we need to know about different attacking reagent. I think I have already told you before a little bit about attacking reagent. Now you see, whatever reactions occur in organic chemistry is initiated by some or the other attacking reagent. Some or the other attacking reagent has to work. Clear? Whether it is a electrophile or nucleophile, or a free radical, but attacking reagent usually it is going to work for a simple reaction. Clear? Now we need to know about two types of attacking reagent, which is going to be called as electrophile and nucleophile. So first let us know about electrophile. Number one, electrophile. Phile means loving, electro means electron. So electron loving attacking reagent is called electrophile. Understand, if it is loving electron, then which section will it attack? The part where there is no electron. That means a deficient center. It will attack that part. Electrophile is electron loving center. Electrophile is electron loving center. So if it is electron loving species, so if it is going to love electron, where will it attack? It will attack that part where there is already electron. So it will attack the electron rich center, because itself it is not having electron. Clear? So electrophile means electron loving. So they are not having electron deficient. So they will attack the electron rich center of the molecule. Clear? Where they will attack? The electron rich center of the molecule. Electron rich center of the molecule. Alright? Clear? Let's write down. Electrophile, reagents, these are actually reagents, okay? Reagents possessing a deficiency of electrons. Deficiency of electrons. These reagents attack on the electron rich center of a compound. Electron rich center of a compound. There are two types of center: electron deficient center, electron rich center. So they are going to attack on the electron rich center of the compound, because they are itself electron deficient. So they need electron. So they will attack the electron rich center of the compound where there is already electrons present. Clear with this? Right. Now, how will you see and understand which one is electrophile and which one is a nucleophile? Electrophiles generally has a plus charge on it. So all plus charges are generally electrophiles. Clear? So let us write few example of electrophile. Example of electrophile: H plus, very common electrophile. CH3 plus, electrophile. NO2 plus, electrophile. Cl plus, electrophile. Though Cl plus you will get very less, but these are all electrophiles. Clear? Now, these are all charged. If I write neutral electrophile, BF3, LCl3, these are all neutral electrophile. Now you will say, how it is an electrophile? See, BF3 boron does not have complete octet. Count, BF3 boron does not have complete octet. What about that? Boron does not have complete octet. It has 6 electrons in its outermost shell. Check. It has 6 electrons. Where about 2 electrons? So it is also electron deficient. So if it is electron deficient, they are going to be nothing but electrophile. Clear? BF3, LCl3, these are all electron deficient molecules. So they will be acting as electrophiles. Done? Understood? Okay, next. Electrophile done. Next, other than electrophile, we have another type of attacking reagent, that is called nucleophile. Nucleophile means nucleus loving. Nucleus loving. Who is a nucleus? What charge does a nucleus have? Positive charge. So positive charge loving. That means it will attack that center where there is electron deficient. So if if it is attacking the electron deficient center, then itself must be electron rich. So nucleophile are electron rich. So they will attack the electron deficient center. Clear? So nucleophile, they will have deficiency of electron? No. They will have excess of electron. So write down reagents possessing excess of electron or excess of electron, that means electron rich. Clear? Next point we will write this reagents attack on the where electron deficient center, electron deficient center of a compound, electron deficient center of a compound, electron deficient. Clear? Electrophile means electron loving. Electron is negative, so it will attack the electron rich center, negative loving, and this is positive loving. Clear? Negative loving, positive loving. Electro means negative and phile means loving. So negative loving. So negative loving means electron rich center. For nucleophile, nucleus is positively charged. So positive loving. So it will attack the electron deficient center. Now come to the example. Example, OH minus, the most common nucleophile you will get is OH minus. Other than that, Cn minus, OR minus, water, a very strange nucleophile. H2 will not understand the nucleophile, but actually H2 is a nucleophile because H2O has lone pair. Similarly goes with ammonia. One lone pair is present, so automatically it is electron rich. Clear? Lone pair present in water. That also two lone pairs are present in water. So obviously it is electron rich. Ammonia has one lone pair, so it is also electron rich. So all electron rich species, they will act as nucleophile. Clear? These are all neutral nucleophile. Understood? Nuclear attacking reagent understood. Now we will be learning about few types of reaction and their mechanism. Okay, few types of reaction and their mechanism. Okay, what questions come is, questions come based on identify the type of reaction. They will give you a reaction, you have to understand what type of reaction is. Electrophilic substitution, nucleophilic substitution, addition, beta elimination, this type of things they will ask you and you have to understand. So first thing we are going to discuss is nucleophilic substitution. What we are going to understand? Nucleophilic substitution. So the first topic we are going to take up is nucleophilic substitution. Now first try to understand from the name what does it mean. Acha, substitution reaction means some atom will be substituting one atom in a compound. Like I am giving a simple substitution reaction. CH4 plus Cl2. What happens? This Cl comes in place of hydrogen. So it becomes CH3Cl plus HCl. So Cl has simply replaced one hydrogen. But this is not nucleophilic substitution. This is free radical mechanism that I will talk about later on. Okay, I just give an example. Cl2, one Cl is taking place of one hydrogen. So this is substitution. So substitution means one atom will replace another atom in a compound. Right? Now nucleophilic. That means there will be somehow a nucleophile which will be doing the substitution. Who will be doing the substitution? The nucleophile will be doing the substitution. So nucleophilic substitution means the attacking reagent is a nucleophile. Clear? So here the attacking reagent is a nucleophile. Attacking reagent is a Nucleophile. That you can understand from the name itself. Nucleophilic substitution. Now, nucleophilic substitution can occur in two different ways. Either by SN1 mechanism or by SN2 mechanism it can occur. Understand it. Either it can occur by SN1 mechanism or it can occur by SN2 mechanism. Different mechanism. Two mechanisms are there. Both the mechanisms are useful in their own way. Clear? Now, first let us discuss about SN1. Then we are going to discuss about SN2. Achha, before we go for SN1, SN2, let me just give you a quick example of what exactly is a nucleophilic substitution, not the mechanism. I am telling you about an example right now. Suppose I have, let us take CH3, Br, CH3, CH3, right? If I give you here instead of this NaOH, so this part you find out that OH is acting as the nucleophile. OH will be the nucleophile, right? OH is going to be the nucleophile. Actually, it's not supposed to be NaOH, it's supposed to be aqueous KOH. Okay, NaOH won't actually do it. So let me write aqueous KOH. So K plus will be the KOH. I can write it as K plus plus OH minus. So OH minus is the required nucleophile. So who will actually attack? The entire KOH will not attack. The OH minus part will attack. Right? OH minus part will attack. So instead of aqueous KOH, they can write in the question directly OH minus. Because actually the attacking is being done by OH minus. Right? So who is doing the attack? OH minus. Where it will do the attack? Over here. Because the Br will leave this. In the SN1 mechanism I will tell you, the Br will leave there. So OH minus will attack this carbocation that will be formed over here. Okay. So OH minus will attack this center because this is the electron deficient center. So as a result, the compound that will be formed will be CCH3 CH3OH. Clear? And KBr will be outside. Understand it? Clear? This is the SN1 mechanism reaction. Another case is SN2 mechanism reaction. So first let me discuss about SN1 mechanism reaction. SN1 mechanism reaction, first of all, it is valid for 3 degree greater than 2 degree greater than 1 degree. This is the major part that you need to remember. SN1 it is 3 degree, 2 degree, 1 degree. SN2 it will be opposite, 1 degree, 2 degree, 3 degree. Okay. This is the first thing that you need to remember, that it is for SN1 3 degree, then 2 degree, then 1 degree reactivity order. Okay. So how does it occur? Example that I have taken previously, I will talk about that only. CH3 C CH3 CH3 Br. This was the reaction. Reaction with OH minus, I got CH3 CCH3 CH3 and OH. Right? Now what happens is step number 1. In step number 1, what happens is the carbocation will be formed. What happens is formation of carbocation. First step is formation of carbocation. How? Carbocation will be formed by CH3C CH3 CH3 Br. Right? Br being more electronegative will cause heterotic bond fission. So Br will take the electron. This I have already told you. So resulting will be CCH3 CH3 carbocation formed over here plus Br minus. This is the first step that happens. So you can see a carbocation is being formed. So the OH will be attacking the electron deficient center. So resulting formation is the OH minus. Second step, I do not think I need to tell you anything. Second step, CH3 CH3 carbocation OH minus attacking this center to form CH3, CH3, OH. Clear? So this is basically the SN1 mechanism. So you can see in SN1 mechanism, firstly there is carbocation formation, second step there is the substitution, right? Now come to SN2 mechanism reaction. You will see SN2 mechanism reaction is a little bit different from SN1 mechanism reaction. Little bit different. Concept is same, but you will find it is a little bit different. How? Let us understand. Now come to SN1 clear. Now moving on to SN2 mechanism reaction. SN2. Understand SN2. For SN2, it is ulta. 1 degree, 2 degree, 3 degree. SN2 mechanism, 1 degree greater than 2 degree greater than 3 degree. SN1 mechanism reaction, 3 degree greater than 2 degree greater than 1 degree. Done? Now, so let us take the example CH3Br. Since 1 degree, so I have taken CH3Br. Any problem? Any problem? No problem. CH3Mg, CH3Br. Right? If I react this with OH minus, OH minus. So I have written OH minus. That does not mean that it is only OH minus. That because only OH minus you cannot get. Actually, it is aqueous KOH. Okay. This will result in the formation of what? This will result in the formation of what? Nothing but an alcohol. So it will result in the formation of CH3OH. This is an alcohol. Methanoic acid. Right? But methanoic acid. Methanol. Clear? It will result in the formation of methanol. CH3OH. No doubt. But how it is happening, we need to know that. So the mechanism of the reaction we need to know. Step 1, step 2 does not happen. The reaction happens in one step. How? CH3, this is the mechanism, okay? Mechanism. How you understand? CH3Br is there. Very good. OH minus is there. Okay. Achha. Br will take all the electron towards itself. That you already know. So CH3 will develop a positive charge. So OH minus will attack CH3 center. So CH3 center. Now what happens here is a transition state is formed. What is formed? A transition state forms. That means, understand, CH3 carbocation is not yet formed. Carbocation is not yet formed, but there is a case where carbon has 3 hands. Right? CH3 means carbon has 3 hands of hydrogen and 1 hand of Br. So a transition structure of 5 hands of carbon is formed. That means একদিক দিয়ে OH বেরোবে, আরেক দিক দিয়ে Br একদিক দিয়ে Br বেরোচ্ছে, আরেক দিক দিয়ে OH ঢুকছে. That will be shown there. Clear? So we are doing it in one step. You can see we have not formed any carbocation, then we are doing. Otherwise it is becoming SN1 mechanism reaction. But we are not doing SN1 mechanism. We are doing SN2 mechanism. So SN2 mechanism, a transition state. A transition state means it's just unstable. So we will be representing it by third bracket. Okay. What happens is C H H H. These are all okay. Now you understand. If these are the 3 hydrogen, I am not writing, but it is a hydrogen. Okay. If Br is going to leave from this side, let us take Br leaves from this side. Okay. Br leaves from this side. So OH will attack from this side. Correct? Now imagine if Br leaves from this side, then OH will attack from this side. So there can be 2 possibilities of answers, 2 possibilities of products. One, OH can be this side, one time OH can also be this side. So there will be 2 products. That means the answer will be a racemic mixture. What mixture? Racemic mixture. Racemic mixture means combination of 2, 50-50 percentage. Clear? Okay, Br can leave from this side as well as Br can leave from that side. So the product will be racemic mixture. Okay, but that term I will not use right now because that term I have to use somewhere else. So that time I will tell you. Okay. Achha, this is clear. Any doubt? Any doubt? No doubt. Forget about racemic mixture. Later on I will tell you about that. Okay. Later on I will tell you about that. So what I was talking about, Br will be leaving from this side, and from one other side OH minus will be entering, right? So I have to show that by this type of bond. I cannot show it by straight bond because five hands are not possible, no. So one side I have to show that OH is entering, another side I have to show that Br is leaving. So this is called transition state, which is highly unstable. Transition state which is highly unstable. Clear? So immediately in the next step I will get to see that CH, this side I will see OH has entered and Br has already left out. Clear? Understood? Any doubt? No doubt? Clear? 3 degree what happens? There is a crowd of atoms, right? CH3, CH3, so much crowd is there. Steric hindrance will apply, so this will not happen. Okay? Clear? Any doubt? Any doubt? No doubt? Done? Okay, clear? Clear to everyone? So this is SN1, SN2. This is nucleophilic substitution. Next what we are going to learn about is electrophilic substitution. Nucleophilic done. Nucleophile means you understood. Now next we are going to do the electrophilic substitution. Electrophilic. That means electrophile will attack. This time nucleophile attack. Next time electrophile will attack. So let us see electrophilic substitution. So in nucleophilic substitution, the attack was by a nucleophile which was substituting. Now we will see the attack is by a electrophile that we will call as electrophilic substitution. Okay. So now we are going to see electrophilic substitution reaction. Electrophilic substitution reaction, where the attack will be done by electrophile. Clear? So who will attack? Electrophile will be attacking reagent. Attacking reagent will be the electrophile. Clear? The reaction takes place in 3 steps. Step 1 is the generation of electrophile. Okay, let us change the color. Step 1 is the generation of electrophile. I need to form the electrophile, right? I will not be given the electrophile. I have to form the electrophile from a given compound. So first is formation of electrophile or generation of electrophile. Step 2 is the formation of carbocation. The formation of carbocation intermediate, where the electrophile will attack is a carbocation. So carbocation intermediate. Step number 3, removal of proton. Step number 3 is removal of proton, and removal of proton will give you the required product. Okay, now let us understand what exactly is going on with the help of an example. Okay, see here, benzene 2, benzene 2, toluene using AlCl3. Benzene to toluene using AlCl3CH3Cl. This you have to remember. The reagent which you are using, that you have to remember. So when you are going from benzene to toluene, you are using the reagent AlCl3 and CH3Cl. Clear? So let's now understand that what exactly is happening. So step 1. Step 1. What did I say? Step 1, generation of electrophile. So see here, CH3Cl plus AlCl3 will form, this Cl will come here as Cl minus, and this AlCl3 FeCl3, they take up an extra chlorine and get a minus charge. Okay, so they can form AlCl4 minus plus, they will form CH3 plus. So you can understand that this CH3 plus percent is actually the electrophile. This percent is the electrophile. Right or wrong? So this percent is the required electrophile. So who is going to attack? This required electrophile will attack. Second case, we have seen formation of carbocation intermediate. So formation of carbocation intermediate means of this benzene must be the attack will be. So how does the benzene look like actually? Like this. So on the benzene CH3 plus, if I attack, let us check that this bond breaks. This is minus. Okay, this is minus, this is plus. So it will not attack the plus side, it will attack on the minus side. So minus side it will attack, like this it will attack, right? So let us take the attack this side, minus side. So this way it will attack, right? So attacking on this side, I'm showing like this. Clear? Attacks. So moment it attacks, what happens is this, and one hydrogen was already there, two hydrogens are there, already one hydrogen was there. Actually one hydrogen is only there because our bond is there, no? Clear? Acha. So if this is going to happen, then there will be a positive charge. If this is going to happen, then there will be a positive charge over this side. No doubt about this, because negative charge was that side. Now this positive charge will undergo resonance. So I will not show all the resonating structures because you all by now have learned resonance. I will just show the resonance hybrid. How does the resonance hybrid look like? This dotted structure plus, because dot plus will come till here, the hydrogen and CH3. This is the step number 2 where there is electrophile attack. Last step is the deprotonation, right? So what is deprotonation? Deprotonation actually means the removal of hydrogen. So hydrogen, how can you remove? Hydrogen will donate only electron to here, so that part will become minus and a plus is already over here. As I have already told, the plus can travel here, here and here. So plus is here also. So plus minus will form one bond. It will or not? It will. It will form a bond, right? So plus minus forms one bond. So the actual structure becomes this. The CH3. Clear? This is the actual product. That's a toluene that we have written already. Mechanism understood? Mechanism understood? Clear? Now, H plus is giving the electron, then must be something is taking up that H. The H will not go as H outside. So who is taking up that H? This AlCl4 minus is taking up the H. So here I will write AlCl4 minus. This H is coming to AlCl4 minus. So not only toluene, but toluene's byproduct will also be formed, and those byproducts are very necessary to be written. Here you see the byproduct. AlCl4 minus is not the actual compound, right? What is the actual compound? AlCl3. So AlCl3 will be formed, and hydrogen will go with the other chlorine. So HCl will be formed. Done. So AlCl3 plus HCl. This is the final product that you have to mention in your answer. Clear? Done. This is the way the mechanism is done. Many others are there: Friedel-Crafts acylation, alkylation, chlorination, sulfonation, bromination. All these mechanisms take place by electrophilic substitution. Okay. Next one homework I am giving you to try out the mechanism of this reaction. This is chlorination of benzene. Okay. This is chlorination of benzene. Try it out and tell me. Okay. Another one you can try out. This is homework number 1. Homework number 2. Homework number 2. Okay. Along with byproduct, you are supposed to write the answer. Clear? This ends the electrophilic substitution. Now we will be discussing about free radical substitution. Free radical substitution. Till now we have seen carbocation, carbanion attacking. Now we will see free radical how it is substituting. In class 10 you have done this reaction. CH4 plus Cl2 forms CH3Cl plus HCl. Actually CH3Cl is not the only product. CH3 double bond CH3 Cl2 are all products as well. But we are focusing on the major product. So we do not write all that. Clear? There are 3 steps over here. Step 1 is the initiation step. What is step 1? Step 1 is the initiation step. Step 1 is called initiation step. Okay. In initiation step, the Cl, they will be homolytically breaking to form 2Cl free radical. Clear? First step was initiation step. Done. Initiation step done. Second step is called propagation step. Second step is propagation step. In propagation step, what happens is CH4 was there. So CH4 looks like this. Cl attacks. So this hydrogen and this carbon takes 1 electron each. So what will be the formation? Formation will be this. Right? So this is the formation CH3 dot. Now this CH3 dot will attack another Cl. This Cl will homolytically fission. This Cl will come up over here. So what will be formed? CH3Cl plus Cl dot. Clear? So you can see how it is happening exactly. This was the propagation step. Lastly, we have the chain termination step. Termination. That means the last time whatever free radicals are there, they will merge with each other and terminate the reaction. So free radical number 1 was Cl plus Cl. So whatever Cl plus Cl will be left only from Cl. Whatever CH3 dot plus CH3 dot is there, they will form CH3 double single bond CH3. Done. So that CH3Cl is not the only product. Other than that also you are getting products. But we will not focus on that much product. We will focus on only on the major product. Clear or not clear? Any doubt? Doubt is there? Very good. Now we are going to move on to the next type of reaction. This is not a mechanism, this is a reaction. Elimination reaction. Elimination reaction. Elimination reaction. Now, from the name you can understand that you are eliminating someone. From a reaction, you are eliminating someone. So, elimination means exactly what you are thinking, that is, you are removing someone from one compound. Correct? Now, what you have to take care of is whether it is alpha or beta or gamma. That means whether it is from the same atom, whether it is from the adjacent atom, or whether it is from alpha and gamma position, means leaving another atom. Clear? So that you have to take care of. So let us understand first alpha hydrogen. Alpha elimination, alpha hydrogen, alpha elimination. Alpha elimination. See here. In this reaction, both proton and leaving group. Leaving group means that group which will actually go out, which will actually be eliminated. Okay, so leaving group are on same atom. So from same atom it will be removed. Same atom. Clear? This is called alpha elimination. This alpha elimination usually gives rise to called carbene. usually gives rise to carbene. As I have already told you about carbene before, gives rise to carbene. Clear? Alright. So what happens exactly? Let's take CHCl3. What is this? Chloroform. CHCl3 is chloroform. If I give alcoholic KOH, what will happen? If you don't remember, I'm writing it. This is chloroform. What will happen if I give alcoholic KOH? HCl part is supposed to go out, right? One HCl part is supposed to go out. So exactly if I write the structure, then I will get somewhat this structure, tetrahedral structure. So this way, to this OH minus will attack, K plus will not do anything. So OH minus will attack where? This percent will attack. So if this percent will attack, it will form what? This way, something like this. Right? Now, K plus is there to remove the Cl minus as well. So one Cl minus will also go out. Only H plus will not go out. Living group has to go out. So one Cl minus will go out. So as a result, left out will be this. So this is a carbene. Clear? Understood? Alpha is usually not seen. Okay. Beta is the most commonly used, and you will get it 1000 times here. Next is beta elimination. Alpha elimination clear. Now we are coming to beta elimination. In beta elimination, proton and leaving group are on adjacent atoms. Clear? Not on the same atom, on the adjacent atom it is there. Okay, let us take an example. CH3, CH2, CH2, Cl. If I give alcoholic KOH, what will happen? Cl gone, it needs a hydrogen. Cl gone, it needs a hydrogen. That hydrogen, it will get from which atom? That hydrogen, it will get from which atom? It will get from this atom. If it cannot get from this atom, then it will become again alpha. Beta means it has to get from the next atom, so it will get from here. So if it is getting from here, then you see what will happen. CH3, CH, double bond, CH2 plus KCl. Any doubt? Any doubt? Plus water will also be there. That is a different thing. So did you understand why double bond is formed? Double bond will be formed because hydrogen is removed. So carbon will get a negative charge and this carbon will get a positive charge. Positive negative will form a double bond. Has to form a double bond. Clear? This is beta elimination. Last one is gamma elimination. That is also very least required, but still we have to say. Acha. Alpha one is also called 1,1 elimination. Okay. Just remember it is also called 1,1 elimination because from the same atom it is done. Beta elimination will be called as 1,2 elimination because from adjacent atom it is done, and gamma elimination will be called 1,3 elimination because leaving one atom it is done. Okay. So here proton and leaving group are on alpha and gamma position. Okay. See here CH2, 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 Br. This is what? Dibromopropane. Written like that because the structure will form like that. Dibromopropane. Okay. Now here in dibromopropane, if we give zinc dust, this takes place only in the presence of zinc dust. Please remember. If we give a zinc dust, then CH2, CH2, CH2. This will be formed and J Br2 will go out. Exactly. Clear? Understood? Nothing. This Br bond will break. This is for Br virus. This Br virus will attack over here, and this will again go out as Br virus. This is the case what is happening. Clear? Understood? This is the elimination reaction over. Elimination reaction over. Okay. Next we are going to discuss about E1 elimination reaction and E2 elimination reaction. This in details not at all needed. Just I will tell you how much is needed. Okay. E1 molecular E1 elimination reaction. E1 elimination reaction. When I talk about E1 elimination reaction, I am writing 1. 1 means it is a unimolecular elimination reaction. Clear? It is unimolecular. Why am I saying unimolecular? Because if you see the rate of this reaction, then it will depend on only one molecule. That is the concentration of the substrate. So that is why it is called the unimolecular elimination reaction. Clear? Okay, so you need to remember that effect of leaving group. Now by now you know what is a leaving group. So effect of leaving group over here is Ri greater than Rbr greater than Rcl greater than Rf. Though Rf we will not usually use in the script. Clear? Understood? Okay. Effect of leaving group done. Order of reaction is obviously then 3 degree, 2 degree, 1 degree. Order of reaction is 3 degree, 2 degree, 1 degree. Clear? Because 3 degree carbocation maximum stable, 2 degree, then 1 degree. Okay. And last one, rate of reaction proportional to, this is concentration symbol. Okay. This symbol is for concentration. I am writing in bracket. This equal to concentration. So concentration of the substrate. Clear? So this is why it is actually going to be called as unimolecular elimination reaction. Okay. Next is E2. I am just telling how much is needed. This is actually not at all very important. E2 elimination reaction. So what will be E2 elimination reaction? Obviously bimolecular. That means rate determining the rate of reaction will be depending on two different things. This is a bimolecular elimination reaction. If it is a bimolecular elimination reaction, it will rate of reaction proportional to nucleophile, that is attacking reagent, and concentration of substrate. Clear? Nucleophile, that is attacking reagent, and concentration of substrate. Both of these will be checking out the rate of reaction. Okay, and the order remains same: Ri, Rbr, Rcl, Rf. Done? Clear? Oh. Now let's move on. Let's move ahead of this. Let me give you a quick question. This alcoholic KOH, you must know what it does. It does, right? You all know. You have done in class 10 about alcoholic KOH. So nothing new about alcoholic KOH you're going to do over here. Let's see the question. If I give the question CH3 CH2 Br, and I am giving you alcoholic KOH, what will be the product? The only and only product possible is CH3. From here Br gone, right? From here one, this is actually H2, so HBr will be taken away by alcoholic KOH. HBr should be taken away, right? So if HBr is taken away, the next product will be formed. Now that is my bad, I told you it is single bond. That should not be a single bond, obviously, otherwise it's not possible. Okay, leave. I have gone bad. Never mind. Leave whatever I have said. CH3, CH2 Br is your compound. Alcoholic KOH you are giving to it, and you are trying to form the product. What will you form? H3 means one H is over here and two H over here. So this H and this Br will go. So remaining will be CH2, double bond CH2. So this will be formed. Plus KBr will be formed. Plus water will be formed. Right? No doubt that you get this is the answer. Now, if the question is somewhat this CH3, CH2, CH, Br, CH3, giving you alcoholic KOH, what will be the answer? Think and tell. What will be the answer? Acha. Someone can say, wait, without the color. Acha. Someone can say that this is the answer. CH3, CH2, CH, double bond, CH2. I cannot deny. Now, someone can also say that this can be the product. CH3, CH, double bond, CH, single bond, CH3. Then that person also I cannot deny. So I am getting two answers which can have the which can be the product. So which one will be the product out of these two? That I have to decide. Who will decide? I cannot decide. You cannot decide. Then who will decide? There has to be someone, some rule which will decide which one is the major product, which one is the minor product. And that rule is called Side-Jeff rule. Okay? That rule is called Side-Jeff rule. So what is the name of the rule? The name of the rule is Side-Jeff rule. Side-Jeff rule. According to Side-Jeff rule, what you have to note down is Side-Jeff rule states that the product which will be more alkylated, will be more alkylated will be the major product. Will be the major product. Now, alkylated. Who will be alkylated? The double bond containing the double bond will have two carbon on two sides. Those two carbon must be maximum alkylated. So product which will be more alkylated actually means what? Which will be more alkylated. This one. Actually, what does this mean? The carbon which contains double bond will be more alkylated. The carbon containing double bond. Okay. Not everywhere. The carbon containing double bond only. That also you have to note down. Okay. Clear? So that product will be preferred which will be more alkylated, and that will become the major product. So now check and tell me which one is the major product, which one is the minor product. Here you see double bond containing this one. So this side I am getting one ethyl, this side nothing. And here you see double bond is over here. This side I am getting methyl. This side also I am getting methyl. This I am getting only ethyl. So who is more alkylated? Don't say that ethyl's power is more than methyl. Two methyls are there. So who is more alkylated? Obviously number B. So who will be the major product? Number B. So whose one is correct? The second person's one is correct. Clear? This will be the major product and this will be the minor product. Clear? So there are two products, but when you are writing in the reaction, you have to write the major product. Clear? Understood? Very good. So this is Side-Jeff rule which you have to keep in your mind. Next we are coming to addition reaction. What are we coming to? Addition reaction. Now, what is an addition reaction? I need not need to say, nor I will write. You know what is addition reaction and who shows addition reaction. So nothing new about addition reaction has to be told to you. I am going to straight go to electrophilic addition of alkene. Electrophilic addition to alkene. Electrophilic addition. Electrophilic addition to alkene. Okay. Electrophilic means attack will be by electrophile. Addition means there will be bond breaking. Clear? Now how exactly that is happening, you have to check it out. See here, any sort of halogen if you are trying to add, yeah, remember in class 10 we used to do CH2 double bond CH2 in presence of Br2 CCl4 gives CHBr single bond CHBr. This type of thing we used to do in class 10. But how exactly it is giving, that you have to see. Okay? Okay? Now see here, CH2 double bond CH2. If I give Br2, only Br2 I cannot give, CCl4. So that will form CH2Br, again CH2Br. But how exactly, that I need to see over here in class 11. Okay? See here, nothing very here and there. Just you have to see Br. If see here, if I for Br plus, then what will happen? Br is having lone pair. Definitely yes, Br is having a lone pair. Br's lone pair containing electrophiles are called non-classical carbocation. Remember, what did I just say? I said lone pair containing carbocation are called non-classical carbocation. Are called non-classical carbocation, and the remaining, those who do not have a lone pair, the carbocations not having a lone pair are the normal carbocation. This is a classical carbocation, but these are non-classical carbocation. So whenever there is a non-classical carbocation, there will be no shifting. Now what is shifting, I will not discuss about that because that is not actually a part of our syllabus. There will be no shifting, and a ring-like structure will be formed in case of non-classical carbocation. In case of non-classical carbocation, ring structure will be formed. Okay? So let us do. See here, CH2, CH2. Right? When I am passing Br with it, so there will be a ring-like structure formed, but before the ring-like structure forms, there will be pi complex. What is exactly a pi complex? Nothing. This is CH2 double bond CHH. Pi complex is basically Br. One Br plus, one Br minus. So Br plus will be bonding, and to this Br plus we have Br negative bonding, like this. This structure is called pi complex. Now in the next step, this pi complex will be forming the required ring structure. How? This C will remove that bond and the Br will come and get attached like this. This will form H, 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 H. Clear? This is called non-classical carbocation, how it is going to attach. Normally the carbocation does not attach like this, but non-classical carbocation attaches like this, and that you have to understand how it is going to attach and why exactly is happening, that also I will be telling you. See here, one step I am showing you. The Br, if you remember, the double bond has broken. So if it has broken, it must be one carbon is positive charge, one carbon is negative charge. So do the negative charge Br attached, Br plus, Br attached, Br attached, Br attached. This Br, where it is going to attach, this lone pair is going to donate to this person. So they are forming a bond and Br is getting a plus charge. This is how the Br plus triangle is formed. Clear? So this will form actually Br plus, this way. Understood? Where did it come from? This way it is coming from. Done? Now, if you remember, a Br minus was also there. A Br minus or a Br del minus, whatever you take. That Br del minus will be attacking this person. Where will it attack? Tell me. Where can Br del minus attack? Definitely not on Br. It will attack on that position where it is mostly stable. So it will attack at this position, or that position also it can attack. That is not the problem. Here it will attack, most stable over there. So the resultant will form Cbr H H C Br H H. Clear? So this is the ultimate product which you have to write. This is the mechanism how it is forming. The pi complex part is very important for you all to know. Clear? Done? This is electrophilic addition to alkene. Next we are going to come to addition of halogen acids. That is very important. This is the last part, addition of halogen acids. Addition of halogen acids. Now you see, what exactly is happening in addition of halogen acids? Symmetrical to no problem. Problem comes in unsymmetrical compound. Suppose I give you CH2 double bond CH2 and I tell you add HBr. Very easy. What is the problem? CH2 Br and CH3. That opposite also equal to no problem because they are same thing. But if I give you a compound like CH3 CH double bond CH2 and I tell you add HBr, then what will you do? You can someone can write CH3 CH CH3 Br. Okay, someone can write CH3 CH2 CH2 Br. Now who's one to take? Again, to decide on this, we have got a rule. That rule is called Markovnikov's rule. What rule? Markovnikov's rule, which will rule out this product. This is not the correct. This is the wrong product. But this is deciding on what? This is being decided on what? It is being decided on the Markovnikov's rule. Clear? So first let me discuss what is Markovnikov rule. This is major product and this is the minor product. Okay? So let's discuss on Markovnikov rule. I will be writing in short. In book you will get a better version of Markovnikov rule. I am just going to mention the main thing about Markovnikov rule. Markovnikov rule. Markovnikov rule. According to Markovnikov rule, the negative part of the addendum, please read, negative part of addendum. Who is the addendum? Addendum means who is getting added. HBr is getting added. So that is addendum. Okay. What is addendum? Substance getting added. Clear? Substance getting added. So negative part of the addendum will attach. Negative part of addendum will attach to the carbon containing least number of hydrogen. Least number of hydrogen. Clear? So negative part of addendum will attach to that carbon which has least number of hydrogen. Understood? So least number of hydrogen attached to that carbon. Okay, this is Markovnikov's rule. Another rule we will come across is the anti-Markovnikov's rule, which is just the opposite of what you have learned for Markovnikov rule. So I don't think I have to write it again for Markovnikov rule. Anti-Markovnikov rule, because it's just the opposite of Markovnikov rule. Okay, clear? Okay, so maximum number of hydrogen if it is there, it will be anti-Markovnikov rule. Markovnikov rule, least number of hydrogen. Clear? So see here and you can understand which one is the major product. I hope I don't have to say anything. Clear? Then if you go for mechanism, then you will find it is proceeding through carbocation formation. Okay, it is proceeding through carbocation formation. Then mechanism I am not showing you because it's not needed right now. If you want to see, you have your textbook, you can go and refer it to it. Clear? See the Markovnikov mechanism is not required. Anti-Markovnikov I have to show. Clear? Okay, this will proceed with carbocation. There you will get carbocation stability where 2 degree will be more than 1 degree, obviously. So that is more stable. Clear? Actually the carbocation is over here. No, here carbocation, here carbocation. This is 1 degree, this is 2 degree. Which is more stable? 2 degrees. So 2 degrees is a major one. Okay, very simple. Now come to Kharash peroxide effect. Anti-Markovnikov rule, also called Kharash peroxide effect. Scientist Kharash peroxide effect. And please remember that this is only and only shown by HBr. Because HF bond is very HCl and HBr bonds are strong enough. HI bond is too weak, it will not form HI, it will form I2PAC. So that is not possible. Okay. Oh, So please note down that it is only applicable for HBr. Only applicable for HBr. Intentionally the question will be given to you HCl H2O2, but you have to apply Markovnikov, not anti-Markovnikov, because that is not going to give you anti-Markovnikov. Clear? Now straight I am going to go for mechanism. Before that, let me give you the same question. The question was CH3CH2, CH3CH2 HBr, but this time along with HBr I will give you H2O2. So the product form will be CH3CHBr. No, this is going to not follow the Markovnikov rule. So it will be single bond CH2Br. Clear? This is going to be your major product, while the product that I was trying to make, this will become the minor product. Understood? Now let us come to the mechanism of this. Why exactly this is going to happen? Mechanism. See here. This is going to go by free radical mechanism. Clear? Acha. We will find instead of H2O2, it can be given as benzyl peroxide. What it can be given as? Benzyl peroxide. Actually, any peroxide works there. Usually, it will be given as benzyl peroxide. How does a benzyl peroxide look like? C6H5. In between the COC bond, again other side C6H5. Clear? So, I am showing it by benzyl peroxide. Step number 1. In step number 1, the benzyl peroxide structure is this way. See here, benzyl peroxide bond, then C double bond O, then C6H5, benzyl peroxide. Most unstable bond is over here. Can you locate? Most unstable bond is over here. Why? Because two lone pairs sitting together, it's very, very disturbing. Lone pair. Repulsion. So this bond will break. One electron. Remember, this is homolytic bond fission. Okay? Homolytic bond fission. So what will we form? C6H5, C double bond O, O dot. This will be formed into 2. Same thing, no? Into 2 it will be formed. Right? Okay. Now you understand. One thing you can do is over here. Electron donated, electron taken. Okay? 2 form, no? This 2 form, let me write the next step only. 2 form, what we did is C double bond O dot. O dot gave this electron, this bond gave 1 electron to this. What it will form? C6H5 dot plus CO2. Check. Correct? So ultimately it is going to form C6H5 plus CO2. That. Now, this was step 1. Step 2, free radical mechanism. Step 2, C6H5 dot will not stay at C6H5 dot. It will form HBr is there. In HBr, there will be homolytic bond fission. So it will form C6H6 benzene plus a Br dot. No doubt. Step 3, the last step. Second last step. CH3 CH2. Now I am adding Br dot to it. Now you see 2 ways it can be added. Now you tell me which is more stable. CH3 CH dot double bond CH2 dot. Okay, plus Br. What time I am adding Br over here? What time I am adding Br over here? Okay, fine. First time I am adding Br over here. That. Second time I am adding Br over here. So it will become this way. Any doubt? No. Now you tell me which one is more stable? This one or this one? This is a 2 degree free radical. This is a 1 degree free radical. Who is more stable? Obviously 2 degree is more stable than 1 degree. So which one becomes the major product? The first one becomes the major. That is why it is not following the Markovnikov's. This is the reason. There carbocation stability and this is free radical stability. Clear? There it was carbocation stability. Here it is free radical stability. Understood or not understood? Clear? Last step is the state termination step, where all the dots will be combining to form whatever compounds they will form. So CH3, CH dot, CH2Br plus HBr. Again the same thing, dot dot will form CH3, CH2, CH2Br. This way something will form. Clear? And the remaining CH3, CH2 dot. In presence of HBr will form the minor product, that is CH3, CHBr, CH3. Clear? Minor, major. This is the way you have to solve, and this is all you have to study from this chapter. This marks the end of GOC. Okay, in your book you may get a little bit more like polymer, what am I saying, isomerization, rearrangement, this type of reaction. These are nothing but just a theory based. You will see one reaction is there and you get it from the book that I am not saying. These are the most important things that you have to read from this chapter and that I have covered in this. Okay, so let's see which video comes up next. This took me how many days? More than 1 month to make this video. Anyways, hope you have understood the concepts in this topic. Let's meet in the next video, obviously, and check my channel sometimes, maybe any video can come. Okay, take care.